Right, I think. Are we ready? No, not yet. Yeah. Okay. So this is instead of the catch box, right?
Yeah,
For now.
we have both.
We have both. Okay, cool. So, uh, good morning. Welcome to the power management and thermal control session. Is this working?
Yes.
Okay, cool. Welcome to the power management and thermal control session. And the mic is off. Okay. Am I supposed to turn it on? Yeah, something missing. Still. All set? One, two, three? Nope. It should be working right now. So, not quite, I suppose. So do I need to take the other mic?
Can you try knocking on it?
Nope. Not working. Nope. All right, technical issues. So for just a bunch of like scheduling information. So I made a change to a session schedule yesterday evening. I'm not sure if it propagated to this conference schedule. But the problem is we lost a topic that was scheduled originally at the end of the session. So the change is like kind of cosmetic. So there is only one break now, which will take place at 11:30 along with the other micro conferences. So we are aligned, and we have the first part of the session will be thermal control, the other will be power management, so after the break.
Say that they don't have power.
Yeah, that's a known problem here since Tuesday. Oh,
Maybe they're stuck in runtime suspense.
yeah. Yeah, but the screens have power apparently. So the camera does. Okay. The podium doesn't. I love this. fortunately, we have time.
Somebody's dying.
Da ist geschwunden. Muss ich rufen, die ja.
Well, so the problem is that we don't have the people on the that is not here.
So here it looks like microphone. But you see it's being activated. It's just that the speakers
You mean this one? This only means that the mic on the laptop is working,
okay.
as far as I can say. But so if I'm next to the laptop, they can.
Also, we could maybe ask in the chat. So if it takes a longer time, we could just get in the front. And if they in the chat can hear us, then we could start without speakers.
Well, okay. So let's see. If it takes more than 5 minutes, then
I'm not in a hurry, just.
because when I wouldn't like to start moving things before, if they are able to fix it quickly. So. Well.
The laptop?
Yeah.
Oh, this.
Because the laptop is still battery now.
So again, the boxes, they don't have no electricity, so we're bringing extra boxes so that we can.
Oh, I see, okay.
Go just fly in this first presentation about Userspace. 3 points.
We have some feedback on Matrix. They say that all the mics are working. We can test this.
Yeah, so we could, okay. So,
Make a test like say mic number 1 here, mic number 2, and the Matrix people can answer which is actually responding.
all right, so we'll first try the mic at the podium. Can you hear me?
I can hear you.
You can hear me. Okay, cool. Now let's try the catch box, okay? Can you hear me now? Yeah. Well, so I guess we can just go ahead. All right. So I'll try to stand here, like close to the laptop. Welcome again. So let me first thank our sponsors. Without the sponsors, the conference wouldn't be possible. So thank you very much, sponsors. And now the code of conduct, which is also important. So we've all agreed to follow this. And then if you discuss something with somebody, please be civil. Do not go personal. It can be a heated discussion, but within limits. So please follow the code of conduct. With that, I think we can move to the content. All right, so I'm going to talk about changes in the thermal subsystem that I would like to make. Some patches have been sent already, so I'm going to say a few words about what's there in those patches and why I want to make those changes. So. But first, a bit of terminology for the people who may not be super familiar with the design of the thermal subsystem. So as I said before, the session is going to be divided in 2 parts. So the first part will be mostly thermal control. And then there will be a break, and after the break we'll switch over to power management. Yeah, so this is the idea. So first, the thermal control terminology that I'm going to use, and then Daniel is going to use. So this is like for the benefit of the first part. So we have thermal zones, which are basically a thermal zone represents a thermal sensor, and so if you are sitting at the end of the room and you can't hear me now, please move forward because we have audio problems. Those problems may or may not be fixed at one point, but
Probably we should remove this budget, they make so much noise.
yeah, but I can remove mine actually. That's a good idea. All right. So yeah, we have thermal zones, which represent thermal sensors along with some control and monitoring mechanisms like like trip points, like cooling devices and thermal governors. And so a thermal zone is a temperature sensor equivalent with a collection of things associated with it. One, two, three. 1, 2, 3. 10.
Hello, 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 hello. Yeah.
Okay, and
So.
this one? I think it will be working too. Is this working? No? Okay. Yeah, good. Oh yeah, now it's working. Yeah. Okay. Thank you. All right, so let me continue. Hopefully that's going to that's going to be the end of the technical issues for today. So the catch box is here. If you want to ask a question, please raise your hand, and then and somebody will throw this thing at you. Then, if the remote attendees have questions, please turn on your camera if you are able to do this, so we can see that you want to talk. All right, so let me continue. The zone temperature is the value returned by the thermal by the temperature sensor in the thermal zone. Thermal mitigation. So this is a term that we use for to say that something happens in order to decrease the zone temperature, right? So there are some actions carried out. Now there are trip points. Trip points are so a trip point represents two temperature values. Basically, one you can think of them as temperature watermarks. So if the zone temperature crosses one of them going up, then something happens. So thermal mitigations are triggered. If it crosses the other one going down, that thermal mitigations are stopped. So they are referred to as trip temperature and trip low temperature for your reference, and trip hysteresis is just the difference between the two. All right, so there are cooling devices. And cooling devices, so a cooling device in our language is something that can pull the zone temperature down. Basically, it doesn't have to. So just as much. And then this can be anything. This can be a fan. This can be some code that will throttle some devices and something like that, right? Cooling states are the levels of activity of a cooling device. So state zero means no cooling, state 1 and so on means that the level is high, up and up. All right, and then there are thermal instances. So a thermal instance is a connection between a cooling device and a trip point. So the idea is that when a trip point is crossed, some cooling devices will be activated, or their cooling states will be bumped up. And so there needs to be a way to associate cooling devices with trip points, and this is done through thermal instances. So the thermal instance is just a link between a trip point and a cooling device. And there are thermal governors, which represent thermal mitigation algorithms associated with thermal zones. So the idea again is that a thermal zone, there should be a thermal governor associated with a thermal zone that will manage the cooling devices and so on. But there are cases in which there are tripless thermal zones, so you can register a thermal zone without trip points and without anything else. So it's just a sensor that can be read through SysFS, and and this is the simplest case, and all of the other cases are possible going up. Like you can have trip points, you can have cooling devices. There may be trip points without cooling devices, and so on and so on. There can be zones without governors. In the most complicated case, a thermal zone is a thermal sensor with a set of trip points. With each of them is associated with a set of cooling devices, and there is a thermal governor that manages all of that. All right. So, okay. Now, I will talk about the changes that I would like to make, like one by one. And the slides are done in a way that, so if you download the presentation, the links are active, so you can just click on them and see the patches, actually, if there are patches. But for the most of the points on my list, there are patches. All right, so first of all, today, so I should probably say that the thermal core subsystem has been undergoing some reconstruction for some time, and mostly to improve the handling of trip hysteresis, but also other things, simplify code and so on. And this is the continuation of this. So at the moment, the thermal instances are all hooked up to at least in a thermal zone object. So all of the thermal instances for all of the trip points in a thermal zone hang off at thermal zone. So, for example, if you know a trip point and want to find a cooling device and want to find a thermal instance for the tool, and you may want to do that because the thermal instance contains information like what cooling state of the device to use for the trip point. Then you have to walk all of the thermal instances for all of the trip points. That's like not very nice, let's just say. So the idea is to move the list of thermal instances, or put the list of thermal instances under trip point descriptor, so that if you know the trip point, you can just walk the list under it, and then So that's the first change. I don't think it's controversial. No. Okay, cool. I need to wait for a while for the slide to show up here. So the next change is an optimization of sorts. So today the design is that when you register a thermal zone, the trip points are already known. There is a known set of trip points. There may be disabled to start with, but there is the number of trip points, and the types of them, and so all of that is known up front. So the terminal core creates a table of trip point descriptors, and it may not be sorted because there is no guarantees that the creator of the terminal zone will sort the trip points to start with. And also the trip temperature order may be different from low trip temperature order in some cases. So we have this table, and then when there is an update, when the thermal core reads the thermal sensor and gets the temperature, the zone temperature, it needs to walk all of the trip points in order to see if they have been crossed or not, or So that's a bit of an overhead. It is not huge because usually there is not so many trip points for a thermal zone. It's like of the order of 10 usually, right? So that's not a huge deal, but then. From the it's just unnecessary overhead from the pure programming perspective. So it's better to rearrange it so there is fewer operations to carry out, and the idea is to use sorted lists for that. And it is actually easy because we already use sorted lists in the thermal core for thermal notifications, so that can be used for to organize trip points such that they always every trip point is always present in a sorted list, but it depends on whether or not it is above or below the zone temperature. Because if it is above the zone temperature, the ordering has to be by the trip temperature, so the higher watermark, right? But if the trip is below the zone temperature, it has to be ordered by the low temperature of the trip, which is the low watermark. So there are two lists, and the trips go between them as they are crossed. So basically, this is the idea. I don't think this is super controversial either. Yeah. There is an interval tree API. I have considered using it, but for this particular use case, it is not particularly useful because for the notification purposes that I was talking about, we already have to move the trips around, sort of, and then the operations on that tree are more expensive than the list operations. So yeah, but yeah, please, if you have time, look at the patches. If you have an idea to improve this, please let me know. No problem. So. But yeah, I did consider using it. All right, so that's this. And then the next thing is related to locking. So I would like to use a guard for thermal zone locking. Again, super non-controversial. But if you want to, if you have the time and can review the patches, please do so, because it's super easy to make a mistake when you do those changes. Because you have to basically in every case where the locking is used, you have to use the guard in the right way and without everything needs to be locked as it was. Hopefully I didn't. There is one catch in this, which is that in one case we have to drop the lock and reacquire it in the middle of an action. So this is for system suspend. When a system is suspending, there is a case in which the lock needs to be acquired and then dropped and acquired again, and this is this doesn't really play well with guards, but so for now it's like open coded sort of. But then I have an idea that maybe it could be done by creating a reverse guard, like that will be unlock and lock, and then use it in this case. So I'm going to send a patch later, but this occurred to me just on Tuesday, I think. So yeah, so guard, that is a no-brainer. There are problems with thermal zone initialization and exit that are related. So they are not visible in practice, but it doesn't mean that they don't exist. So if you register a thermal zone, it shows up in SysFS before it's ready. And when it shows up in SysFS before it's ready, then Userspace can talk to it, basically, from that point on, and it can enable a thermal zone before it's ready. That is not maybe very bad, but also it triggers things that are like sort of out of control. So it's better to avoid that, because ordering of things needs to be followed it doesn't really, so, if this was just the initialization of the kernel, I wouldn't worry that much. But there are terminal zones registered by drivers, by modular drivers. And if you have a modular driver that registers the terminal zone, and then user space starts, then enables it prematurely, then things may get confused. So these are the changes to prevent this from happening, basically. Again, I don't think this is controversial because, these are bugs mostly. Okay, more guards. So there are other logs other than the terminal zone log, and I would like to use guards for all of those. So have patches, and they are in the list. So again, please, if you have the time, please look at those. Hopefully they are all correct. There is one thing that is not done today, which is that when the terminal zone goes away. So for example, there is a driver that registers the terminal zone, and it is unloaded. So the terminal zone goes away. We unbind, so the kernel unbinds cooling devices from that terminal zone. So the terminal instances associated with trip points are removed, basically. And at that point, the cooling devices that were associated with trip points in that zone are left behind, without changing their state. I don't think this is okay, because the terminal zone may be the only one actually influencing those terminal devices. And so if you can think that, for example, if the cooling device is a throttling cooling device, it might be, after something like that, it might continue to throttle things when the terminal zone has gone away already. So maybe not. It's just a very small change. It's like a super tiny patch. Okay, there are things that I'm thinking about, but have no patches for. So the stepwise governor right now works the way that. So the idea is to increase the level of cooling step by step for all cooling devices in terminal zone. But when but it only works one way. So it increases step by step, but then when the zone temperature goes below the trip point, the low temperature of a trip point, it actually reduces the cooling state of all devices in one go to 0. So that can be done in principle, and the problem with it is that there may be this dance, going up, then going down to 0, and then again rising up, and going down to 0. So maybe that can be done step by step, going down, but you need to be careful about this. So there is always a mitigation in place, but maybe we can reduce the cooling states, decrease the cooling states of cooling devices step by step earlier. So that is one thing, and the other is so if we use the sorted lists in the core, then the governors can use them as well, and that can be maybe a bit cleaner. Now the testing enhancements. So I started to construct the testing facility for the terminal core, which is it works of debugfs. You can create mock terminal zones right now. In 6.12 RC1, you can create mock terminal zones, control them through debugfs, set the temperature. Obviously, all of this is fake, but you can exercise the terminal core and see what happens if you do that. If you do this, you can disable, enable trip points, do things like that, create them in different orders, so everything can be. I would like to extend this by adding support for mock cooling devices, so you can create a mock cooling device, then bind it to a mock terminal zone, and see how this works, exercise governors and things like that. Also, I would like to add set trips testing support to this. And another thing is that I would like to have a circular buffer of notification messages, because right now they go over netlink, so I have to write an application opening a socket, reading all that from the netlink socket. I would prefer to have the messages available in the circular buffer as well, so I can look at them like from a human perspective right away, or from a shell script, which is easier for testing automation. So, okay, so these are the plans. Hopefully, nothing super controversial. There will be obviously there will be patches going to the mailing list. So, any comments, questions? Yeah, there's a mic. Yep.
Hello? Yeah. The netlink messages, it is expected that as soon as some trip point is reached, there is a netlink message broadcasted to Userspace. Is it?
Yeah, so there are messages sent to Userspace on every change in such that the trip point is crossed, or the trip temperature is crossed on the way up, or the trip load temperature is crossed on the way down, but also on other events, like the cooling device is bound and so on.
I ask because there are some systems with which I'm working. They don't have cooling devices. They are just passively cooling, and they usually there is no real strategy what should be done with these devices. So the main strategy is just if the system or house or whatever is burning, literally, then we just stay till the very end and log every I don't know 10 grad of degree increase in temperature and notify whatever we are able to notify for then forensic research later. So is it somehow possible to like set list of trip points like every 10 grades and notify?
Daniel's going to be to talk about this. So not yet, I would say, not yet, but we are working on it.
So just to avoid polling of.
No, so it is possible to poll. Yeah, so you can register a polling terminal zone, but also it is possible to do this interrupt driven if you have supporting hardware for interrupts. Okay, but so this is the end of what I had. The rest of the slot is Daniel's, basically. So Daniel. All right, so pick the one that you are going to start with.
Vienna is Userspace, right?
It doesn't matter. It's all your stuff. So.
Okay, so I think the title of the presentation was Userspace 3 points. So somehow, given the discussion we had recently in the mailing list, we decided to rename that to 3 results, which makes more, they are more self-explicit for what they are supposed to do. So 3 points are a description of the hardware. So the firmware gives information about the different temperature the thermal zone is supposed to do an action with. But the user space actually needs to get woke up by when the specific thermal zone is crossing a temperature limit. And he has no mechanism today to do that. So the choice he has, he can poll indefinitely the thermal zone temperature and do an action when the temperature is crossing. That means the user space is constantly waking up the system, while we might want to be just sleeping during a long amount of time, because on the mobile system, it's not, we cannot accept that kind of wake up. So what we find, so out of 3 kernels, what they do is they create fake 3 points in the device tree. So the firmware is giving 3 points. They are not bound to any cooling devices, and they activate, enables in the kernel the option to writable 3 points. So they change the temperature of the 3 points on the fly, and use that to get notification directly. So yeah, so what we have today, most of the sensors are interrupt-driven. That means we can program the sensor to send an interrupt when we are crossing the temperature limit. And it's exactly what we want. We want to be wake up by this. We want to provide to the user space this mechanism to be wake up when we cross the temperature limit. So in order to give something to user space to use this mechanism, this existing mechanism, only the kernel is using today, we are providing this user space results. So now what we have is a patch set. It's a V3 version where you can specify the temperature you want to be, at which temperature you want to be wake up, and you can give also the direction. That means if you specify that you want to be wake up at a temperature limit and the direction the way up, that means you will receive the event only when you cross the way up. But when you cross the temperature the way down, you're not wake up. And the benefit of doing that is actually you can create hysteresis with that. So you create an upper limit for the hysteresis with a up direction, and you can create the low limit of the hysteresis with a down direction. Or if you're not interested of doing the hysteresis, you can specify up and down direction, so you will be wake up when you cross the way up and down, which is acceptable for thermal zone when the temperature is very slow in terms of variation. Also, we don't want to give a lot of information about the 3 point, the thermal zone, the result. We just consider that the temperature is the identifier of the result. So if you want to delete the result, to just specify the temperature. It's not, there is not trip ID like the trip points. You don't have IDs, so the ID is the temperature and the direction. So we do a mix of both. So you can remove a temperature and a direction. So if there is a result set with both directions, then you will remove just one direction. I think, given the comments in the mailing list, that I think we reach a consensus about this.
Okay. This is mostly like details to agree on, like, implementation details.
Yeah.
Basically. So this is going in sooner or later. Hopefully in 6.13, right?
So these results are just giving a notification. So the notifications are netlink based. So we have the thermal zone ID, we have the temperature, and we have the current temperature, and we have the previous temperature. So with that, we consider that user space has enough information to build the situation, the thermal situation, and we don't have to send 1,000 notifications when we cross all the results. If we specify a lot of results, just one notification is enough. And user space can figure out what is the delta given this information and do the appropriate actions.
I wanted to add to this that this is intended for thermal zones that support interrupt that support thermal interrupts, but it can also be used with pole thermal zones, yes. Right? So, yeah.
Using the polling mechanism only, that means you will have a delay, which is basically half of the period of the sampling period of the thermal zone. But now I don't think we have a lot of sensor not working with the interrupt, so yeah. Okay. So this is an example you can specify from user space. So you have a set of netlink comments and you have events messages in netlink. So with the command you can add a result, you can delete a result, and you can flush all the results for the specific thermal zone. So assuming that you have here, that's an example, you have the temperature result with a direction. U and D means up and down. So here, this result, we have 37,400 direction. So you want to be notified when you cross the way up and down. And if we have the temperature crossing, so we have the system internally is wake up because we cross one of these results, then the thermal framework will read the temperature. We will have the previous temperature, the current temperature, and we send a notification. So even if we cross several results, we send one notification with the thermal zone ID and T0, T1. So that's an example. Here, the same. If we cross this result with the direction down, then we don't want to send a notification when there is a flag set for crossing the way down. So just the second one is in the list here. The last one, I mean, is the one which will result in a notification to user space. If the temperature is dropping a lot, then we will send one notification, and even if we cross these two results, we are flagged with the down, the way down flag. So if we want to monitor a thermal zone, obviously there is a trade-off between what we can do in user space, what the kernel has to do, and what the firmware has to do. And that will depend on the speed of the temperature variation. The faster it is, the less you can handle that in user space. So for CPUs, for example, where you can have for very fast CPUs, very fast transition, temperature transition, trying to handle that in user space does not make sense. You cannot do that. It should be the firmware, and if the firmware is not able to do that because it's not implemented, then it's up to the kernel to do that, but not the user space. So you can monitor places in user space with this result, but you are not supposed to monitor temperature moving very quickly because you will have storm of events, and you don't want that. If you want to have you have always a delay when you go from the kernel to the user space. So, and especially with the temperature where you can have big variation, then you will have a storm of event, and you will always be trying to catch up an image of the situation, which is not really resulting of the real situation. So it's just a bad solution to try to handle that in user space. So the real context usage here is to have a thermal engine in Userspace, trying to monitor different places to get a thermal information about what's happening, more or less, and try to mitigate the overall temperature, where one of the critical sensor is a skin temperature sensor, which is moving very slowly, around 1 degree per second, and from there, the system has to take action to mitigate this sensor given all the temperature all around the place. So what could be missing? So assuming that we have this threshold mechanism upstream, what could be missing? So we have processes setting thresholds, and if we have other processes reading the events, it will receive notification about these results. Maybe we don't want to pollute the other processes watching the netlinks events, which are thermal related. And so maybe what we can do is do per process notification. That means all the processes setting this result will receive the event, and only the process setting the result can remove or change a result. So yeah, that's a part, I think, of the next step for these results. Userspace result, I think, yeah. Questions?
So if you can go back a couple of slides to one, that one, for example. So to answer your question about what to do with this, so you can just set a set of those levels from Userspace and have like here, and then when one of them is crossed, you'll get a notification via netlink, and then you decide what to do in Userspace, basically. So that it is that simple. Yeah, right. And then you can manipulate those things on the fly, so you can remove them, add them as needed. Okay, thank you.
Thank you. How do I switch to the other presentation?
Yeah, so plus button here, and then you have a list of them.
Okay. So I think it's the next one is.
So a reminder, we are doing a break at 11:30. So just like the other micro conferences, so this was a change in the schedule I was talking about.
Das geht.
In the beginning. So okay, floor is yours.
Okay, so today we have several governors in the kernel, but if we want to just assuming that we have the putting apart the fair governor or the bang governor, we have two governors having some logic inside. It's the stepwise governor and power allocator governor. Both of them are relying on periodic sampling of the temperature. So the stepwise is quite easy in terms of logic inside, because when the temperature is still rising, then you just increase the mitigation effect. And when the temperature is dropping, then you decrease the cooling effect of your cooling device. So it's just working fine. But the problem is, when you have cooling devices with a lot of different states, that can happen, for example, with the idle injection cooling device, where you have 100 cooling state. Basically, you reach on some devices doing idle injection, you have between 26 and 40. That's what the interval of cooling state I found, where the system is reaching the temperature stability when mitigating. So that means the stepwise has to wait 40 times the sampling rate before reaching the state.
So this is working now? Okay. So this is particularly a problem with pole thermal zones, where there is a polling interval, and then every step can only happens after a polling interval, right? So it takes you can compute the time needed to reach. If you have many steps, you can compute the time to reach the full cooling by multiplying the number of states by the polling interval, which then can be quite large, and that's problematic sometimes.
Yes. So because of that, you can decrease the sampling period. So you will be sampling more, but the more you sample, the more you do logic, the more you are consuming CPU, and the more you are overheating the CPU. So you're adding more work to do cooling while the CPU is trying to do a lot of work, which is not really good. And the problem is, well, if you have this delay before the stepwise is able to increase the state until it reaches the state where the cooling device can mitigate and stabilize the temperature, then you have overshoot and undershoot in terms of temperature, which is not very good, because overshoot, you can have big overshoot reaching a critical temperature, shutting down the system, or you can have undershoot, and undershoot means you lose power capacity, computation capacity. So that's for the CPU, but it can be for GPU too. On the other side, we have the IPA. So the IPA stabilizes the temperature. It's supposed to do some kind of flat figure of the temperature where the temperature is close to the temperature limit, so which is the best figure shape. And it's based on the PID loop. So this PID loop is, well, when you do mitigation stuff, usually you use a PID loop where you can adapt the instruction of the cooling effect based on the situation. The disadvantage of this of the power allocator governor is the logic inside is very complex, and there is a lot of math involved. And if you don't have a very good knowledge of how works the IPA and the PID loop, then it's very hard to configure to do the setup. So for each thermal zone, you have coefficient. This coefficient is part of the equation of the PID loop, and it will depend on the ambient temperature, it will depend on the workload, it will depend on the platform, And if you don't know how to find this coefficient, the PID loop is not working very well, and the result is a kind of signal jittering around the temperature limit. And last disadvantage is the IPA only works if you have devices and cooling devices with the energy model.
I think that your last bullet is the most restrictive one. I mean, because, you know, this means that currently we have energy models for CPUs only.
Yeah.
So
And GPU.
Yeah, okay. So this means that the PID, the power allocator governor cannot be used in the majority of cases, basically.
Yeah. So the proposal here, so it's just all, yeah, question, sorry.
You will answer that later, but for the power allocator, you say that it's quite hard to set and tune the PID. You will use a PID in stepwise. Why that will be easier to tune this PID?
That's the
Okay.
all theoretical aspect of the proposal. So the proposal is, maybe what we can do is try to find a solution where we can have a simple logic, like the stepwise governor, and having a smooth stabilized temperature figure. So it means we reduce the number of overshoot and undershoot. In order to do that, we need to find out the temperature speed estimation. We have to find the temperature speed change, well, the variation of the speed of the variation of the temperature. And we don't do sampling. If we have the temperature speed, then we don't need sampling because we should be able to predict when we will reach the next limit. So instead of doing sampling all the time, we predict.
So I kind of disagree with the statement that we don't need sampling anymore in this case. So you need sampling in order to predict things. So you need it for that different purpose, but you still need it. Because if you don't sample, you don't know how things are, what's going on.
Yeah, so let me define sampling. Sampling is you read the temperature at periodic intervals.
Right.
And it's fixed. This interval is fixed.
So you are just saying that we may not need to do the constant sampling interval sampling. Yeah.
So you use the speed, and you can use the speed to set a timer. And the timer is the place where you read the temperature. So if we have the speed, we can do an estimation of when we reach a specific temperature. And of course, the temperature is the speed of the temperature variation change depending on the cooling state we have. So the higher we are in the performance state, the higher we will have temperature variation speed. So in this example, we have the temperature crossing the low limit of the hysteresis for the temperature. So we can imagine that this red zone is the zone where we want to keep the temperature of the system. When we cross the low limit, then we can, at this moment, we get an interrupt because it's a threshold. Then we read the time. And when we cross the upper limit of this threshold, then we read again the temperature, and we can deduce the speed of the temperature variation for a specific state. At this moment, you can say, okay, I was able to, I cross during this amount of time, I did this pass in the temperature and cross from the low to the upper limit. So if I reduce so that's an assumption the logic is doing. If I reduce I add a cooling effect, then after this same amount of time, I should cross the temperature, the low limit temperature. And you set a timer equal to the DT0. Of course, this assumption is wrong because you cannot, it's not linear, so we can reduce the effect but still have the temperature raising up. At this moment, you see the temperature, you can read the temperature limit because you have the variation of the temperature and variation of the time again, and you can have, for the state, you can have a second speed. And you do the same for the next one. And you find that the temperature is dropping at this moment. I think the figure is wrong there. Yeah, I did a mistake with the temperature. So if we assume the temperature is now in the hysteresis, the point is in this hysteresis value. What we want is, we want in average, the average speed of the temperature limit to be close to zero, to be zero. Okay? So that means if we compute the average temperature for all this speed and we assume they are equal to zero, that means we know that the time variation is always greater than zero. Then in order to have that equal to zero, that means we have the temperature variation equal to zero. So what we need is to find a way to make this, this sum with factors equal to zero. Why factors? Because the factors will give the duration we will propagate to the different state. So that's the theory, the idea is the beginning. So what we need is find these IBC factors, and these IBC factors will give us the duration of being on the different state during an amount of time defined by the sum of the dt. But the question is how we can find this ABC. Shall we repeat 3 times to the same thing and given that resolve this equation? Or should we use arbitrary values? I don't really like that. And what will happen if we use too longer duration? How do we prevent overshoot and undershoot during this duration? Yes, that's something experimental I would like to do in order to try to have a self-adaptive logic given the temperature and the behavior of the temperature of the system. So just one comment, because there is a big change actually in the thermal behavior of the board. Just for a few degree ambient temperature variation of 1, 2, or 3 degrees, the consequences internally of the temperature of the sock, it's very big. The impact is very big. So that means if we do a setup of the system assuming that the ambient temperature is 21 degrees and we say, okay, 21 degree, we can mitigate nicely the temperature with a sampling rate of 100 milliseconds, but that at 23 degrees is no longer true. At 25 is even worse. So that means this sampling period might be always wrong because of that. And trying to find an algorithm which is able to use the speed, find out the speed, and do the sampling, but sampling, variable sampling, and trying always to find out the best duration for the cooling state, will adapt automatically of the change of the ambient temperature.
So it also depends on the form factor of the system. Because if this is a thermally challenged, let's just say, design with a very thin form factor, then this is going to heat up very quickly. So I think so. I don't know. Maybe a good way to start would be to think about like when the stepwise governor needs to bump up the cooling state by more than one level in one go, right? Because that would be like a step in this direction. Like maybe we can, there can be like, say if the temperature crosses like 2 trip points at the same in one go, then we may bump up the cooling state by not just but one step, but proportionally to the temperature, increase or something like that.
Yeah, but the issue with that is the temperature drop is not linear with the step.
Yeah, it isn't. Yeah, but
so it's hard to figure out how many steps you have to do because it's not linear.
Yeah, but you still, so it is linear to an approximation, right? Because you can always approximate a function with a straight line to some extent, right? it's just a matter of the angle, right? So this is the first comment, and the other is like, well, that it still is better than just doing one step at a time.
Daniel, elementary question on trying to understand the content, the control system that you are designing. So when you have the graph of temperature over time, there is you're not just measuring. At some point, you will cool. So and you're saying that you want to find the optimal sampling intervals so that you solve for that equation, and the cooling, like the control system would, like a control system, there is some input, some output, and those coefficients are the output of your algorithm. Is that what?
Yes, because if okay,
and you decided that you want 3 past values. You want to operate over.
Let me clarify that. You are correct. So obviously, if you have always the temperature rising, you have a temperature variation speed positive. What you want is to have a temperature speed negative. So when you have a positive one and a negative one, then you have to find out how long you will stay in the negative one to compensate, to balance and to be zero. And it's these factors gives you the duration.
So it depends on what cooling state you are. So the assumption is that there is one cooling device with a set of states, and each state has influences the temperature in some way, such that there is a constant speed of temperature changes in the state.
Forgive my ignorance, but the cooling states, right? You can either be cooling or not be cooling. There is no such a thing as cooling faster, right? There is.
Yeah, there is.
Okay.
Yeah, there is. There may be like 100 of cooling states for a cooling device, and each of them is a level of activity, as I said up front, like in the terminology slide. So if there is 100, then each level means that, like, if you think of a cooling device as a fan, like, for example, then it means that the fan is speed faster and faster. Yeah.
And so the speed of a fan will influence your parameter, the coefficient you find.
Yes.
Right.
Okay.
So if you see the temperature, the faster the fan is rotating, the faster is cooling down the system, and the faster you see the temperature dropping. If it's very slow, then you have the temperature increase will reduce, and the more you have it's like when you accelerate and you reach a Vites limit, and you accelerate with your car, and when the more you are reaching the limit, and
you only set the state equation. You didn't propose an algorithm. Is that correct?
Yes, right.
This is just like.
Yes, that's why I say it's all theoretical, because theoretically, if we are able to solve this, then we have this temperature staying equal to 0 and being in this hysteresis.
In these examples, I see that the primary use case are desktop servers and so on. Their cooling is very important. And embedded devices, they have other problem, so it can be too cool, and we need to be a bit more warmer to keep operational temperature. So is it something for thermal zone framework to keep actually things warm, not only cool?
Yeah, but it's if I'm correct, this warming device is just one state, right?
Oh, not necessarily. So I guess the point is that in some cases the system needs to be like hot enough to operate. Like, because if the temperature drops below a certain point, it will not be able to operate anymore. So the answer is yes. This, in theory, is a matter of the problem is analogous to cooling. So the same framework can be used for that in theory, but in practice it has never been used for it. So, so it's like, well, we can do that, but we need to adjust it probably for this use case, because then you kind of need to look at reverse, at things in reverse order. Like, we don't want to. So the falling of the temperature will need to trigger actions. In that use case, right? Yeah. That's. But yeah, in principle, we can do it. It will
be like this red line which you are seeing this operational temperature. It's just not like cooling temperature. It is.
Yeah, but then you would need to create like a reverse thermal zone then just for this purpose. Okay.
I mean, if you really need something like that right now, you can always have a busy loop thread running all the time, and your cooling device would be to slow it down. Don't run it as often. If you're really in dire need before they figure it out, that's an option.
So this is like mostly about like adjusting your operation conditions to your needs, like, because you can you can always have a loop, but you never know how much heat it generates actually.
No, the temperature.
Yeah, but then you need to hook it up. Yeah. Yeah. So so the heating device is an analogy of a cooling device. So it can be multiple. There can be multiple states, and then
The problem with heating or keeping some operational temperature, there are different strategies. Like if you're using only water level strategy, then you make it too much jumps, and sometimes it is not good. So you need to keep it a bit more stable, and to keep it more stable, you need some profiles about your device and so on.
So this is a PID problem, right? In which you have to adjust the parameters.
I wanted to mention, maybe it's not the title of this slide deck, but on the conference page you wrote PID, right? PID controller, like the classic theory, proportional, integral, derivative, but seems derivative only, right? Because you seem to only look at the difference. You see what I mean?
Yes.
Okay.
I put PID, but I changed my mind because when I was thinking about the algorithm, I said, yeah, it's more time-based or speed-based or thing. Maybe at the end we end up with some kind of PID. Maybe, but it's too early.
Yeah, because for example, in the completely different situation, frequency scaling, the Intel state used to be to have the code for PID, but the only non-zero parameters were the proportional one. So yeah, PID, but then at the end of the day, it was proportional. So. Oh, sorry. Oh yeah.
Oh.
Yeah, so in this example, like the speed for each of these cooling states is going to vary significantly based on like the system load, right? Like how much heat is generated if, like, say you have idle time. So that means the speed for each cooling device is going to be changing over time. Is there any sort of like smoothing or averaging you expect to add for, like, because the factors you described are also going to change over time if the speeds change over time, right? So like, is there what's the strategy for dealing with that?
It's the
right,
same
like,
as for the ambient temperature, right? This is the same problem because.
Right. So is the expectation that the factors are going to be changing constantly then?
Yes.
And your exposition is that those factors are the output of a control loop.
Yes.
So at every kind of time step, you have ABC, ABC, ABC. Is that right?
Yes. But
so it's not like three fixed numbers.
That will happen only at the beginning of the mitigation. I mean, so you have a mitigation episode, so you are about to overheat, and then at the beginning you have these measurements, and you find the factors, and then when the mitigation ends up,
it's over. The control is done. You know, it's back in control, unless you can't.
So the accuracy actually.
It doesn't converge.
In theory, the accuracy.
Back to the gentleman there.
Okay, so a comment. In theory, the accuracy will depend on how many measurements you make on the way, right?
So is the intention that you are only start the mitigation when you hit the trip point, or is the idea, since you have a dynamic sampling, like you would want to choose, since you know the current speed, you can choose like a sampling interval that gets you like halfway to the trip point or something like that to minimize the amount of overshoot?
Realistically, we'll probably end up with dynamic sampling.
And you begin to sampling at not when you reach the limit, when you reach the low limit of the hysteresis. So the real temperature you want to avoid to be to overshoot is the upper limit of the hysteresis. Usually when you set a trip point, it's the upper limit. And when you have the low limit is when you stop mitigating. So you can begin to monitor and measure the speed at the beginning when you reach the low limit. You are close to this result.
Right. So thanks a lot, Daniel. So we have reached 11:30, which means that we are supposed to have to be having a break now. So why don't we continue later, or or during the break? So I would like to give everyone the time to rest a bit. So let's just do a break right now, and then we'll start with the Daniel's topic on the we are late because of the technical problems, in the beginning. Or at the beginning. We are one topic late. So we'll start with Daniel's next topic, and then we'll continue with the topics from Saravana. Okay. So let's have a break now. Yeah, exactly. Yeah. The parameters. Yeah. So see you after the break at 12.
When you use the governor, you are in the kernel. And the purpose of the kernel is to protect the place and not doing overall logic. So when you are in user space, it's up to the user space to manage the overall logic.
About protecting the board. Let's say that I have a power supply that is able to provide 60 watts, okay? And if all my system on chip or my device is used at the maximum, okay, I am using every IP of myself, I am out of the power. Okay?
Idea is basically like,
and this is something that I cannot have, I cannot put not in the
For the same trip point, or we have two different
be able to measure the current, okay, measure the power in some way, and okay, you know what, we throttle the CPU, so we get back within the power level of my power supply. Looking at this in terms of power, okay, or milliwatt or watt.
So is the target temperature then the low water mark of that curve
saving
point?
power because also have a longer battery life? But
yeah, so the low
Doing power budget.
yes.
So there is a beginning framework called TPM,
Okay.
which is an extension of the Power Card.
Okay.
You know the Power Card framework? So the Power Card framework is a CSFS. So you have devices registering themselves saying, I'm power capable, so I can give you my power consumption, and you can set a limit. Basically now the DTPM is to describe the dependency between the devices.
Similarly, you would need to start measuring when you hit falling past the low water mark, because then you can reduce your cooling.
Right, exactly. So then when you are when you start measuring, you are.
If you create, for example, you can create.
I guess my assumption is that if you always want to stay between the high and low water mark.
Memory, CPU, cluster, big, little, and then a big cluster, you call the CPU. When you
want to avoid crossing the low water mark,
then DTPM
It is not in the scenario. This is the scenario. So you are below the low water mark.
when you read the power.
I guess my assumption is if you're below the low water mark, you're applying too much cooling.
All the children soon them, okay?
Yeah.
And then when you read the temperature,
I really
then you have the
Right. So this is a.
The wood.
power of all these devices. If you read the power of the cluster 0, you have the power consumption of the CPUs, and so on. So if you put a limit, so there is an algorithm I want to put in place, but now what I need is more devices capable to get and set power limit. But what I created an algorithm where you can set the power limit at the parent. Okay? If you say I give you 100 and you have one having using so you distribute and say okay, this I can wait this child and this child, so this one will have 80 and this one will have 20. Now let's imagine
you have only 90 available,
ideally,
then you need to take some
yeah,
action.
but if one is not
temperature will be relatively stable.
Yeah, it should stabilize below the high water mark.
But the stable temperature may or may not be below the low water mark.
You can borrow it.
It may, yeah, so it may be high.
And that's the algorithm.
You're right, but then...
So there is something around this going on, but...
Yes. And DTPM means dynamic thermal power.
Higher than the high water mark. Because
But
high water mark really means that you...
I mean, my company, we build embedded devices. I don't know, maybe you heard of them. I mean, Provadex.
no?
And we build boards, so some mainly
Overshoot a little,
more than what we see happening
the
now
target
is that
temperature
we
is
have
the high water mark.
what used to be embedded stock, and we have
Okay, so ideally you spend approximately half your time
okay,
above.
so we end up with really huge power supply. And in the reality, most of the use case on the average we use less. And what you would normally do designing such a system, you design the power supply for the theoretical maximum peak.
Okay.
That's not designed correctly.
There's not like a separate
and
target
same characteristic
temperature.
in the most weird way. And this is, making the product bigger, okay? And so we are trying to think about
But right now,
be a way to say, okay, you know what, we give you, I don't know, 40 baht, not 50, okay? And then that would be a way that, if you are going to go over this power that we are able to provide, you throttle the CPU, you throttle the GPU, you throttle that, you switch off a core. I mean, there are, options, okay? And this is a little bit where this is coming from, okay?
So my
That was what was confusing me.
Yeah, that might,
the red bar in the diagram with the range, you want to stay in the
because
middle
what
of the
we did
range.
in our last product, I mean, the power supply is designed in the traditional way, and we decided to use USB-C power delivery, and I mean, 100 baht power supply. I mean, what you have on your laptop is 65.
Yeah.
Yeah, and this is where this is coming from, just to give you a little bit of background. Good, so DTPM, there is something going on.
Yeah. And the more there are devices with ability to do get and set power, the more we can put devices in this DTPM thing, and the more we can do this rebalancing algorithm, which is not validated today.
Yeah, understood. Now it's tricky because something that, if I think of that, is very easy to do is measuring the power that we give to the socket. So the input power, what it's currently consuming, I can give you the number that this power supply is capable of. And then on the single IP block, I just have the data from the system on chip vendor that is telling me, okay, this IP, that's power, okay?
Yeah.
That's what I have at the moment.
That's not bad. I mean,
Good.
You uploaded?
I uploaded it.
Okay, so there are.
It should be here. Can you check? So I asked for system.
Optimizing suspension.
No, that's the same.
How do I see mine?
Oh, yes, it's me. And then you're just after, and your slide. And Watson, LPC Watson.
Okay? Yep.
Yeah, we all agree. Yeah. Well, finding common ground. I am. It's the only way I can get rid of this.
Otherwise, I'm just going to stir crazy. Okay, cool. Okay, I'll see you then. Thanks.
No, I mean, the mic
Okay,
is working,
hello
but
everyone. So why don't we start the second part of the micro conference? So please take your seats. And we are starting with Daniel's talk on the power thermal performance interfaces.
Okay, so adding one information is about this talk is focus on mobile platforms. Why? Because usually the platform needing a good control of all the power, thermal, and performance things is Android. And Android, as you might know, has a lot of different custom code, and there is no unified ABI to act on the different aspects of the power management of each devices. And so it's very hard to write any generic code because each platform has its own solutions. One of these solutions we can find in some platforms hundreds of cooling devices, and when you look closely what they are doing, they are just hacking around different devices, and the cooling devices are there not necessarily to tie it with a 3-point or and a thermal zone, but just for the sake of giving an API, so an API to be used by the user space. So obviously it's platform specific, and behind that the user space is specific too. So it's not possible to write any kind of generic library using these PM knobs existing in these platforms.
So I guess the main point is that the cooling devices should be used for thermal control, and specifically, and not for other purposes, which they are used for actually.
Right. For example, we find cooling devices where you can specify the current of a battery. So the cooling device is the battery, and then you can specify the current for the battery. It's the cooling
Also,
state.
I guess it works the way that you set a cooling state, because the so maybe as a matter of introduction, the cooling devices are exposed through SysFS to Userspace. In particular, there is an interface to set the cooling state of a cooling device from Userspace via SysFS. And that's what people use to control the devices, not necessarily for thermal control purposes, but for any purpose. Like they use a cooling device interface to set brightness on screens. They set the cooling device interface to control the battery, the
frame rate,
to frame rate, the other things through cooling states, because there is a SysFS interface and it's easy to use, essentially.
I mean, those things do, at least examples you gave, they do affect the temperature, thermal characteristics, right? More frames per second is more heat. Higher charging current is more. So I don't see those as necessarily wrong examples.
But they are not used for cooling. They are used for controlling brightness, for example.
Yeah, brightness also affects the heat.
Yeah, but the point is not to cool down things, but to set the brightness to a specific level, which is not exactly the right use of the interface.
Yeah, so that's the sign that something is missing in the kernel. So if people is forced to use this framework, which is not the right one, then that means there is something missing in the kernel. And so what do we have today to act on the power? We have power interfaces, the power cap and DTPM. So basically with that, we can get and set the power of specific device. The battery is a good candidate for that because battery is able to read the power consumption. You have an API through the power supply. You can read the power consumption of the battery, and you can also set a power charging limit for that. So it's a good candidate to be added to the power interface. So the user space won't have to go through the cooling device. They can go directly act on the power capping interface. And if there is really a need to tie a thermal zone with a cooling device, if this cooling device is power capable, so being able to enter in the category of power capping, then it will be quite easy. Yeah, Rafael?
Okay, so one more comment on this. So cooling states are defined the way that the higher the state, the more cooling is applied. In some cases, Daniel is talking about the higher the states, the more power is used. So less cooling is applied. So it works kind of in reverse as with respect to what is supposed to be doing, right? So this is the main problem, I think, here. That the cooling state should represent the level of, of activity in order to pull the temperature down, not in order to pull the temperature up.
So if we can categorize the different devices and put, for example, all power capable devices inside this power capping framework, then it's quite easy to do a connection between the thermal framework and the power capping framework by creating a generic power capable cooling device. So the thermal framework won't have to write every time a new cooling device. We just have to declare the power capable device as a cooling device too and do the connection. That could be quite easy. It's just a side comment.
Yeah, so this is already a case for HW1, right?
HW1.
Error monitoring.
Yeah.
There is already automatically happening in that framework. Right?
So another category is the performance interfaces. What we have today is we have CPUFREC, we have DEFREC, which is exported in CSFS, with minimum frequency and maximum frequency, with different format, depending on CPU and DEFREC. But on the other side, we have PMQS for /dev, doing this min and max frequencies. We have unit used instead of frequencies. There is something called summing PMQS. So it's a way to I didn't really understood the purpose of this QS, but basically it's just giving the sum of the performance for a specific device. And also they are putting temporary constraints, so you can set performance capping for a device, and then it's automatically removed after a while. So the idea here is, let's provide a performance capping with QS so we can connect all the different frameworks together, because when you are doing power capping, you are also doing performance capping. And on the other side, it's the same. If you are doing performance capping, you also do power capping. So if a component is able to export performance knobs and power knobs, then we need a connection between both, and using QS, it's a way to make them to translate from one system to another system easily. The goal is to unify the interfaces and the units used by all the devices. We would like also to add a constraint timeout, so you can set performance capping for a specific device and just it will automatically be removed. We find this kind of usage in ISP. In the power, for example, in the Power Agile, we have temporary constraint. So we set a constraint and it is removed after a while. We would like also to have a notification when we have a constraint change. So if someone else is changing the constraint, reducing the max, for example, or the mean, we want to be aware of that because Userspace might want this notification to do something. I don't know what, but somehow he has to be informed about this change. There is an initial proposal about that, where I have the link here. And the proposal here is just providing a few interfaces. So we have performance normal mean. So that means the content is normalized values. And these normalized values are between 0 and 1023, which is the common way to specify normalized values in the kernel. It's a require file. So if we provide a device doing performance capping, then we have to provide these files. Then we provide also a performance normalized mapping. So we do a mapping between the frequency, which is usually when we have performance, we have operating point performance. So we use this frequency. So it's easy from Userspace to have information about at which frequency a specific device is running, at what normalized value. And then, as we can have devices using the kbps value to set the performances, we can also provide this interface with the same idea, where you can have the kbps map giving what is the normalized value given the kbps. I think we can put that under the power directory. Will make sense for the device.
So why do we need the normalized when we give kilobytes per second in addition to it?
Why is it necessary to have both?
Why is it necessary to have both kilobytes per second and normalized?
I would say it's if you have a Userspace library and the Userspace just want to use normalized value,
and I compute it from
yeah,
the
you
other
have
one.
to compute every time. Because here the kbps, it's you tie the kbps map with the normalized value. So normalized value is the mandatory one, the required one. kbps, if the device is able to do also kbps, it can export this information too.
I mean, so these are the interfaces you want to provide in SysFS for them to control, is that
for each device?
Right.
For each
So are you also open to adding more and more unit types? Or you're saying it's only kbps and normalized?
I think these two is enough.
That's when, like, okay, I'm kind of like leaning towards what Rafael is saying, because you can always imagine up another unit which is a measurement of performance, like IOPS, right? Like, and if you're using an SD card, IOPS is like a number of random accesses per second or whatever that is. IO operations per second. Like, they're going to propose that as the next one. Like, I don't see really a point in doing this, and I think we just use the normalized one.
Because kbps is a unit you can find on different platforms specific for the operating points.
I think you normalize them. This is only for terminal.
Right. So my concern with kbps is generally that this is a throughput unit, and it doesn't apply to all the types of performance control, which may also cover latency. So you may not be able to represent everything in kbps, but then you can measure throughput in other units as well. like, I don't know, frame rates or similar, or packet rates, or whatnot. And then the question is, why kbps? What's special about kbps?
You can convert frame rate in kbps, no?
Yeah, but then you can convert it the other way around. So, they are all just throughput units. And so, I don't know. But yeah, okay, let's continue because,
we can put first normalized values, and then we see the need for more units.
Perhaps one like remark or one observation is that you may need to be able to compare the units for the values for different devices, and then the normalized unit for one device may not be in the same as the normalized unit for the other device. Then they become hard to compare, and we need to think about this a bit. But that's...
Yeah, again, I guess it depends on the intended usage of these interfaces. If it's mainly for standardizing thermal and whatnot, I think then the normalized is good. But if you're trying to do more than just that, then yeah, I agree, normalized wouldn't be enough. So it really depends on your goal here.
I haven't looked at the series yet. I'm assuming these are just new PMQoS types. You're not adding some new SysFS interface? You're adding new PMQoS types?
Yes.
Okay.
Yeah. So the question is, shall we put all these files in the power directory, or should have a performance directory?
Well, that's part of my question. If you're adding them as PMQoS knobs, then they're just going to end up under the device nodes that exist already. You can with PMQoS, you can expose each type per device to Userspace with the existing like export function, so they will already show up under each device. Right? You don't need a brand new set of files under SysFS. You shouldn't.
So the question is if this is going to be used for controlling performance. Device performance, right? Because in that case, putting that into PMQoS is sort of confusing. A bit, right? No? Well, so yes and no, because if you want to control performance for the power management purpose, then yes. But otherwise, yeah. Okay. Okay.
So, assuming that we have all these files in per device in the power directory, that means the user space will have to go through all the devices and check if this file exists in order to say, okay, this device can do that, this device can do that. That can be a bit complicated and prone to error. So I'm wondering if it makes sense to create a sysclass perf cap along with sysclass power cap, where we can have just links to devices allowing to do performance capping. So the user space just have to list the devices inside this directory to have the list of the devices capable of doing that.
At least with what I understand, for you to have folders under sysclass perf cap, you need a struct class, and you need to add devices to that class for them to show up under, and they won't be symlinks. You cannot generate symlinks under perf cap. So you'll be forced to create a struct device just to do this. You can always link from somewhere else to these, but not the other way around. Okay. So you'll be just creating struct devices for this. I don't think it's worth it.
So I think overall we need to think about use cases. I mean, which by the way was the main like comment on the series that you posted. It's like, well, what this is going to be used for, and still this needs to be answered. Like, what's the use case you want to use it for? And they. So I don't know. Let's focus on the brightness example, okay? Because that's easy one. So how you think the Userspace entity would use this control interface for brightness control?
The brightness controller it does not, from my point of view, it does not go in this category.
All right, so maybe the example is not right then. But yeah, again, so this is like Saravana, to your point, this is one example of performance control that is not power management related, right? Brightness control. Because brightness is about, usability mostly.
Yeah, I mean, still a performance, you want it to be bright.
Yeah, right, but this is not about, this is because you want it to be brighter because you want it to adjust to your, like, your reception of the image. But so that is, to me, it is mostly about thinking like, what is the goal of doing this?
So the goal of doing this is, I have a couple of use cases, common use cases. In ISP, when you have, depending on the kind of application you run.
Yeah, okay, so we are going over. So
we have
maybe let's just take the discussion offline and then continue there.
We have the both.
Yeah, we have the both. So yeah, tomorrow at the noon. So everybody interested is welcome to join. Yeah. Okay. Cool.
Shall I? Yeah. So are we going in 10 seconds through the remaining slides?
Well,
So just notifications. So it's, the proposal is just sending you events when there are changes. When there is a change of minimum and maximum performance.
So I think let's just defer it to the both tomorrow and then let the other topics run right now. And then, yeah, because, it always like depends on the answer on the use case question, right? Okay, cool. Thank you.
Good afternoon, everyone. I'm Saravana Kannan from Google, and this is my teammate Sam Wu at Google. We've been working on a tool called Watson for close to a year now, and thought we'll talk about it here. So if you look at the status quo for performance evaluation today, right? Anytime you make a kernel change, people run performance benchmarks and say, hey, 10% improvement or whatever. So when you're doing that, the hardware setup to do your performance measurement itself is kind of pretty easy. Whatever device you're developing on, you do the performance measurements there. And it's also fairly easy to kind of scale that to a lab if you want to start monitoring performance in a lab. If it's like a production device, you have enough volume to kind of purchase a bunch of those and set up a lab. And you have hundreds of benchmarks to profile performance with based on the use case. And so it's fairly repeatable performance measurements for good benchmarks. Main issue most of the time, at least in talking about CPU performance, is thermal throttling. Otherwise, if you have two devices, they're mostly the same performance. And in terms of attribution, we have tracing to attribute performance impacts to like specific threads, or you can like get like a finer grained view of what's going on. So it's pretty reliable. We've kind of gotten used to how to do performance testing. But if you do, so that's like the typical device for performance testing. So if you're trying to do power testing, the status quo today is that the hardware is not, hardware setup isn't easy. It's typically like a custom solution per board you're trying to do power measurement on. That's an example of a Pixel 6 trying to measure power. You need all of the extra hardware. And the cost can also be pretty high because it's not the same amount of volume. The device cost can be high. It can be finicky to set up. You nudge it a little bit, suddenly your resistances are different and the power numbers could be different. It's happened to me quite a bit. Scaling is also hard because you don't have enough devices and volume to scale for a lab. Measurement-wise, there's no good common benchmark, at least that I know of, and no good way to easily use them remotely. You have to figure out a solution for that. And it's not also very repeatable because even though you might be, say, comparing between two Pixel 6s, the binning might be different, the manufacturing differences might be there that affect the power. And thermal starts having a huge power impact way before even throttling kicks in. So in that sense, it's not very repeatable. And when it comes to attribution, at best you get at a power rail level, and at worst you get at a battery level, the power impact of it changes. So again, it's not easily attributable to what did you do that caused the power to increase. So we kind of wanted to improve that situation because when I was working on power improvements, I've had all of these issues I talked about before. So one of the ideas was like, okay, can we just look at the traces that the kernel spits out and use that to estimate the power? So that's what Watson is about. It's like Watson to your Sherlock, if you're the Sherlock. And it's trace-based, so it's pretty lightweight, low overhead. And the intent of this tool is not necessarily to give you the exact estimates that you would measure if you're using a hardware measurement tool, but to give more like a percentage change. So without the change, how much percentage is the power going to increase? And this is for CPU, not yet looking at other devices. So what you're seeing here is just like a visual representation. We take the CPU frequencies and CPU idle state trace inputs, and then we spit out a time series of the estimated power usage per CPU. And as you might expect, we have power curves for different states of the CPU, active power curve. This is for, say, for the big CPUs and middle CPUs, and things can actually get more complicated. For a little CPU, we have more like a power volume of data, because in the Pixel 6, the little CPU's power is dependent on the frequency of the little, the middle, and the big CPUs. So we can account for all of that complexity too in this tool. Not only that, also the point at which the kernel spits out, say, idle exit or entry traces don't necessarily match with the hardware because the kernel does a little bit more work before it actually can turn off. Or when it's powering on, it's doing a bunch of work before it spits out the idle exit traces. So we actually measure the actual time difference we see in hardware by sampling it really quickly at the hardware level. And we know what the extra offset is. So we account for that in this tool too. So if the kernel says it's like, hey, 1 millisecond is how long you were out of idle, we'll say, oh, it's actually 1.1 millisecond, because we know that to be the truth in actual hardware. And that's kind of like the setup on what we've done so far. And Sam's been working on running some analysis and results, so he's going to kind of share those details right now.
Hey, thanks, Sarvana. So these are Watson estimates for 10-second runs of Bouncy Ball. And Bouncy Ball, as the name implies, is just an animation of a ball bouncing around on the screen. So we've done this 100 times for 4 different build configurations, with each of these dots here being one run. And as you may predict, and this is all relative to baseline, with the RC lazy build configuration, Watson is estimating a slight decrease in power. With the 1000 hertz scheduling tick, there's a slight increase in power, and the combination of two is somewhere in between. Now, all of this is meaningless if Watson is just spitting out arbitrary numbers, but we put in a lot of effort to make sure the model is as accurate as it can be. So in the top row here, we have our power numbers relative to baseline from our actual source of truth hardware power measurement tool. And then the bottom row here is the Watson estimate, so the percentage change relative to baseline. And as you can see, they're all within a 1% error. So this graph is further evidence of what I was describing. Whereas the previous slide was an average over multiple runs, this is listing out each run with each build here being a different color. And we're comparing the dashed lines, which is our source of truth power, and the Watson estimates in the solid. Since Watson is at AB, yeah.
Yeah. So you have been able to measure the power on the CPU rail in this case? I mean, when you're comparing the performance,
That's right, yeah.
You
are measuring exactly what you are estimating?
Yes. So this is the sum of all the CPU rails.
Okay.
And yeah, we're plotting the same value.
Okay.
Hardware is sum of all CPU rails. Watson is sum of estimates of all CPU rails.
And the bouncy ball, for example, I assume it's not CPU intensive workload. Did you check how the temp can impact your power estimation? I mean, or do you take into account the CPU temp or the skin temp in your power model?
I'll get to the point towards later in the slides.
Okay, good.
Okay, so these are individual runs comparing the dashed lines, which is our source of truth, and Watson estimates and the solid lines. And since Watson is a A/B comparison tool, we just want the slopes and the trend lines to match up, which they do pretty well here in this graph. Now, in order to use Watson, you need to collect Perfetto traces. And Perfetto is an open source tool that leverages the kernel's ftrace in order to come up with the stats we need in order to get our power estimates. And then most test setups follow this timeline here with the initialization and teardown. So we created this notion of Watson markers to define the period of interest and exclude the initialization teardown. We highly recommend using the markers because the initialization teardown in some cases can actually use more power than the test itself. And even if it didn't, it introduces noise to your test. So you can use the markers with the commands at the bottom. And once you have the Perfetto trace, you can either use the UI at this link here or through the command line with these commands to get the Watson estimates. If you're using the Perfetto UI, you need to enable the Watson plugin. It's just a few clicks here, and the setting is sticky, so it'll persist upon browser restart. If you're in the Perfetto UI, you might see something like this. If you're at all familiar with Perfetto, you'll know that they have these CPU frequency tracks that change over time per CPU. Analogous to that, we've added the power estimate tracks highlighted in orange. Okay, if you were to draw a window on the threads there, you might see something like this, which is a per thread power attribution table. So again, I'm going to compare the RC lazy with the baseline. So the RC lazy table is at the bottom, the baseline table is at the top. And here we're running, this is still bouncy ball, but we're looking at the swapper thread, otherwise known as the idle thread. And Watson is showing there's an 18% decrease in idle power when you have the RC lazy build configuration enabled. Furthermore, we can look at the RCU preamp thread. This time we're looking at the idle transition overhead costs here. And Watson is showing that there's a significant decrease in idle exit power for the RCU preamp thread. Okay, beyond build-to-build comparison, we could look at run-to-run comparisons for the same build. Sometimes a process comes up sporadically that messes with your measurements. In this case, the bad run has almost 3 times the energy usage. This is still the 10-second bouncy ball comparison. And since Watson gives a thread-level power attribution, we can sort by the top threads by either power or energy. And in this case, if you see something like Nexus Launcher, something completely unrelated to bouncy ball come up, you can throw this out and label it as a bad run. So this is particularly useful if you're using some kind of testing automation. Now, everything I was showing before in the screenshots can also be extracted via the command line, and you might get some JSON format in these pictures, similar to these pictures. On the left side, we have a per thread breakdown, and then on the right side, we have a per rail breakdown of the Watson metrics. I'll pass it on to Sarvana to finish off.
So if you're wondering how do we use this tool for kernel development, right now we only support it on a Pixel 6, but if anybody here uses a specific device for your development and you want to add support for it, we're more than happy to help you add that support to the tool. You just need to get the right power curves and we can work together on that. We have the contact information at the end of the slide, so you can feel free to email us about that. For suggested workloads, we suggest if you're going to do some Android testing, we suggest using Bouncy Ball. It's a really good analog to an average Android app. And don't do things like run a performance benchmark, which is going to max out your CPU frequency. It doesn't really give you any useful power analysis. Those are kind of common guidelines. After this is just a bunch of slides telling you where to get this tool, how to set it up. Let's kind of skip through them quickly. And then John Stultz has written a really good quick start guide on how to set up and use Perfido. It's like super simple to use. How to collect the traces in Watson, how to collect traces on a busy box kind of system. Doesn't have to be Android. It works on any operating system and any distribution. And this is like the sample input for the config file for Perfido. It's basically saying, hey, collect CPU frequency traces, collect CPU idle traces. And we'll go to discussions, but before we get there, to answer your question, Vasa, so it does not have any thermal impact, and I personally see that as a very good thing, because when you're doing power analysis, we want you to focus on things that you can actually control. If you have a really leaky device or the room temperature is different, you don't want that noise to be affecting your analysis of your changes. So it's not affected by thermal intentionally too.
So for this, having the ambient temp, yes, but I mean, I have seen, for example, that when I'm using speedometer on Pixel 6, in fact, at the end of the first run, the skin temp of the device is higher than at the beginning.
Right.
And you have to wait for
Right, but
minutes.
with this you don't have to wait, that's the point.
No, but you have to wait.
As long as you're not thermal throttling, your performance isn't going to be affected, your power estimates won't change.
But
it's intentionally won't change.
No, but if you rerun one more time, you will have some thermal throttling happening.
Right.
And the power consumption, I mean, if you have a use case, if you change the behavior so that you have more temp peak, I mean, this will impact the power model. I'm not saying that's really good, a really good way. I mean, I'm fine. It's just that I think.
Right. We're not trying to address that point. We're not trying to address the point of power changing once you hit thermal throttling. Okay. Because most of the times, I think we have other issues. For even non-throttling cases, we have a lot of power impact. Like RCU lazy, that has like a 3%, no, not even 3, I think 5% impact or whatever, right? Yeah. That's like a really good way to check, hey, did my RCU lazy changes have a real impact I'm looking for? Or if Daniel is working on CPU idle governor improvements, you can use that to say, I'm seeing power reduction. Is it really true? You can look at the swapper thread to see is the swapper thread's power number going down. So those kind of things. So going to a discussion, right? First, do you guys find Watson useful? What can we do to encourage you to integrate it into your development workflows? Those kind of questions.
So yes, it's useful. Just one more thing for Pixel. I think that now you are updating the energy model.
Huh?
Now.
Oh, by the way, this doesn't look anything from DT at all. It's fully independent. You can run any kernel version, it'll work.
No, I mean that the energy model, for example, now is updated dynamically on some device to be aligned with the reality. So you have the energy model that you're using is out of what is used in the.
Correct. Completely independent. If you can magically run Windows on a Pixel 6, it'll still give you the right numbers.
Okay.
There's a question here. There's a question remote as well. Oh, can somebody read it? Or is it here? Okay, I'll get to the question remote after I get to Daniel. Daniel?
Me? Yeah. Yes, I have a question. How you? So there is when you read the traces and you try to find out intervals of workloads at different frequencies. There is a dependency between the performance domain and the CPU, what the CPU asks for. So is the traces able to, for example, you have a CPU asking for performance state number 2, and then you have another CPU asking for performance state number 6. And so actually the first CPU is belonging to the same performance domain. Does the traces take
The way
into
the
account
traces
kind
work
of-
today, they spit out the same frequency value for all 4 CPUs.
Okay, so you can see that. And when you are doing CPU idle and you go to cluster idle state, are you able to find out?
They account for that too.
Well, you do the intersection between. So my question is, how long it takes to
run the tool?
process the traces to
Super
get
quick, like seconds.
Hmm?
Couple of seconds.
a
max.
couple of seconds. So it's
So like we run this on like say 4-hour traces. We can use the UI. So it's like it's not slow enough where you can't use the UI. You draw a box, wait like a few seconds, it comes up, and that's like trying to do more processing than the command line stuff. Just asking for the command line stuff, it's pretty fast too.
okay.
Yeah.
Sorry, could you explain how you convert CPU idle states into power? I don't see how that's generically possible.
Sorry, can you repeat the question? Is the same person asking the question as the?
That's me. How do you convert the CPU idle state? Let's say you've been 1 millisecond in state 2. How do you convert that into power? I don't see how that's possible.
Thank you. Thank you for saying it's too good. So we actually measured the power usage of the CPUs on all of these different states, and we can extract the info. So for example, if we can say the little CPU is at 1 gigahertz in WFR C1, we know this is how much energy it's using. And
But that's dependent. For example, WFI is highly dependent on what frequency you're running at and so forth. So that's quite hardware dependent, right?
So yeah, right now, like I said, this tool is generic enough to work on other hardware. Right now, we have support only for Pixel 6. I'm not saying this is going to work for your random device. But if you give me the power curves, we can easily insert it so that it'll start working for your device too. So if Vasant likes to work on Dragon Board 845C for all the scalar changes, I'm saying let's work together to add support for that into Watson. So Vasant or if Peter Z ever wants to test it on an ARM device, we can give you a Pixel 6, please. I would love to see you do power regression testing for all your changes. Like, we'll ship a device to you, please.
A related question that I had, and I see Morton has it also in the chat, which is like the C states don't necessarily correspond to reality because of what firmware does under the hood. You know, Linux is going to ask or allow certain states, but the firmware might decide something else. So the traces aren't going to reflect that, where the actual measurements will reflect that, but the traces aren't going to reflect that, right?
That might be true. At least I haven't seen that cause enough of a variation in our estimations. For everything, we've always tested with the real measurement, and like we're saying, it's always matching within 1%. But just to kind of, because you brought up a point, for example, this will not work for x86 because even the Linux kernel doesn't know what the frequency it's running at, right? So this tool is not going to work for anything where the firmware just does its own thing for even frequency scaling. But again, if you can test it on even some devices for power testing before we land the changes, I think that'll be a huge step up compared to what we have not been doing so far. Okay, time out apparently. Thanks.
Thank you.
Good. Again, that's the contact info. Send us any questions you have. Watson-external@google.com. I would really like to see all the key developers who make CPU frequency governor or idle governor or scalar changes to start using this tool. And we'll ship you a device. Please. Thank you. Next talk is also mine, so I'll just bring up the slides. Can you help me with that? I don't know how to. I think I found it. Got it. Got it. Okay. This is my next set of talks. This is about optimizing suspend resume. As you can expect, suspend resume, I've been looking at suspend resume again in the context of power, and it affects, like a watch or a phone quite a bit. Way more sensitive on a watch. I've been looking at it for a while to see what all is inefficient about suspend resume, and is there any places where I can improve suspend resume. So just to give a really quick intro, one slide. this is how the suspend resume states are kind of broken down, right? Before you enter suspend, you do sync the file systems, you feast the processes, you do device prepare, suspend late, no RQ, and then you power off the CPUs. When you come up, it's the reverse. You power on, resume no RQ, resume early, resume DPM complete, and then you do thaw process. That's a high-level overview of the suspend resume. So in terms of optimizing suspend resume, man, these fonts are really hard to read even for me right here. Optimizing suspend resume, file system, sync file system, what it does is it basically flushes all the dirty pages to disk. And it's quite wasteful on systems where you frequently enter suspend resume. So on a phone or a watch, a lot of suspend resumes per day, hundreds to thousands. It's quite wasteful to sync your file system every time. And on devices with large amount of memory, so if it's an 8 GB device, if you say 10% is the watermark of dirty pages you want to have, that translates to 800 MB. And if it's a random I/O, it can end up at 30 megabytes per second. So just your syncing file system can end up taking 25 seconds, right? So one of the problems here is that when you're doing file system sync, there's no way to abort suspend. So if the user starts interacting with your device and you want to abort the suspend and do something, the device is just frozen for some time. So first question is, the obviously easy thing is turn off sync on suspend, but then people are worried about data loss. So one question is, should we try to build more intelligence into it, say instead of every suspend, do it every suspend within 1 hour apart or whatever? Is that something you want to do? And actually even more important than that, is there a way or should we add a way to abort the file system sync or at least not block on it? It can continue syncing if it wants, but it'd be good to be able to abort the suspend.
So I don't think you can abort the sync. But I mean, or maybe
depends on how you wait, right?
You have to wait for it. You may choose not to do it at all, but when it starts, you need to wait for it to complete and then continue, because then you are going to suspend devices, and including possibly the ones involved in the sync. So it's like.
But if somebody wants to abort, you don't need to get as far as suspend. Just let the sync continue, but return the write, because if you're blocking on the write.
You can abort.
And Peter seems to have a.
You can abort the suspend after the sync, but then.
25 seconds of not responding to the user seems really bad.
It also is so. Okay, so the sync in a kernel is not really needed in the sense that you need user space to trigger system suspend anyway. So why don't you sync in user space and then
that's kind of what we're trying to do right now, but if this is possible. But it also means we have to sync every time because we don't know if it's going to be a 25-second file system sync.
Yeah, so one solution is handing the sync off to a thread and just waiting for that and the cancel condition, and then you can drop out.
That's what I'm thinking, yeah.
That should be doable. It shouldn't be too hard. As to how often you can lower the threshold of dirty pages, and that way you don't build up.
You're passing more writes and you're damaging your flash.
I mean, you're gonna flush them out anyway at some point, right? I mean, you want to not have many dirty pages. I mean, we're talking about phones and watches, right? How long are they awake for?
Depends on the user, honestly. Genuinely, right? Phone, yeah. Watch is less so. But definitely for a phone, I mean, somebody's on their TikTok session for an hour, who knows, right?
Yeah, so it's not, yeah, I don't know.
Yeah. But, I mean, if you're open to doing the file system sync on a separate thread and just letting it continue and aborting the suspend, I think that would be nice to do, I think, if you're okay on that.
Yeah, so, abort, so there is a way to abort system suspend from user space anyway, like to block it. But when you start, I think this happens before the sync. But you can reverse the ordering in there, like abort when the.
Okay, but if you're open, we can figure out the implementation later, but if you're okay with the idea of doing that, then we can work on it.
Yeah, okay.
We have a
can
lot
talk
more
about
slides
this.
to complain
Like,
about.
I know this is a problem, yes.
Okay. I'll move on to the next one. Okay.
I didn't quite exactly understand what you wanted to do with the K-thread thing, but if you intend to move on with a suspend sequence.
No, I'm not trying to move on to the suspend sequence. I'm saying when you're trying to abort. So let's say you kicked off a suspend, you're syncing a file system. It can take 25 seconds before, but I want to be able to abort it.
Okay.
So meaning let the syncing continue or stop the syncing or whatever, but no, I'm not trying to suspend before the sync is done.
Right.
Yes, that'll be done. Yes.
That's what I'm saying.
Going on to suspend enter, this is something I don't know. Glad to see Peter Z is here. This is what I see in the perforator trace. It's tracing. There's like a bunch of time where it looks like almost nothing so going on. Is all of the time spent setting the flag for all the threads? And even if that's the case, why is there some sleeping time in between? This thing feels weird. I plan to dig into it further, but if anybody has insights on what might be going on here.
Peter?
Is this the freeze process?
Freezer. The freezer, yeah.
Like why aren't we using more CPUs to do the freeze? I don't know what's going on, but just in general, the picture looks inefficient.
So I have no idea, to be honest.
So it's been a while since I wrote that. I think it just iterates all the threads and try to move it to the frozen state. And that shouldn't take long. But yeah,
it's all relatively long, but the weird part is that it's clearly doing some work in the beginning where it seems to be doing the whatever. And then there's like some sleep in between. I don't, like for example, the sleep here, well, I don't know what else is going on.
So it is, so maybe the threads that are running have been doing something. And then they need to, say they have entered the kernel and they need to exit the kernel.
It shows kernel states, everything, right? Like in that part right here, nothing is literally running on any of the CPUs. So maybe IRQs is not displayed here. That's the only thing that could be happening, but even that seems kind of sketchy. I'll just do a bunch of rants. We can come back to it if we have time.
Yeah, okay.
These are one of the issues I saw was wrong.
Okay, so yeah, again, that we need to talk about.
If it's a kernel thread that's say blocked on a mutex and that is not freezable, then we'll need to wait for that task to finish his blocking on whatever state that is.
But like nobody else is like unblocking, right? Nobody else is running, so it can't even be
so
somebody
you need to figure
freeing.
out who's waiting for what, but the freezer cannot always continue. You need to wait for the task to become freezable.
Yeah, so for you.
No, I understand, but like, assume in those cases something else is running. Like literally nothing is happening in any of the CPUs.
Ravana, is this kernel thread freezing or is this user space freezing?
The whole freeze process.
All of this. So for kernel threads, it's the problematic part is they freeze voluntarily and they only freeze when they want to.
Okay. So maybe it's like a timer thing. They're checking periodically. Okay.
Whatever. They have to like reach the point at which they want to freeze, and then you need to wait for this to happen.
Yeah, I need how much time I have left based on the allocation.
Well, still, I don't know, 10 minutes.
Okay, I'll assume you have 10 minutes.
Yeah, middle of the.
Okay. So. The other part is looking at optimizing DPM resume all the stages. Right, so this is on again on Pixel 6 running really close to the mainline kernel. So without any optimization, resume takes 82 milliseconds. But you see most of the CPUs are mostly idle, like they're not doing that much. So what happens if you go, say, enable asynchronous suspend resume for all the devices? Good news, it actually works, fully asynchronous. Every single device is asynchronous suspend resume. Because firmware dev keeps track of the dependencies, it actually works very reliably. And it's actually, the funny part here is for resume, it gets 20 milliseconds worse if you enable asynchronous suspend resume. I have some guesses on what it could be. I'll show the suspend part of it and then we kind of get to it. And then what about suspend? It looks fairly idle again, not much going on over the entire time because it's all serialized. 126 milliseconds is how long it takes. If you enable asynchronous suspend resume, you see more parallelization and it's again stable. It comes from 126 to 94, so 32 milliseconds better. Ironically, the way you do asynchronous suspend resume is different for resume versus suspend. Resume tries to do it more efficiently or more smartly, more parallelly, but it actually makes things worse. So why is it not helping much? My guess here is that there's a lot of devices.
So there is a difference in between the suspend and resume async handling. So
And that's what I said. Like they do it differently. I know that.
they do it differently. So the resume part starts all the async threads up front.
Correct. It's trying to be more parallel, right? To make it faster.
Part doesn't do this.
Yes.
So that's the difference.
That's different, but like the resume is trying to be more parallelized, but it actually makes things worse.
Well, yeah,
Right?
okay.
Right?
Turns out.
So the suspend doesn't actually do that. So my lot of devices have really small operations, so they don't have much work to do. But we're kicking off a new K worker, we're queuing work. There's a lot of context switches, a lot of wait for completions. So there's a lot of overhead every time you do asynchronous kickoff and asynchronous work. So that's basically why we imagine you see so much overhead. And then one other thing I'm noticing is like, all of these stages are still synchronous. So you need to finish DPM prepare for every device. Oh, actually, no, before that, do you know why DPM prepare and complete need to be fully serialized? Is there a reason to?
DPM prepare, yes. The DPM complete, probably not.
Okay.
So the reason is that DPM prepare has to prevent children from being added to the device, and then it has to go one by one in order.
With proper dependency tracking, is that something?
Yeah, proper dependency tracking, yeah, because it has to.
No, I'm saying with device links. Is that still an issue?
That doesn't help a lot because you then could. So it's like we again we need to talk about this, but the problem is that if you don't go in order, then you would end up with some new devices showing up and being added to the DPM list in the wrong places, basically. And it possibly can be solved, but I'm not sure if it's worth it because that's a very so in the prepare phase, you are not supposed to be anything like two devices, so it should be very fast anyway.
Not really. I mean, subjectively, not really fast.
Okay,
I mean, I'm sure it's the operations are quick, but when you have like 300, 500 devices, it's getting worse.
Yes, but complete could be done in parallel in principle.
Then the other part is that we also do all the phases. We have hard boundaries between all of the stages. The question is, okay, if all the devices sitting on I2C have finished whatever stage, can we move to the next stage as long as everybody in the dependency chain have already finished that stage? That's something I would like to explore.
Yeah, so that it is like conceivable, but it would require a redesign of the whole.
Very what?
Redesign of the whole.
Okay, so I'll try to make it as like a command line flag. If you enable that, then we'll.
But it is designed this way. Like if we want to the stages to, so we would need to remove the stages basically. Is what I'm saying.
Okay.
Totally.
If it works, you're not opposed to it.
And
right?
then do it separately for every device, like the. So yeah, but possible. But then again, it would require some work.
Okay.
To do it.
I'll try to look into that part, but there's definitely like a huge gap there where we can try to parallelize more if you want to. In terms of avoiding overheads, one thing we notice is basically figure out the really slow devices. So Vasan, this will answer your question. So if you figure out the really slow devices, go set them all async, and then you need to take those devices and all their suppliers and suppliers of suppliers, you need to go set them all as async. Same thing you need to do for the consumer direction. Take that device, their consumer and consumers of consumers. That's the only way you can make sure those devices run as early as possible during suspend resume. If you did that, it does get better. I don't have the graph here, but it gets better than not doing any async. and it's also better than full async.
So a sledgehammer approach to this might be to reduce the number of worker threads involved.
Kind of getting to the next one. So the second proposal, right? So that I could do the first proposal I gave, but the problem is that it's still not as parallel as it could be, and it still has some of these overheads. So what I'm proposing is what called breadth first suspend resume. So if you're thinking about, say, suspend, you go suspend all the leaf nodes in parallel. And once they're done, they just queue up their parent or supplier if they don't have, like, if they're ready to go into suspend. Basically, you don't queue anything that you think might end up blocking. So, and then as you finish, so basically you're walking up the tree and you just kind of set them up. That hopefully that'll mean we won't have that many context switches or that many threads running at the same time. Halfway through, like, or 25% through this patch, didn't get time to finish it before this LPC. But that's something, does that sound reasonable to try? Okay. And that I'm making it on like a flag, like do everything asynchronously, because not every device is going to work that way. The other part, on a watch, we actually measured it fairly recently. 5% of the battery over a day is spent just running the suspend resume. And a huge part of the suspend resume time is the DPM suspend resume stages. And you're doing that for so many devices. So one thing that will definitely help is if more people start doing runtime PM, so you don't unnecessarily, if the watch is waking up to do some background thing without updating a display, why are you waking up your display device, right? Clearly, this runtime PM where early suspend and lazy resume would help, but I don't see runtime PM being implemented as much. I don't know if the interfaces are difficult to understand or what not, but I think general comment is, as a community, I think we have more room to make it easier for people to use it. And one other thing is I'm thinking, can you have like a flag where if you implement suspend ops, you're going to assume it'll work for runtime PM and use it?
We need to talk about this too. So this is in my list of things to do, but for a long time now. So I would like to, for devices that are runtime suspended and do not need to be woken up, to stay there in suspend over system suspend resume. That can be done in some cases, but then strange things appear. Like we tried to do this for the Intel graphics driver i9-15. Audio depends on it. It turns out that audio depends on it, and in order for audio to suspend the audio, you need to wake up this device. And
okay.
So that's a long-standing known problem.
Okay, so but should we try playing with the flag? Says if we set the flag, then we're going to take a suspend ops, and we're going to assume it'll work as runtime PM?
The flags are there, and then...
No, what you're talking about is early resume and early suspend, late resume. That's there, I know what you're talking about. My point is more of, people aren't even implementing the runtime PM ops. So can we do something to make somebody there as a comment?
Okay.
I'm trying to make that more likely to happen. What can we do?
Doesn't that already exist in the other direction?
It does in the other direction. I'm saying,
if you
do it in the other direction.
Runtime PM ops and do PM force suspend and force resume, is that what you want?
There is a problem with force suspend and force resume that they cannot be used for all the kinds of devices for technical reasons. They can only be used for certain types of devices, and the problem is we need to do something to consolidate all of that.
I'm saying, can we call DPM prepare, suspend late, whatever, all those ops together, and say this is going to be a runtime? If you have those ops, is that a flag that is likely to work? I'm not saying it work for everybody.
No. So you cannot use runtime PM. Well, so you could use runtime PMOs for system suspend, but not the other way around. That is generally not working.
Okay. Is it worth trying, or are you saying it definitely won't work?
No, so
Not for everybody, again, based on a runtime flag.
Runtime PM is the structure of runtime PM is just different, and then if you have those stages in suspend in the system suspend handling, then they are not present in runtime PM. So there is no like direct mapping to the other callbacks like from there.
I mean, maybe we can talk about this in a BOF or something.
We
but
are
really like to
starting to run over. So
okay, last slide.
Wrap up. Yeah.
Last slide is S2idle was. We tried to get S2idle working. It always ends up being some firmware bug, and nobody updates the firmware. I would love to see this work, but I'm so tired of like hoping for it to work and never working. So one of the proposals, which is kind of a nice segue to old stock, is can we use/abuse hot plug implementations to fake a really deep idle state? And can we kind of have like a wrapper around the hot plug API so that devices that don't have S2I implementation can still get most of the benefits of S2I? I'm sure Wolf has a lot more thoughts on this, so I'll pass it on to him.
Right.
That's it. Thank you.
All right. Thanks a lot.
How do I find the slot? How do I find the... Where's the presentation?
Plus button on the left.
Plus. Okay. Hello, everybody. So, for those who don't know me, I'm Ulf Hansson, working for Linaro. Sure. I'm Ulf Hansson, and I'm working for Linaro. So today, I want to talk to you about Suspend-to-idle and some issues. So, in Linaro, we have been trying to promote Suspend-to-idle to our members, our vendors, to move from suspend-to-RAM to suspend-to-idle. And I think that has been pretty successful. A lot of our members has started looking into this and converting to use this. So now I'm not just only talking about enabling suspend-to-idle, but actually adding support for the deeper state also, which is it's comparable to the one that we're using for suspend-to-RAM, which makes it slightly more difficult, and there are some issues around this. The issues I'm going to talk about today and I want to discuss with you is not the one that's on the Linux side, but rather on the firmware side of things. So, as Saravana just told you, there is a bunch of old firmwares out there that doesn't support suspend-to-idle, but only suspend-to-RAM. And we have been playing and exploring with some ideas of how we could make use of those legacy interfaces for hot plug to support those deeper states. So that is exactly what I wanted to talk to you about here. So the idea is to use the suspend-to-idle loop and path, but rather than actually calling those APIs to suspend the CPU, we are thinking of using the CPU offline interface to the firmware to put the CPUs into those deeper states. While doing this, obviously there is a whole bunch of constraints that we need to fulfill. So we're trying to take advantage of the benefits of not actually powering off the CPU from the Linux point of view, only from the firmware point of view. So
And we will obviously hit a bunch of scenarios and cases where we need to be careful from the Linux point of view. For example, we don't want an IPI to be fired to a CPU that's been offline from firmware point of view. So these are a couple of problems that I've just discovered by thinking a little bit about this. So this is just a very high-level idea that I want to pitch with you. So there's no code, there's no patches at all written for this. So this is just a simple idea that I wanted to put out there. So yeah, for example, we need to move to the boot CPU, and that one needs to, a similar pattern as we have for Suspend-to-idle. The boot CPU needs to be the last one, and the boot CPU needs to be one that actually wakes up the other CPUs. Additionally, we will have to save and restore the CPU state to be able to continue running from the idle path. We need an entry point to resume for each of those CPUs. That's a couple of things that I've realized, so to say. So, yeah, what's your thought about this idea? Is it completely crazy? Or do you think it's something that can work? Can it be useful for x86, old platforms too?
So we don't need to. For x86, you actually can do a... You mean the ones that don't have like C10 maybe, or so we don't care about them too much. Also, Suspend-to-idle works there, so it's not like we could. Yeah, but I think that the CPU hot plug is too much for this use case. So we don't need to. You don't need to do everything that CPU offline does in order to just leave the CPU in the idle state.
I think to clarify what I think is Wolf's point, she's not saying we should call the CPU offline. We just directly call the firmware to turn off the CPUs, so you skip all those steps. That's almost like a deeper idle state in some sense.
Yes, it is, but you need to be careful about, you need to save all the state, the relevant state, right? And the CPU hot plugs do that, but you just need those CPU hot plug callbacks that save the relevant state, and you don't need some other CPU hot plug callbacks, which, I don't know, move away, like migrate processes out of the CPU going offline. You don't need that.
One thing I was thinking of was the IPIs, for example. So assume that we have 4 CPUs, and one of those CPUs goes into the suspend-to-idle loop, and from the firmware point of view, you will put it offline, but from the Linux point of view, it's online. It's only suspended. And so theoretically, you could actually send an IPI for another CPU to wake this CPU up, but it's firmware-wise offline. So what will happen in that situation? Wissam?
I was just going to say, I think you have that same problem for any interrupt, right? Any interrupt won't be received if the firmware thinks the CPU is offline. It probably turned off the interrupt controller. Yeah. So you also need to migrate all interrupts away, not just the IPI, but all interrupts away from that CPU.
Yeah.
But at least for ARM, that's already almost what we are doing. I mean, when the CPU goes to its deepest idle state is off, and you have to take care of, at least on the geek interface, to make sure that either you will wake up the CPU or you will redirect that to something else. So I don't see that as a major problem by itself. Maybe I'm wrong, but that should be okay. In worst case, you will have to wake up the CPU and go back.
I assume you're talking about, like, when you refer firmware, it's the PSCI? Or do we
yeah, so I'm mostly looking at this from the ARM64 and PCI point
Okay,
of view.
so basically you want to call PSI CPU off instead of like, do we checked do we meet the criteria? So we might end up that the firmware keeps rejecting the call because we have not met the criteria of in this scenario. Like,
Would it reject hot plug? If it's not going to reject hot plug, why would it reject?
no, in the state when basically you'll be making this call in the idle thread, whether that meets all the criteria for CPU off is what I'm like. I don't remember all the details, but yeah, that's my main concern.
I think his goal is instead of using the idle PSI CPU suspend, he wants to use the PSI CPU off, yes. Yes, yeah. And because if I remember correctly, in the PSCI at the end, both functions are ending in the same internal local function. Just the state index is not the same. So we are doing the same at the end from a pure power point of view or low-level point of view. Now there is all these criteria when you accept or reject the things. But I can assume that, yes, if you call CPU off, yes, CPU off instead of CPU suspend, that should be accepted. It's a pure power thing.
So from the firmware,
it's a pure hardware question.
Let's assume if we had done S2RAM, it's going to work. It would have succeeded suspending, right? We just in the same situation. Instead of going through all the Linux steps of S2RAM, we're going to go through all the S2I steps of the Linux. So from a firmware perspective, it's the exact same criteria that's being called in. Yeah.
The main difference is what you allow to wake it up, whether it's IPIs or every other interrupt in the system. That's really the criteria, right? So you still have to do some masking or some IRQ affinity stuff. Right?
It's already the case with suspend-to-idle. I mean, even if you're entering an idle state, you're disabling some system-wide regular wake-up as well.
Yeah. Well, that depends. That's platform specific, right? Some IRQs are like when the GIC goes off. Most of these devices have some other little block that's actually going to do wake up IRQs and then reroute them to the GIC, right? And that can be platform specific depending on the state that's chosen.
No, but wouldn't that be the same issue for S2RAM today?
Yeah, that would be the same to S2RAM, yeah, for today.
And then for S2idle also, it's not every interrupt can wake up, but you still select which interrupts can wake you up.
Yeah, yeah.
Yeah, but the suspend sequence is the same between suspend-to-run and suspend-to-idle. So
For the devices it is, but not for the CPUs. That's.
Now, in this case, that's why the goal is really to not Linux CPU hot plug, but at the end we call that. So it's a pure software point of view and from a system point of view.
Lying to the kernel.
Sorry?
Lying to the kernel is the goal.
Yeah.
Thanks. You can do less work there because in principle you don't need all the CPU hot plug overhead, like migrating threads again, right? So, yeah, then, but from the electrical and setup standpoint, it's exactly the same as Suspend-to-idle.
Yeah, agree. That's what we are proposing this. So you're not going to reject the patches outright, right? That's what you want to.
it depends on how it looks like, I guess.
So what I'm still trying to get my head around like the beginning, the problem statement. Like, is the root cause of is the root problem here that CPU hot plugging is just too slow?
So the root, well, the goal is that you want to quick up the suspend and resume cycle. So and the benefit that Suspend-to-idle gives you compared to Suspend-to-RAM, we all know about that.
Yes, yeah.
So if you have an old firmware that only supports Suspend-to-RAM, the legacy way of doing things, how can we How can we like trick that firmware?
Right. Okay.
So we don't
okay.
have to.
So oh yeah. Okay. Okay. Thank you.
Maybe I should say that from the beginning. Yeah.
Good. Is that only one slide? Is it?
Yeah. It's just. I don't know.
So nobody's gonna be like, it's a stupid idea, don't submit the patch. Okay, cool.
Yeah. So I think my concern is the way how the code would look to manage this, because we don't want a platform hacks in there, and we don't. Yeah, it should be upstreamable code, and that's kind of my concern at this moment. But let's see how it looks like and explore it. It sounds like it's worth exploring, and that was well, nice to hear.
Another thing that we need to not discuss, but as part of this, is how do we make sure that when people are implementing firmware for current chips, how do we make sure they do it right so this isn't a problem, right?
That's a very good point. I mean,
That's my one slide saying
yeah.
So we have been. I mean, obviously, our role at Linaro is to try to convince our members to do the right things, and so what we've been telling them for several years that please move to Suspend-to-idle. It's a good thing, and some of them has obviously been listening. Not everyone.
Most of them do, but even if most of the high premium tier end up doing, there's still enough of not the highest end SoCs that are there that probably don't care about this, but they can still benefit from it.
Okay. Thank you.
Okay. Thank you everyone for coming. So we are thankful to our sponsors again. I think that there will be some coverage of the session, so I would ask the speakers, please, maybe do a short summary of your topics for the purpose of documenting the event. And that's all for today. Thank you very much. See you next time.
When's the BOF again?
Tomorrow at noon. I don't know which room, but it's there in the schedule, I think so. Okay.
What is it? Something you tried? I'm not that familiar with that.
power, and then estate, machin. Et donc tout c'est forcément les développeurs. Et est-ce que là j'ai toujours du mal à appréhender où les resets sont changés, parce que dans un sens on peut implémenter les mêmes fonctionnalités avec des resets. Reset ou bloc. Il y a un mec qui est passé sur un sujet de test. Ça veut dire qu'il y a des problématiques sociaux que je suis en train de faire le chef, machin, tout ça, pour le même d'un seul device, c'est plus simple. Mais c'est pas aussi chiant que le même. Le nom, oui, j'ai déjà vu peut-être faire des talks et tout, après je les avais interagi. C'est là aussi, c'est là aussi. C'est un mec, hein? Ne demande pas à Linux qu'est-ce qui est vraiment ça. Configuration plus poussée du système. Je sais pas, mais en tout cas c'est toujours en fonction de nom interne, comment c'est modélisé, ça parce qu'actuellement il y a. Bon là ça va, là, c'est quel? Moi je viens de faire ça pour comment je suis son attitude, à force, est en train de lui desservir. Parce qu'en gros, si tu veux, autant avant, je sais que qui prend les trucs il y a d'autres personnes qui sont là-dedans, et donc ça définit la logic source et quelle plateforme système on choisit. Est-ce qu'il y a des choix sur quel device on fait ça? Parce que pour définir plus, parce qu'un device système actuellement c'est tout le monde le dit, mais on va dire par exemple le bordel PCI fait pas de système parce que moi et actuellement il n'y a pas de support. Je pense que le problème c'est que il y a peut-être des endroits en fait dans le carré où tu as des gens qui ont introduit ce système et qui sont devenus par paternité, on va dire, et qui en fait se retrouvent pas forcément la personne la plus adéquate. Ah non, mais faire des bits sans couper le contrôleur. Oui, je crois que c'était je crois. Je suis pas sûr, je crois. Les revues, il comprend rien au sujet technique. Dès que c'est pas le mot habituel du truc, ouais, mais il faut ensuite il faut ici comprend pas, c'est donc on n'a pas de moyen par exemple. S'il comprend pas, c'est pas l'idée c'était. Ou alors s'il comprend pas, il y a des modes ARM ou de machin. Pour runtime, ils disent bon bah ce là il va pas compter pour le donc ça serait soit Userspace, soit ABT, soit lâcher vraiment, soit en fait, customiser le système qui actuellement est fixe. Une fois qu'on a démarré, le système, on sait ce que ça va être. Bon, mais écoute, c'est toujours le même sujet, on fait plein d'idées possibles. Ouais, ça doit avancer parce que là, en fait, on se fait mal. Ouais, mais ça va stopper le. Oui, on va avoir ce système-là, mais on peut avoir un entre deux. Lui ne se système pas, on touche pas, c'est pour le mettre. Moi, je le mets exactement. Ah ouais, c'est problématique, c'est vraiment de plus en plus. Oui, mais tu commandes le code pour pas le faire, d'accord. Oui, alors tu peux faire
que là, tous ces sujets d'ajustement des facteurs en fonction de en gros, l'impact sur le thermal des actions qui sont menées, si je vais des tailles de l'injecteur, du fan, du swapping, etc. Il y a tellement de facteurs que c'est hyper dur de faire un modèle qui est correct. Oui, mais le modèle accurate, il est en fait moi je pense que garder un grade ne veut pas dire que on va sacrifier le côté apprentissage. Parce que ce que je propose, c'est pas de faire un utilisateur surchauffe. Au moment où ça peut être les raisons, c'est soit le premier temps de vitesse qui est trop long, qui peut varier, parce que tu peux avoir qui ne concerne pas des différences par rapport à l'épisode pour mitigation que tu as eu. Ce que je disais, c'est que l'ambiance température change de 2 degrés, et puis ça change tout. Donc ça prend. Oui, ah oui, on va taper plus de mètres. La vitesse de changement de température, elle est vraiment linéaire, tu peux vraiment interpoler. Si le guide doit rester un, moi je fais rien en thermodynamique, mais j'aurais tendance à penser que c'est justement pas linéaire. Genre tu allumes un fan, tu fais de l'idle injection, du swapping, en gros c'est pas linéaire la façon dont ta température va baisser, ça va être, je sais pas, c'est pas linéaire, mais du coup comment tu vas pouvoir interpoler, comment tu veux faire ça. Il faudrait que dans l'interface, il sera linéaire, mais il ne sera pas linéaire dans le sens où il n'y a pas de référence. Je pense que c'est l'EPP maximum, parce que la vitesse de changement de température maximum. Si tu peux mesurer, la pente comme ça. Si tu as le réglé en dessous, la pente sera comme ça. Si tu as les pétales en dessous, ça sera comme ça. Même au centre, je ne suis pas sûr. Moi, je me suis dit, pas sûr que la température, elle va vraiment baisser. Parce que c'est ça que tu mesures, c'est la température résultant sur le GPU ou le système ambiant, est-ce qu'au moment où tu vas baisser, toi tu baisses ton OPP de 1200 à 600, est-ce que ta température elle va vraiment faire ça, ou est-ce qu'elle va faire ça, ou est-ce qu'elle va faire ça, elle va faire ça, voilà, elle va faire ça, et là elle va faire plutôt un truc comme ça. Au début elle va pas beaucoup baisser, et puis quand ça va enfin avoir de l'effet, elle a le changement de fréquence, sauf que quand tu fais une dérivée, est-ce que tu penses qu'on va rester avec une liste de... Ouais, mais si tu fais ça, c'est thème des CMU, c'est-à-dire qu'au début, ta vitesse de descente est faible, et après elle s'accélère, mais donc si tu interpoles sur le... Là, c'est des suppositions sur le début, tu vas dire, ah, et baisse pas bien vite ma température, il va peut-être falloir que je baisse encore plus l'OPP, sinon ça va encore durer je sais combien de temps, et donc je risque de overshoot et de passer mon volume, et tout à fait sur ça. Si tu as le temps de descendre la température, elle n'est pas linéaire, on va l'interpoler avec le début. Et du coup, c'est là que je me disais, mais est-ce que comme ces épisodes ils sont quand même récurrents, mais changeant en fonction du contexte environnemental, c'était une température de pièce à 28 degrés ou je sais pas quoi, comme ça, ils sont à 20 degrés, c'est pas du tout le même comportement de pente. Ça a tellement de paramètres, est-ce qu'il n'y a pas de l'apprentissage à faire en gros. Est-ce que moi le problème comme ça, qu'est-ce que tu fais, moi tu me dis exactement. Moi le pas que je fais, c'est qu'à partir du moment où tu as la température qui diminue, le but c'est de pas rester dès qu'il y a une température, dès qu'il y a une vitesse, une variation de température. Mais ça c'est dès qu'il y a une vitesse de température négative, normalement, tu es capable de mesurer le temps qui doit rester. Dans ce cas-là, tu es obligé d'avoir pour atteindre on va penser au large de device qui représente si tu es dans une hystérésiste pour te dire bon bah c'est pas une vitesse alors que en fait c'est pas forcément la même chose. Si tu as une vitesse inférieure, tu arrives à la descendre. Là il y a un truc. Je pense que à mon avis c'est pour ça que je pense que ça t'utilise l'état de ta vitesse négative et l'état de ta vitesse juste avant, juste les deux états tu es capable de mesurer combien de temps tu vas dans combien de temps tu vas aller dans l'autre état. De telle manière, à part être en train de faire ta feuille, tu restes là-dedans. Et après tu réajustes en fonction de est-ce que j'ai pété la consigne, j'ai pas pété la consigne. Je pense que tu vois, et du coup, Donc, par exemple, ce cas-là, il n'y a plus de capacité pour un autre. La crainte que j'ai, c'est que tu peux avoir une température un peu plus moins chaotique, mais en tout cas, le fait d'utiliser le timer, ça va se réajuster au maximum. Ça va à quelle vitesse. Et du coup, c'est variable. C'est ça le paramètre. Si on fait une montre dans le chose, c'est là où on extrait le maximum de performance. C'est ça le but. Oui, c'est simple pour faire du timer. Tu mets la fréquence minimale, mais le timer était déjà placé pour le. C'est ça. Avant de réveiller ton kilomètre entre overshoot pour un max de perf, mais dans l'enveloppe thermique qui est acceptable pour les moindres utilisateurs. Et ensuite, là, il se réveille forcément en constructif. Donc, est-ce que vous devez savoir, il faut savoir régler, comme je disais, en passant non plus pas trop de temps, plus tu vas avoir des gains. Et ensuite, là, c'était intéressant, sur le système, il y a 35% du temps qui est passé à rentrer en suspend ou à sortir de suspend. C'est un truc de fou, c'est pas non plus énorme, mais c'est quand même significatif. Même 3 à 5% du temps, tu vas en faire des opérations rentrer, sortir de suspend. Et par contre, il y a un truc qui ne savait pas, c'est que normalement, quand tu passes ton doigt comme ça sur les Android, tu n'as qu'un framework justement d'optimisation de ça. Bon, moi, je ne fais pas d'Android, donc par exemple, tu passes à ce qu'ils appellent les HL, et dedans, tu as serveur, un petit peu de logique d'algorithme, et par performance, chaque plateforme, le HL est censé être une description d'interface, et toi, tu remplis les applications, ça s'appelle un bout, donc des transitions d'éléments, et quand tu passes, par exemple, ton doigt sur le terrain, normalement, tu passes ton doigt sur le terrain, tu as un élément qui dit, je suis en mode alphatique. Donc là, normalement, toi, le device enregistre une callback, tu débutes à la intensité, et c'est censé être super rapide. Quand tu as une application, tu bascules en mode planification de l'information, tu vas passer en mode active random. Donc ça, normalement, tu es censé, depuis Userspace déjà, de commencer à comment ta application se lance, tu sois déjà dans un état mis en ta possibilité, on ne comprend pas trop en fait, cette histoire de premier frame, raté, etc. Normalement que ce soit sur du rendering. Et comment est-ce que tu... Ouais, ça je sais pas quel c'est. Moi c'était super intéressant, ça dépend de côté. Pas dans tous les cas, est-ce que, vu que c'est des systèmes qui font beaucoup, je rencontre sur truc, qui font complètement réduire le temps qui est passé de toutes tes parents ensuite à la sortie. Est-ce que tu peux me dire, est-ce que tu restores tes... Non, c'est ça quand même. Peut-être ce qu'il faudrait, c'est un truc macroscopique, et même sur ce framework, l'idle state, l'intégration, Suspend-to-idle state, et c'est le système qui appelle qui indique dans quel état tu vas. Là, tu vas PMQS, le but c'est d'arriver à ça. Parce qu'avec PMQS, tu peux donner quels sont les performance levels que tu veux atteindre, et ça peut empêcher des idle state oui, c'est l'idle, si tu veux attendre les latences. Et là par contre, je parle global. C'est-à-dire que sur l'idle state du CPU, on parle de manière globale. Non, c'est bon, PMQS c'est global. C'est pour tes applications, elles peuvent dire moi je veux pas de temps de latence. Mais ça fait tout le monde est censé faire uniquement sur le CPU. Normalement non. Tu veux du dev, il y a du device et PMQS aussi. Je veux aussi je suis en train de faire de la visio, donc je veux pas de latence plus que ça. Et donc par exemple j'ai mon appli, du coup je vais pas me mettre dans tel mode de power parce que sinon je vais avoir même si je veux pas beaucoup de ça, mais tu peux aussi avoir en fait des trends de et c'est ça que je dis en fait, c'est qu'en fait dans le système tu dis moi je suis pas sur les comme CPU idle, tu sélectionnes la sélection positive. have any agenda. On va chasser. J'y ai pensé en argumentant un peu. C'est facile quand on bosse pour un client. On implémente une solution de façon spécifique et on l'upstream et comme on a une solution, j'ai besoin d'un work, mais de manière théorique, c'est pas suffisant. Oui, ça peut arriver. Déjà, on arrive à avoir du l'algorithme qui fonctionne, ouais, c'est ça. Dans 10 ans, on verra. Et si déjà on arrive à avoir des devices qui passent au suspend, sans gérer tout leur rallye, leur reset, leur régulation, c'est déjà un gros pas. Et en plus, ça règle aussi le problème avec
Because the next session is on the
même si vous utilisez le même c'est pas le même power law.
you can go with the matches.
Ce groupe d'IP en si power law,
For the meeting. The meetings are scheduled
ouais.
yeah.
Mais c'est l'avantage des power domains qui sont gérés de manière implicite. Alors que tout le reste, tout ce qui a été, en fait, on voit quand ça a été introduit. Par exemple, des blocs, ça n'a toujours forcément parce que ça marche bien. Ok. Et donc ce générique power domain, ça, donc le système on veut en a parlé, ça ressemble à quoi?
Je sais pas, j'ai pas encore vu ces papiers. Vendor process. That's right. So this is a version. Certainly. The complete thing is 3605. Yeah. The rule is close. So, okay, first is only this. I think before the conference came down. That's our session. Oh, only ours. No, Ricardo. What about the section memory allocation between the one and the this is very interesting.
Pour chaque là j'ai les 80%
But
des
that
vendor cost de manière générique. On aura pas
it doesn't consider that.
plus à faire comme ça.
I think this one therefore will happen. Correct? Yeah. Nobody opens us.
Sinon il faut changer
So I think that it's okay. We can take 1 hour for the meeting.
énorme sur tous les devices, toutes les plateformes qui marchent pas. Même si ça c'est fait bon. Le vrai façon de le faire parce que ça détruit le hard comme il faut. Oui, mais en fait, il y a déjà plein de choses qui n'écrivent pas le hard dans les devices. Donc cet idéal, oui, mais c'est un idéal. Déjà, oui, il y a plein de jeux qui sont sur une plateforme test.
This is another camera. Total PAD one. Yeah. This is our tower facing. One is the speaker. What is the third one?
C'est cool de te rendre compte.
Interesting. Yeah, somehow I don't relate it. Speaker. Oh, it's back. Yeah. See that two screen. These are the closer. Okay. From back side. Oh, back view. That's front view. So, not like rear view.
Ton Richard a eu un enfant. C'est un peu compliqué. Ah non, c'est tout le temps Maréchal,
is good, right? Yeah, Scratch pattern. Yeah. Oh, is it? Yeah. Because that's, I mean the template. So that was the 16 lines. 16 lines, sir? Yeah. So here only 4. Yeah. And also that the bus. Convenient. Very, very convenient. Oh, good. And in each bus station, there's the smart screen to show when the bus is coming. What's the time? The next time. So in my hometown, in Hyderabad, so only 2 lines. Okay. That's nice. No, but most places, no, expanding is needed. I see. It doesn't cover complete. I see. So 2 lines means less coverage. Less coverage. Yeah, you're right. But less complexity. That's complexity less. Very good search. They have the outlets near here. Outlets, huh? Which area? This one? Rural. No, the AMICIS. Outlets by AMICIS. AMA group. This one. AMICIS. So everything looks like it. Yeah. 3 to 4 kilometers. there's one which is the slide I have to finish now. Yeah. Just change the colors. There's one for Lohan to talk about memory. Memory. I think it's recording, by the way. I think it's recording. And then you were talking something. I see. Public to worldwide. It is. Yeah. Okay. I didn't know if you were talking about something. No, we didn't. So there's, and then a final discussion of the vendor pass-through. The vendor pass-through is exactly, I think, the part you're more interested. Okay. That's how do we send that log to the driver, and the driver doesn't know what the log is contains. Okay. Interesting. The same thing yesterday we did. Yeah. That's the first. So it's not recording, it is it's stopped. Yeah, it's a stop. It's not a record now. It is recording. No, 194. I think it's that people can see. Oh, live. Live is live. Yes. Live stream. Oh, I see. You shouldn't talk about the stock price or. Yeah. How do you change the color here? How do you change the font color? I'm being stupid, I cannot find it. Hello? The building is here. This one? Yeah. This is the text one. Yeah. Okay. Thank you very much. Okay. Oh, this is the card that there's no audio, no voice. It's on.
It's on.
effect, camera will turn towards it. That's the user frame. LPC. Hello? Hello?
No, that's me.
What? You're controlling?
No, I can hear you.
No, just we are checking the camera is turning towards the audio.
Wait 5 minutes and I can join the session.
It's 3 o'clock or 2:30?
3 o'clock, but I can join. I think I can take over the presentation at that time. I'm not allowed now.
Okay, good.
Share content. Let me connect the notebook. Battery.
Go to battery.
Yes, please. Thank you much. I usually prepare the slides the day before, but never 5 minutes before. This is a new thing.
So what's the last topic of this session?
It's about discussing how the vendor pass-through. We were discussing if and how can we send some parameters to hardware that is not documented.
Okay,
That is
good. Yeah, that's
very important.
Yeah. It's for the whole thing.
No, it's for us. It's for everyone.
For everyone. Okay.
The one from Logan is the memory allocation.
Share memory. Okay.
That is his main program.
Allocation. Allocation.
The thing is when you have a GPU, you have a CPU, you have a camera, and you have a screen.
I think complete pipeline. What is the better buffer mechanism?
You cannot allocate 1 gigabyte of contiguous memory at the boot time because you lose that memory.
That's right. Yeah.
And you can.
But normally nobody does that unless use case requires. No?
And I think in industrial images they do that. They allocate. They know how many buffers they're going to use.
Oh, the boot up time itself. But
The pilot
camera is the only use case for that?
is camera session.
No, my question is whoever allocates the memory at the boot, right? Camera is the only use case?
The ones there's probably more use cases, but the one I have seen it's for cameras, and you allocate. So you have an industrial camera. Your main case is going to be camera. So in the bootloader, you say, I don't have 2 gigabytes, I have 1 gigabyte. So the system doesn't even see that gigabyte.
Oh, that's the card memory.
Yeah.
Card. This is not allowed in Linux. This is not allowed.
I know. It's not allowed. But that's how I've been doing it. But this is a very bad strategy.
Yeah.
You want to dynamically allocate buffers. You want to be able to dynamically allocate those buffers, and the buffers that are less restrictive to your requirements.
But at the end of the day, I think in the Linux, the system is the one people allocate the memory, right?
Which one?
different system. That's the difference.
The PMA buffer is how
it's
you...
not a continuous amount.
Exactly. And
Yeah. No,
how do you allocate the PMA buffer? That's the question.
Using heat. Using heat, right?
Yeah, but what is the requirement for that heat?
No, the challenge is by default, right? Linux kernel support cached system heat, but that is virtually contiguous, not physically contiguous. The challenge is that you have to remap the page tables. Okay. So the Linux page table is that 4K or 16K. 16K is the right? So that it will be a big effort that you map the page table one by one. If you have 4K, pixel. Oh, you want physically contiguous memory? There's one of the options. But if it is only centric use cases, like for example, complete use cases camera, only one use case, focus on it, maybe there it works. I think that the easy way is from the kernel side, it should be allow us to allocate a big size page, right? It's more than 60 kilobytes. Big page.
But there's a concept of folios now. But again, the problem is, what are the hardware requirements that every device is going to... You have a memory. How do you make sure that memory can be used by all the hardware that is going to use that memory?
Second point is how, for example, if you use the bigger pages, right? Maybe there are applications where they need small amount of memory. In that case, fragmentation happens. That's right. Yeah. Good thing now that's good for me. We can see, of course. Please. You're in the middle. See, you're in the middle. Good. Earphone.
It should be in there, right?
Yes. Send it to me if you want.
I put them on the website, so if you go to the LPC website, they're there. I uploaded there, but not on DVD because the option wasn't available. LPC Latino, see.
Microconferences. Complex camera. I've loaded the one. I don't know if you have made any change after I made it.
No, I haven't made change. There's still a few points I'm not entirely sure about. Could we introduce them by saying that the points that are listed there are recollection, summary, recap, whatever, of the what was expressed yesterday, but that not everybody necessarily agreed on every single detail.
I think you're the only one that agreed.
Yeah, but that means not everybody, right?
Okay. We can say that there's a different opinion by Logan.
Totally fine.
Take presenter.
Oh, you have to take presenter first, okay.
And then you need to upload.
Okay. Complex camera.
Like here. Buffer allocation. But you don't want to change the default. Upload. Uploading.
Okay. Yeah, I didn't know how to take presenter before.
Before we fight. This is for you. I didn't buy it.
Well, I thought so with the logo. It would be impressive. Did you draw that overnight?
They
That's a speaker presentation.
They sent it in for the. I also got the one. I haven't opened it. I don't know what it is.
Chocolates.
It's poison. No. Do you take the risk?
I think so, because if you wanted to poison me, you had ample chances to do it yesterday.
That's true. Depending on how the discussion goes, we let the people take a break or not, right? You make the break optional. I don't know who. Is there anybody from the? Have you seen David Arnold from the? But I haven't seen him. There's a metal detector in the entrance. I can help taking notes for the same for your house. Yeah. Fantastic. If you take notes for the first one, that would be great. And for the last one, unless that's ours and me.
They're remote, the position.
I don't know how.
Perfect. Okay.
Try.
Hello, hello. Thank you very much. Thank you very much. Let's give it a couple more minutes to see if some more body is coming in. Okay, that's it. Thank you very much, everybody, for coming. Now we are going to do the complex camera micro conference. And first of all, thanks to our sponsors. We couldn't do this micro conference without them, and it's great that you support the community efforts. Then remember, there's an anti-harassment policy. It's in the website. Please go through it, and if you feel that you're being harassed, please use it. And yeah, now let's go to the fun part. So, Complex Camera Summit recap. So yesterday, a couple of vendors, Chrome OS, Video for Linux maintainers, and libcamera, we joined to discuss about how we support complex cameras in Linux. We already support some of those cameras there, but it's complicated. So we discussed how can we improve the situation. We wanted to do it here, but it was it's difficult to get tickets for everybody, and it's also we wanted to have more space. So we joined there, and this is a small summary of what we discussed yesterday. This is what most of us agree on that meeting. There's some disagreement by someone, but no one. But I think everybody except Lorana agrees, and I think you agree to 99% of the slides. You can scream at me. You can raise your hand to the points that you think are horrible. But I don't think there's many horrible stuff there. So first of all, it's like, complex cameras. Why is this complicated? So there's two aspects of complex cameras that make this complicated. One is the technical part. We're engineers, we can fix it. The other one is the political part. Yeah, we have never been trained to we are not trained for that, and that's the part that is more complicated. So just to give you a broad idea of what is going on, when we want to support complex cameras, first of all, what is a complex camera? It's usually the cameras that live in your phones or the MIPI cameras that exist in modern notebooks. When when we want to support those devices, we have some problems, right? So first of all, if we want to use it video for Linux. So for memory-to-memory ISPs, the abstractions, they are not really useful. We don't get too much from them. So formats, controls, pipelines, sub-devices, it's something that doesn't give us anything extra for implementing these drivers. Then when we want to obtain a frame, we need to do a lot of IOCTLs to get a single frame. So we need to enqueue a lot of buffers, we need to dequeue the buffers, and all of those operations are expensive and they take time. Then there are some features that we missing in Video for Linux, for example, fences that will reduce the needs of some of these IOCTLs, but unfortunately they are not implemented in Video for Linux. There were some attempts to land fences in the past, but they didn't succeed, basically because they couldn't prove that they were useful. There's no abstraction for advanced scheduling, so when we look into these complex cameras, there's a way you send multiple buffers to the ISP, and the ISP can make some decisions which of the frames are more important than the others. Imagine you are with your car. Some of those buffers are more important than... It's better than you not crash if your Skype conferences crashes. Then it's support for anything different than a frame. Video for Linux is based most of the time in frames, and slide support it's missing. Multi-cameras and multi-context support. Multi-context is going to land very soon. Multi-camera fusion, I think there's no API there yet. And then when we want, Video for Linux is based on it has an ABI. And if we want to modify that ABI, we need a big consensus with the community. We have a special device that is doing something unique. If we want to make an ABI for that device, we need some consensus and standardization. And sometimes it's for something that is one-off. And yeah, so when we look how can we implement these devices in DRM? And because sometimes when you look into these devices, these ISP devices, which are memory to memory, they could look like a GPU, right? You send a buffer and you receive something in the output. And what is the technical challenge for doing that? So first of all, if we support the same hardware into subsystems, there's going to be a big fragmentation in the ecosystem. So we are going to divide our efforts in two worlds. And then DRM people, they are not, there's not that many camera experts in the DRM subsystem. So that is bad, that is a big challenge. The other is, if we, in DRM, the APIs is custom. You don't have a high-level API like in Video for Linux. When you implement a custom API, you need to introduce some trust into the vendor, in that they're implementing the API in a way that is secure. You don't want that API to be able to control the image engine. And you need to trust the vendor, and reviewing that code is more complicated. And then custom APIs are more challenging for Userspace. If you need to make an application, it's easier to support one API than one API per hardware. And of course, they are reviewed much less than a standard API. So this is the technical part. And we got a minimal agreement, which is that Video for Linux, we want to get a complete list from vendors of what are the features, the technical things that are missing in Video for Linux to support complex cameras. We want to fix it, and if it cannot be fixed in a reasonable amount of time, we will not block memory-to-memory ISP drivers in DRM subsystem, in principle, assuming the DRM people want it. We cannot block this development for years just because we cannot have the same performance, the same features. So that's for the technical part, right? And that is the easy part because we are engineers and yeah, this is easy. We are trained for doing this. Now the complicated part. This is the non-technical discussion. Yeah, and just to give you some background, what is the problem? So the problem is that some ISP features cannot be documented by vendors. There's reasons for that. One of the reasons is some of these features, they might be patented. You cannot even look into a database if this feature is patented or not, because then you are tainted. And then some of these features represent a competitive advantage to these vendors. So this means that when they want to differentiate to another vendor when they make their ISPs. And of course, and they don't feel comfortable releasing the information on how to use this feature and how this feature works. Then in Video for Linux, we have the policy that we only allow control loops, proprietary control loops in our API. We don't, if there's something that needs to be controlled from Userspace, we need to have all the documentation for those bits. We don't need documentation from things that are written from the kernel to the hardware, but from everything that the user can control, there should be a documentation. And yeah, the current Video for Linux policy is to disallow any use of undocumented features. So you cannot have any way for using these features. And there's also the big fear that if we introduce a mechanism to use these features, then most of the driver is going to be undocumented, and then the driver is going to become useless. And yeah, this is the problem. And no, we didn't agree on anything. And we need your help to figure out what is how other subsystems are doing this. What would be the right policy? What would be the right solution for this? And we are going to have 2 hours to discuss about this. There were some solutions on the table. One is that why don't we describe a canonical ISP? We can say, okay, this is a basic camera. This is what a basic camera should do. Basic camera should be good for whatever we decide. Video conferencing, taking photos. And then when a vendor wants to publish a driver, the driver needs to be fully documented for those canonical features. This ABC needs to be documented. Everything else, you can use it via a vendor pass-through. This is a mechanism that exists in other subsystems, and it can be used but it has challenges. One is that vendor pass-through security is complicated. It means how do we guarantee that this pass-through is not going to affect the original pipeline? How this pass-through is not going to write into the DMA engine and screw the memory? Then is that even if we have this canonical camera, we are going to need vendor support to use untested combinations of sensor lenses. What does it mean? You have a camera. The camera usually is tested by the vendor by a specific combination of sensors and lenses. And a lot of the calibration is based on these 3 components, the sensor, the ISP, and the lenses. If you modify any of these 2 extra components, you need to retune the ISP. Retuning the ISP means you need to know a lot of things about the hardware. So what happens? Shall we only have support for combinations that have been tested by vendors, or should we allow any kind of combination? Then the problem is defining the canonical ISP. So most likely have a very different opinion of what is a good camera, a good enough camera to another person. So if you ask me what is a good enough camera, I will tell you a camera that can be used in Chrome OS. But that's because I work in Chrome OS. If you ask somebody else, is going to give you a different definition. Finding what is the canonical camera, it's complicated, and we need to find a way to arbitrate what is a canonical camera. And then the other challenge is, what if we say this is what you have to do, and then vendors don't implement anything else but these very basic features? Are we limiting the innovation to our vendors just by saying you only need to implement A, B, and C? Then we have another proposal, which is, vendor, don't tell me anything about your proprietary stuff. Just document what is used, document the basic features, and everything else cannot be modified ever from Userspace. So if any of these advanced, modern, secret features, they cannot be modified they will never be able to be used from Userspace. You can have your out of tree driver that can support it, but it cannot be upstream. And then the challenge there is that if we tell to the vendor they have to support a downstream driver, they will most likely only have a downstream driver and they will not give us a driver for the canonical camera. And then having a driver that is downstream is very difficult to maintain by distros, and it's an out of 3 patch. It's everybody that has been dealing with out of 3 drivers knows how complicated is that. We have 2 hours today to discuss. I hope we can hear your opinions. We need help. Help us, and that's it for that part. And then we were all specifically talking about the IPU6 driver, the IPU driver from Intel. It's been quite popular recently because it's for different reasons. And we want to be able to use those devices as soon as possible, right? And Intel has released an ISIS. So the hardware from Intel is divided in 2 parts. One is the capture part. The other one is the ISP, the processing. The capture part has already landed kernel upstream via Video for Linux. And Intel, they have a prototype using DRM for the ISP part. The decision to use DRM was technical. When they looked into they use Video for Linux, they look into DRM. It matched much better what their hardware was doing compared to that's their opinion. That's what Intel is saying. It's not what I'm saying. That's what Intel has said. Intel will share the details of why they have chosen this. And what we agreed is that there are 2 discussions in the table. One is how the data flows from the camera, and the other is what kind of openness we want to the camera. And the compromise from the Video for Linux, the people from Video for Linux that was there, is that first they are going to review the data flow. And once we all agree on the data flow, we will take the discussion of openness, which registers should be described, some registers, which registers cannot be described. And that was 8 hours of fun, intense fun yesterday.
More than 8 hours.
What?
More than 8 hours.
More than 8 hours. But it was fun. We had fun. It was the first time we managed to have so many vendors in the table with us. And so we are very happy to have this conversation. And at least I think we know more about the other stakeholders in DRM. We know about all the stakeholders when we're talking about complex cameras. That's it. That's all from my side.
Can I immediately?
Yeah.
If we could go back to the technical premises, because I think if we don't set them straight, it's probably hard to have a discussion on what's coming next. So first of all, I would have liked this discussion that happened yesterday to involve all the people here and not be done by closed door, because the technical discussion, I think, is worth an analysis. So at each point, I understand that something, it's like fences is not implemented in Video for Linux. Like fences, you're right, they're not in Video for Linux at the moment. For each of the other point, I think we could go in great length and discuss, like the first one, I have myself implemented at upstream an ISP driver for the Raspberry Pi, which has a single entity. This is not a requirement, this is an opt-in feature. Controls, pipelines, that's not something which is mandatory.
No, nobody's saying that it's mandatory. What it's saying is that this
So it's not a technical challenge then?
The technical challenge is that we don't have any added value from all those Video for Linux abstraction.
And nobody forces you to use those.
Yeah, but why I'm going to use a subsystem when it doesn't provide me any added value?
Because it has other means it has been used for other drivers. Yeah. We have been using those. We have been using entities for the upstreaming of the Mali drive, ISP, an example, because it allows to do validation of parameters. But for other, we haven't had to do that. And also when you speaks about tens of system calls for obtaining a frame, I can count QBuff and DQBuff, or maybe like 5 device nodes.
How many buffers do you have to queue to get one image? You need to send control buffers, you need to receive...
An image and?
No, but the control buffers are not only one.
how many of those do you have? That depends on the architecture.
Yes, but we have seen cases where there are tens of them.
Absolutely, but
No, 10.
10, not tens.
10.
And maybe not even 10. And also when you talk, you have been there in the discussion, we presented multi-context support, that was Monday. And we talk about multi-camera, which is something that is, we discussed that on Tuesday. That's something that doesn't relate to video for Linux. That logical camera happens in Userspace. So it's not something it's missing as a feature in the framework. That's,
okay.
It's a different level of abstraction. Personally, since we discussed that a lot, I'm a bit displeased to see this kind of points here because most of them are fair to debate, but presenting them as technical challenges, to me, it seems like misleading, and I'm very displeased about that.
Okay. You need to understand that when we, first of all, the conversation happened yesterday, and we had 4 hours to make these slides, and this has been the common agreement between everyone. And
I disagree with everyone.
And that's fine. I mean, this doesn't represent your view, and that's completely fine. But that represents the view of the people that has been in this meeting.
Not mine.
Which one of the, I mean, we can discuss which one are the points that are here, but we have edited most of the slides to satisfy, I mean, I don't think any of these points that are in a slide is something you disagree on. Otherwise, we have been removed them.
Oh, okay. So I agree with Jacopo, for instance, for the first one. I think it's misleading to say that there are lots of features in VFile that are there and as abstractions if we don't need to use them, and I think that VFile provides value. And we could go through all of these. If you think about things like no abstraction for advanced scheduling, there's none in DRM either. You don't have a DRM Userspace API.
I'm not comparing against DRM. I'm saying
you are on the next slide. So you're listing points here that are presented as technical challenges for VFile 2, telling the audience VFile 2 has these problems, and saying on the next slide with considering DRM as well, and you're silent about the fact that they don't exist in DRM either. I think that's misleading.
There's no need for advanced scheduler in DRM because you can push whatever data you want. You don't need that API in DRM because you can give the hardware exactly what it needs to do the scheduling. That's the difference.
You can do that in Video for Linux too?
Not today. I mean, it's something we need to implement and agree on, but it's not there yet. All these challenges, on most of them, we can say that we can try to fix them, right?
No, that's something. I mean, the scheduling, if you have a single client in Userspace, you can do it in Video for Linux today.
No, you can't. But with that,
presumably with multi-context support, I believe.
Presumably with multi-context support, you can do something like that.
I'm happy to see that you have made changes to the slides since I first saw them. But I also feel that there is a bit of that there are things listed here that are not really necessary technical challenges or problems in Video for Linux, although those exist as well. But we today, or yesterday, we came up with a good list of those that we can improve. But I think you also said that there is no benefit from using the Video for Linux as such. But I don't think that is also true because. If you think of ISPs, some of them operate from memory to memory. Others can use sensor input as such.
This is just for memory. This is just for memory to memory ISPs.
Yes, but
this is only. We are only talking here memory to memory ISPs.
Right. But still, you can have the same hardware.
Yeah, but
on an online ISP as well as inline ISP as well as an offline ISP. So then you would have 2 different APIs.
That's a different discussion. This is specifically for memory to memory devices.
Right, but I don't think that memory to memory operation is something that defines a nature of an ISP in such a way that it should have an entirely different API. That indeed increases the interoperability challenges in the ecosystem. So
I mean, you have a set of features that you don't want to use. They don't offer you anything. I think we can agree on that. We can agree that those devices don't use controls, don't want to use formats, they don't use the pipeline, they don't use sub-devices. Right. Yeah, but we are talking about these specific devices that don't use any of the features from Video for Linux. In some ISPs.
Sorry, some ISPs are scalar, and we decided to represent them as sub-entities because validating the link format within the sub-device, within the entities, allows to do validation of the parameters format. That's correctness.
But it's also correct that there are some devices that they don't use those. They don't use any of those features.
I agree with that, and again,
that's what
we've been upstreaming one of those not longer than 2 months ago, and
that's what this line is saying.
Yeah, but
it doesn't say anything more.
I agree with that, but that's not a technical limitation of V4L2. You could say there are features I don't want to use, and that's totally fair. Nobody disagree with that. But saying that this is a challenge, I don't see why you would like to present that as a challenge. That's my point.
It's a challenge that you have to implement. You need to implement a lot. You need a lot of overhead by using. When you implement a driver, the driver is going to be bigger and more complicated because you need to give support to features that you are not going to use.
Again, they're opt-in. Nobody is forcing you to support them. And while we disagree on that, could you maybe expand the last point? Because with that one, I really had trouble to understand. Subsystem ABI, you mean that if you make modification to Video for Linux, that you have to modify the whole subsystem, I presume?
I'm not saying that. I'm saying that, let's say we need to implement, a new feature, because a specific ISP has a specific feature. If you want to do that in Video for Linux, you need to modify that in the core, right?
It depends.
I mean, the only we don't have we disallow custom IOCTLs in Video for Linux.
Oh,
yeah, we do.
No.
Yeah, we do.
No.
We never It was never disallowed to have custom IO cons. It's just that up to now there were no need for that. Okay. I guess in the past we actually had 1 or 2 drivers that had, but they were just versions of the existing ones, so those were converted, but just like that. I mean, nobody ever came us with any need of custom IO control so far.
If I may say just a bit, there are actually a couple of drivers using those, such as the OMAP3 ISP driver. But since that the same device-specific configuration such has been moved to video buffers, so there has been little need for device-specific I/O controls.
Yeah, I can add a little bit to that. Usually when a driver wants to introduce a custom iOctal, you discuss it and we discover it's really not specific to the drive. There are other devices that do the same thing. So then we ask to make it a generic standard iOctal. I think based on the discussions that I had, one of the differences between DRM and Video for Linux is that DRM always had MESA. So if you had a driver doing lots of vendor-specific stuff, the requirement was, as I understand it, that there is a MESA support for it. So you have, because applications or Userspace, they are expected to use MESA as sort of the middle layer, and MESA will translate to the device-specific things. Now, if there are DRM people here who disagree, please let me know. It's just my understanding. Until recently, Video for Linux never had that. Video for Linux was MESA. It was the only way to talk to video camera devices. So it was very important for us, given the wide variety of devices, to have a standardized API. Introducing vendor-specific iOctals, you could do it for features that are really very device-specific, but they're actually really rare, because almost always there are other devices doing the same thing. So if you have lots of those video device-specific iOctals, it's very difficult to make Userspace applications. These days we have lib camera. So that is kind of the Video for Linux MESA solution. That might change the game a bit. So that might certainly given these types of very complicated pipelines, would it be interesting to make it easier to allow these vendor-specific things, provided there is a lib camera implementation? But that is sort of the political discussion for these. I wish we had more time to work on these slides. So these technical challenges, basically it comes down to if you have an ISP that is directly connected to a sensor, then we have to use video for Linux, hard requirement. So we need to know, in order to support this, what is missing in video for Linux. This is perhaps poorly written, but anything that a vendor thinks that is missing from video for Linux, and then after discussion we agree, then we need to fix that. It's just a fact. If you want to get that in, you need to fix that. So perhaps this is poorly written and it really would need a lot. We need to talk to the vendors and really understand what their requirements are and how to implement it. But in the end, it's just work. Nobody disputes, I think, that we need to do this. The question is, that is where it goes a little bit into the DRM discussion. If this would take a very long time, would it be a reason to block using DRM for such a driver? If that for many years is the only option to use today? Yeah, that's a big question. I don't have a clear answer at this moment.
So I've been working for almost 2 years on DRM subsystem too. So the model there is different from what we have on Video for Linux, because on on DRM, the driver actually have the kernel driver, which is basically just sending commands to the hardware and allocating buffers and such things. And the actual driver, which implements Vulkan, OpenGL, OpenCL, whatever, it is on Userspace. So it's a different model from what we have right now on media, because, I mean, for normal hardware, the camera will just command that, and the camera will do things. This is different from complex camera, so that's why we introduced lib camera. So with lib camera, we now have a Userspace component that can implement part of the kernel, part of the driver. So this is a different model, and it is just a matter of vendors came to us, and we find them a way to map. It is just like any other solution. Even if you will go to DRM, it will be the same. You need a Userspace component and a kernel space. And we do have this on media. So it is not really a technical challenge. It's just a matter that someone needs to do that.
So actually that what Mauro say is good, that there's different driver models between the V4L2 and the DRM. However, I want to say this difference is good for the complex camera ISP. The reason is that we don't want to such complex processing in the kernel drivers. Just pass the command to the hardware, then kick off processing with the memories. So in case that this is the reason that it's fit. And also that back to Hans' questions on the MISA, I think that this is mainly for the KMS. However, is that the DRM driver we are using for the complex camera ISP is mainly on the GM. So that this is memory-to-memory processing. We consider this as the accelerators.
Right, this might take a while. Buckle up. This comes down really like architecture of V4L2 is not at all suitable for these devices. I'm going to say that to you guys. You can argue with me, but I don't give a shit. It's just not suitable. These devices are not designed to be programmed in this way. The same way as if I tried to program a graphics card in this way, it would not work. It is the overhead of doing that abstraction at the kernel is too bloody high. It doesn't work. If these devices are designed to be programmed, and I think that's how the best way to sort of differentiate what should be in V4L and what should be in DRM is how are these devices designed?
Very quick. You are saying that cameras, these type of devices shouldn't use video for Linux or shouldn't use...
If they're designed in a way, like the way the DRM was 20 years ago,
was how Video for Linux is now. And the hardware has evolved, and your hardware is evolving now, and your hardware is evolving probably along similar lines to what happened to us 10 years ago, maybe 15 years ago. And we came across that problem, and we're like, well, how do we solve it? We have to move from having register programming drivers in the kernel to user space rings. Now, so I think the best way to is not to decide this on like, you know, DRM versus V4L2. And I don't know enough about cameras to definitively say this, but if the devices are programmable in some sort of ring fashion, like if there's like a ring buffer that you submit work to, that the work you're submitting can be constructed in user space on a less kernel environment, like without the security challenges and all that, you can construct that block of work and you can give that block of work to a device in some sort of ring, and the device will then process that work and tell you when it's finished. If that's the programming model for your device, DRM is the subsystem that will handle that. DRM is not a good subsystem if your programming model for your device is, I go into the kernel, I program 57 registers in a certain sequence and then block and wait. That is, the distinction is not, should all these cameras be in one or the other. The distinction is, how is the hardware designed to be programmed? And if the hardware is designed to be programmed in some fashion where you can, I've lost word for what I'm thinking about here, but in a less, in user space, you can build those command buffers and you can send those command buffers to the kernel, and the kernel will fence you at the end and tell you, I'm done with that. And you can build buffers, you can build pipelines with DMA buff and use the fencing system that we've built in DRM. Program the hardware that way. That's the way it was designed. If the hardware is more of a stateful, this comes down to some even the video decode stuff that's in Video for Linux probably shouldn't have been in Video for Linux. It probably should be done with DRM, because again, is the hardware designed to take a ring pointer to something that's not authenticated? Like we do authentication in the kernel for some devices. So like the older DRM devices had no virtual address spaces and had no. And I think the ISPs are probably in that area, that they don't have like a good separation of kernel user sort of places. But we used to authenticate the command streams in the kernel to make sure they weren't going to do something bad. If that's necessary, DRM could still do it. But I think it comes down to, you need to think about this from the hardware design, what that implies, and not from this, there's an answer that's one, V4L2 is the only way to do it, or DRM is the only way to do it. No. How is the hardware designed to be programmed? It may be different for every vendor. You need to get libcamera to be that user space API that everyone else is going to use. We had Vulkan, we have OpenGL. They are what drives us. Vendors put in extensions, and that's cool, but the vendor extensions are normally implemented by everyone. They're not normally usually that vendor specific. But having libcamera be the API will drive that. If you say, I need a libcamera user space driver for this, and you don't put the kernel driver in until you have a user space libcamera driver for something, and the libcamera APIs are what all of the other applications are using, your user space is using, the ecosystem will sort itself out. If your vendor doesn't come to the party, the market will push that vendor to the party eventually. It's like, we've cycled this stuff for a while in GPU land, and I don't see it being that fundamentally different for you.
I think this is a very good. Okay, I think this is a very good statement for exactly for what's the complex camera ISP is, right? That in the Userspace, the lib cameras, there's a special control flow. We call this as a 3A flow, which is calculate or comparing the parameters or command per every frame, so-called per frame control. Then this command is sent to the kernel space, and then that setting the hardware. So this the hardware architecture looks like for the complex camera. There's no anything that we need to compare those parameters that inside the kernel drivers. So in case that the DIM is better fit per this gentleman's comments, right?
These devices are still quite different from GPUs today, so and probably also 20 years ago. So instead of performing certain user programmable program operations very fast, there is a pipeline of different processing blocks that the configuration of which comes from the user space control algorithms. But so what you refer to as a command, I believe,
is basically telling the ISP of the processor frame, generally with certain parameters. So I think that in some way that's similar, but it's important still to remember that it's still a fundamentally different kind of a device. Yeah, actually in the DRM, it supports two kinds of the device model. One we call it as the DRI, which is for rendering. This is a traditional one. The other one is that in recent years that there is introduced a new subtree, so-called accelerators. So the accelerator exactly that requires the user space to generate those parameters and the command, send to the kernel space and pass to the hardware. And this is memory and the memory of processing. So this is the one that the DRM. So when we say DRM, actually here today is mainly on DRM accelerator, not on DRI. Okay.
I know basically nothing about GPUs, but in my understanding, the main difference is that instead of passing in command buffers that need processing inside the GPUs, ISPs, except for accelerator, with, in my opinion, as I understand it, are mostly MPUs, which is different kind of devices compared to ISPs. They are programmed through static parameters buffers. So they are just value that gets set and programmed on the ISP. There is no computation going on the ISP. Does that make any difference, in your opinion?
I think there's some computation there, right? You're setting some weights. Those weights are part of a.
Maybe I should answer that because that's what I wanted to say, that it's actually the same. It doesn't make any actual difference. There's one of the MPU drivers I wrote. It's actually a command buffer, so there's commands which interprets, and what they do is just write a register each of them to some specific part of the hardware. And the other one just passes the descriptors, but it's the same thing. And it's really that what he said for GPUs that may apply to these M2M video for Linux drivers applies exactly the same to the MPUs I'm doing.
So actually from my perspective, actually I disagree that the MPU is static parameters. Okay, yeah. No. What I say is that actually this is the MPU. In this one, that the MPU and the ISP, they are very similar. Okay, MPU, you can generate the different coefficient and the parameters per frame. And for ISP, actually, we have the 3A control model running in the Userspace, which generate or update those parameters per frame. So they're the same operation model.
So going back to the comment from Dave, there we go. When it comes to comparing to GPUs, first of all, we have no ring buffer. We don't have hardware to operate on ring buffers. At the hardware level, or possibly at a firmware level, because what matters from a kernel point of view is the interface that is exposed to the kernel, we have a fixed pipeline. You can bypass elements, you can have crossbar switches in the middle, so you can configure your routing, but it's mostly a fixed pipeline of blocks. And then you have, depending on the ISPs, a few hundreds, a few thousand, 10,000 of parameters. When we say parameters, when people say I have 5 megabytes of parameters, that may mean that you have a lookup table for some of those blocks that will contain 0.5 megabyte of data. So we're not talking about 5 megabytes of individual integers that you need to compute. And I do agree that the model is about computing all those parameters in user space, passing that to the kernel, and we don't want to have a fat driver in the kernel. For some of the ISPs we have today, we have drivers that take parameters from user space and will write those to registers with the CPU. Some of them use DMA to do that. That's really a hardware decision. Some hardware will have DMA engines dedicated for that, some won't. So we have to deal with those kind of things. If you look at the Raspberry Pi 5 ISP, that's register-based, and the values of the registers are computed from user space. So we have a V42 driver today, from memory to memory device in the kernel, where user space computes values of registers, put that in a buffer, pass the buffer to the kernel, and that buffer will be, I think it's copied with the CPU in this particular case because there's no DMA engine. But if we had a DMA engine, we would trigger a DMA operation to copy that. So the model that we're looking at, we don't have a model with a ring buffer where you can submit jobs and the ISP would process the jobs one after the other and go without any CPU interaction between those jobs and handle fancies and all that. We may get there at some point, but the model we have today is that you have to submit a large number of parameters, lots of data for each frame, send that to the hardware. You don't wait. You get notified, of course, when it completes, but you don't have a mechanism when the ISP will automatically necessarily go to the next one without any interaction. And again, we may get there.
Logan, I might be confused, but it's not exactly how the IPU6 driver hardware works. You have multiple, you can queue multiple operations and they're executed in the order that you actually out of order when you execute them.
I think whether it is or isn't is, it's not material here. Like DRM supports both. So we have some where, you fill up huge command buffers and there's complex synchronization between multiple queues and some firmware just does it. We have others which are completely dumb. They just take pointers to massive sets of descriptor tables. Like if you want to render one triangle on on quite a lot of GPUs, whether it takes one job at a time with the kernel filling the register every time the GPU is idle, or whether it's done from a command buffer, you can have, like 50 bytes of shader code compared to like 20 kilobytes of descriptor tables. So I don't think these differences are material because DRM supports both perfectly well. It's fine. What I have more issue, to be honest with, is the non-technical argument. When you say that vendors have no incentive to upstream drivers, you're sort of painting the community as held hostage in a way. And again, if we're looking at DRM, originally the ATI drivers were not done by ATI. They were done by the Weather Channel, who wanted them done and contracted Red Hat, I think. Precision, ages ago. Anyway, so like they're there now. ARM was done by Collabora originally because we thought it was a good idea. And ARM are now helping out with that. But in between Collabora saying, we think this is good, we're going to sink our own money into it, and ARM coming to the table and really starting to support that, we picked up a lot of people who wanted open drivers and they were willing and motivated enough to pay for it. And that's what Dave was getting at when he said that the market will sort it out. If there's no demand to have ISP drivers well supported in open source mainline stacks, then by definition, no one cares. If there's demand, generally people will sort it out, especially as you look at people starting to look at device sustainability. Rather than just throw away consumer devices, you have this stuff being shipped in industrial environments where you need quality and introspection and long support cycles, and that is the market pushing people towards open source. For the vendors who participate in that and do well, then that's a good positive differentiating factor for them. For the vendors who say, my stuff is too unique and too special and too patented, I'm only going to do proprietary things, then either someone will go reverse engineer it because I don't believe it's that complex.
It's exactly the same as EPUs. It's exactly the same as EPUs.
There's a there's a big difference.
That's a lie as well.
Big difference to GPUs here. The pipeline is long and you only get the result at the end. So if you have no idea what is happening in between, it is not going to be reversible.
You can reverse engineer. It's doable, trust me.
An ISP is impossible to reverse engineer. You may be able to reverse engineer some parts of it, but you won't be able to.
Yeah, but you don't have to get to perfect immediately.
No, you do. That's the problem. No, you can't. Before you have everything, you have nothing. No. Daniel, before you have everything, you have nothing.
Have you got their driver?
Sorry?
Have you got a driver for the hardware?
So each hardware.
Yeah.
Have you have a driver for a hardware? You can reverse engineer it. Doesn't matter what you think. It's been done for every single piece of hardware that's ever been created. There's nothing special about ISPs.
No. It's special for ISPs.
It is not special.
Could you do that to some of the complex ISPs first? Then I believe it.
Well, it's impossible until somebody does it, right? That's the thing, because I think it's wrong for us to accept those arguments as if it was valid. That was one about the patents, and the other one was about the competitive advantage, because we can believe those only if there are no open source drivers. At the moment, if that they are, we see that these are not valid because the companies, the competitors, are already doing reverse engineering of those drivers. It's just that they don't publish it. But they know exactly what you are doing with your hardware. So, and I know that because we can do that as well. And just a single person can do that. So imagine if you are a competitor which has thousands of engineers, and some of them are doing that, of course. And they have the domain knowledge that we don't have, even because they already know about how their own hardware is done. I think the open source community shouldn't give much weight to that. I know that all of them think about that, but in the same way, we already saw it at the DRM in Mesa. We know how all the GPU vendors are doing a variation of two approaches. And with the NPUs, everybody's doing the same thing, apparently.
Copy each other constantly, and they all use the same engineers who move from company to company to design this shit. It's not like if you can get a libcamera proprietary driver that can drive one of these chips, you can make an open source libcamera driver that can drive one of these chips, because there's nothing hidden there. It may look ugly and it may look brutal, but you're telling me it's totally literally impossible to take someone's code and recreate it. Like, what else are you going to do? Like, you have a libcamera API to say, I need to do a certain transformation or image processing thing, and then you need to translate that into a table of numbers to give to the device. Is that what the basic code?
The libcamera API will say, I want to enable denoising. You have one Boolean. Yeah. Underneath, there's going to be statistics that will be computed from frames, so from a live stream. You get those stats that are fed to a blob, and the blob will take megabytes of stats. And it will output, 100 kilobytes of parameters that control the denoising field.
Yeah,
and you have one Boolean to control that.
But to phrase, that's fine.
And that half megabyte of parameters are computed. They compute it for every frame, and they vary for every frame in ways that you can't understand.
That's fine, because like Dave said, it is computation. Like, to phrase it more antagonistically, either ISPs are the most special hardware in the world and the only hardware which it is not possible to reverse engineer, or everyone working on ISPs is inherently less capable than everyone else working on other hardware. I don't think either of these things are true, but that's kind of where you're getting at.
They're not the most complex devices, but they're inherently different than GPUs from a reverse engineering.
I've recently heard this exact argument come back on people working on VR headsets, saying there's no way we can work out the fucking lensing crap and all that stuff dynamically. And one guy sitting in his room in Australia worked it out in a few months. It's not impossible. And if you keep telling yourself that, you're never going to just get off on your ass and do it. Just reverse engineer one of them and figure it out. Like, that's how it happens. It's how we broke the GPU drivers. It's how we broke, it's like no one could ever figure out how to program an NVIDIA GPU. It's impossible. How did you ever? Those things are the most complex piece of hardware in the world. Some guy sitting on his ass in Australia figured it out.
You know exactly.
Maybe we just need more guys sitting on their asses in Australia.
You know exactly what you're talking about when you talk about GPUs, but you don't when you talk about.
I know about it with XR, with OpenXR for the VR headsets. That stuff was inherently the same problem. You had to feed in a bunch of stuff from one thing and dynamically do it at runtime to correct the lensing and the thing, and the guy figured it out. So
and when you have registered documentation for an ISP, in most cases, when you have that, that's not enough, even with the documentation.
No, you're able to write an implementation. But you'll also realize that they're not programming magic into the hardware. The values have meaning, and you will figure out that they all have similar meanings over time. And every vendor ends up programming nearly something similar.
You can't, because it's not reproducible. It changes for every frame you get in. So when you reverse engineer a GPU, you control the input, right?
Yeah.
So you send commands.
This is a memory-to-memory ISP device. You control the input. You don't have to build reverse engineer it in the whole environment of having a camera feeding in frames constantly and doing that. You can control putting in 1 or 2 frames of black, white, green, and then saying denoising. You can do it.
No, because the control loop that controls the memory-to-memory ISP interacts with the live sensor as well.
We have light sensors. You can put another input. It's all
actually, the major difference between GPU and the ISP is GPU is stand for general purpose processor, and ISP, actually, we build and integrate all the fixed functions with the predefined algos. So give you an example that if you look at the high-level building block, that the ISP from different company is looks like almost same. For example, we have the TNR, and the company A, B, C, they have different TNR implementations. This implementation will be reflected through the parameters. So if I have the company A's, documentation on TNR parameter versus the company B, then I can compare the difference. That immediately tell me what's happened, that what they implement or modify, refine in the TNR. So this is the something that they can do the reverse engineering.
So I just wanted to see if maybe I could derail the lively discussion about reverse engineering. We do have devices for which we have documentation. For example, IPU6, we have open source implementations even. Like, I think the question that we can get back to is what's the right API for this? And I think Dave already made an assertion that V4L is not the right API for this sort of thing. And I think the Intel team agrees with that, but that's I think the question that we're trying to get at here. And I hear a lot of discussion about the technical challenges or whatever, whether they're technical or not, I think is not the right question. Is like, are they challenges? What's the right API for us to use for this? So that I just wanted to try and pivot back to that. So
what Dave said, and I do agree with that, is that we don't want an API that forces a fat driver in the kernel that will do computation and bit back the registers. That we fully agree on. I also fully agree on the fact that you can do that with DRM. But what I'm saying, and what I disagree with when you say VideoFolix is not the right API, VideoFolix today does not force you to do that. It supports having Userspace drivers that compute all those parameters, pass them in the buffer to the kernel, and it will be passed to the driver or to the firmware. The only thing that we want to have in a kernel, and that's device-specific, is making sure that we validate what's in there so that there won't be security issues, that we won't have buffer overflows, that you won't be able to disable a clock somewhere that will lock up your memory bus in the SoC. That is something we want to validate. That's a job of the kernel, because you have to consider untrusted user space. But we have today drivers in mainline, in VideoFolix, that operate on a parameters buffer, and they just pass them to the hardware. So saying that VideoFolix requires fat drivers, that's not right. Saying that DRM can support these use cases with drivers that pass the data to the device, that is absolutely right.
I just want to make clear that if you want to implement if you implement a driver in Video for Linux versus in DRM, you're going to have better performance in DRM because you're going to have less syscalls. Plus, everything that you send from Userspace to the driver, in Video for Linux by policy, we need to know everything that is there, right?
Yeah, but that's not technical.
But the policy is that we need to know everything is there, which means...
We can discuss that, that's fine, but it's not a technical angle.
So most of the time, we cannot just send the buffer directly to the hardware because we need to recraft those parameters into something that the hardware consumes, because the input and the output, that's how we usually do it.
No, I mean, the Raspberry Pi driver doesn't recraft anything.
Because in that case, you have the documentation for everything. But if you don't have the documentation for everything...
They do that in Userspace.
No. You cannot create... Let's say... You
do that in Userspace.
No.
They create a parameters buffer, which get passed to the kernel driver, which DMAs that to the hardware.
If that
There's no driver expecting parameters there. There is no moving around data.
If that parameter buffer is because you have all the documentation for that, for every single byte. If you don't have the documentation for every single byte, you need to recraft it.
That's not a technical issue.
Yes.
That's the
but
second
that is
part.
What is
Documenting all the parameters or not, that's not a technical issue.
But we agree that we have much more syscalls if we need to implement a driver in iOS in use in DRM versus This is for Linux.
As we said, much more syscall is different than say we got tons or tens of those.
tens.
I agree that queuing and the queuing buffer, there's been a discussion about going towards an atomic API for video for Linux going on since years, I think. We got proposed there, and I think the desire from the community is to go there. That's the outcome of the discussion that we have on Monday. So I agree, and everybody agrees that it could be done better, but I don't think that mixing performances with the needs of having documented parameters or technical challenges is moving the discussion forward. So there is one part which I agree is totally political, which is the needs to document or not all the parameters. And there is one part which are technical challenges, which they exist, but they are solvable and the community wants to solve them.
Mm-hmm.
So if we want to keep the discussion separate about the two API, mixing the two, I don't think it doesn't make the discussion move forward.
We want to re-implement an API that already exists, which is called DRM.
No, that's not true, because with DRM, you're going to use driver-specific OCTLs, and those you need to develop. They don't exist.
No, that was something I thought would happen over the years. I would have thought that V4L would have ended up just growing the exact same style of command submission mechanism and fencing and all that stuff, and we would just interoperate with DMA buff between things, and it just never seemed to have transpired. Like I totally expected this 5 or 6 years ago, I think I talked to you about, Laurent. It's something that should have been there, and I don't know why you I don't want to be having camera drivers in DRM, really. It's not designed for that. But I would have thought by now that the need for this type of API, without all of the extra stuff that's around it, like that you could, an optimized version of this would have transpired, and that doesn't seem to have happened. And that's where your problem is coming from. It's like V4L is still at that level where it's not optimized for the new hardware. And we've gone through this, and that's why probably what DRM is good for this, because we've already dealt with that problem. You know, we've had the upheavals 2 or 3 times now had to upheaval the whole DRM system. But we did it. We got over it. I thought you should have started this 5 or 6 years ago.
Are you talking about DRM or KMS in this case?
Both, the whole thing. Like the original DRI was the big lock. Like there was one user, and you had to take this big, essentially the lock. And then we went, no, that's an insane thing. Moved past that. Like that was the one where you could program the registers from Userspace, but you held the lock. And you directly MMIO programmed the driver from Userspace. That was insane, we admit that. The second iteration was more of we will validate every command. But this is hardware generations, hardware developed at the time. It's like the second generation, I think, is where you are now. We have to validate the command buffers to make sure they're not going to just DMA all over my memory. Now, I think you guys are probably easier here, because it doesn't sound like the parameter buffers are generally a set of commands that will just DMA all over your memory, where we had specific commands to do that.
It depends on the device.
Yeah, it depends on the device. You're probably sending it to a firmware who you don't know what it's going to do with it. But that level was like, yeah, so we validate in the kernel that by the best of our knowledge, it's not going to DMA all over memory. We still have a few of those drivers in the kernel. They're not gone away. And then the next evolution was when the hardware finally got proper separation and privilege separation. And you could just give the hardware buffer from Userspace, and it had virtual address management. And I don't think ISPs are quite with virtual address management in context yet.
Some are integrating platforms with IMMUs, some are not.
So some will get this again. And again, that's a different API again. Like they're not the same API. They're evolutions of the hardware that have driven the API. And I think you guys are still haven't figured out that, you figured it out, I think, but I don't think you've realized it in terms of actually making it happen. It's like that your hardware is evolving, and it's a totally different programming model or a different way of doing it. And I think you kind of got it when stateful and stateless with programming. But you didn't, because stateless probably shouldn't have been in the kernel. It's like some of that stuff could have all been generated in Userspace, and I wouldn't be having to parse H.264 stuff in the kernel, because that's not, and it's like, but I think you're just sort of on the, DRM is there because it's easy and it fits the hardware programming model well. And, if someone decides that this is a good way of doing it, I'm not going to say no, because I don't say no to people with ideas that are insane and crazy, because it's some generally that moves the market along.
Are you going to say no if there's no open Userspace implementation?
Yes, totally. I will. There has to be a full libcamera.
How do we define an open Userspace
There has to be a full libcamera implementation that provides all of the libcamera APIs that you think are important, like same as and that implements them all completely. And then if there's the odd zero in the middle of the parameter buffer that you don't understand.
What if I say that I want to make sure that you can have open source tuning tools for cameras? Is that acceptable?
Yep. If you decide that the libcamera, in this case, the user space is the same we have with Mesa. For Mesa, the basic requirement is that you implement Vulkan or OpenGL in Mesa. We used to sort of be a bit more flexible on that, but we've kind of said, no, you have to do Mesa now for that. Accelerators is kind of on that you have to show as a user space that does something useful for your device. We kind of lost with Abandon Labs. That's the other thing. I'm flexible to let things happen, to see if they actually pull it off, or if the hardware just dies and we don't care about it anymore. It's very rare that successful hardware hasn't just ended up doing the default thing of making a good user space. You might get the odd one that's bullshitting, but they all die because the market forces them away. And you know, you got to be flexible in some ways. But I think if you can define a sort of a lib camera, this is what we believe is the necessary things for a camera should have, and tuning tools is part of that, and you know, calibration, whatever. And you define that, then you set that standard. And when someone in your group, someone goes, this kernel driver has a suitable user space, and here's the reviews, and here's the signed off by, we would merge a kernel driver. That's the procedure we've followed for up to now, and I don't see that being different.
Couple of more points. Full lib camera API support is different from full ISP feature support. So you can leave a lot of stuff, almost everything out of ISP support, and still have full lib camera API support.
But is the goal lib camera support? That is the question. Like with the graphics cards, there's loads of stuff that we've never been able to expose because the goal was just, can our users use it?
The lib camera is essentially the Linux camera API today.
Yeah, and if you need to add extensions to lib camera, or you decide that there's a new feature that people are not telling you about, get a lib camera API for that. Especially, what will happen is they will want to what's the point in writing a driver for an ISP that doesn't have a feature exposed through lib camera? You make that pointless. That's how you make it pointless. That you make sure that any apps using a camera go through lib camera. Once all the applications have to go through lib camera, they're not going to want to go directly to some driver written by some vendor proprietary stack.
No, they couldn't.
No, they won't want it. And so then they will go, well, we need to put an extension in lib camera for some new feature, and then they come and go, okay, we'll put the extension in it. But then part of putting the extension into lib camera is now you need to tell me the details, open source that piece, because I'm not going to let your thing into lib camera without that piece.
I think that one point that's very important here is to understand the abstraction layers. So we have an ISP, and I agree that the abstraction layer there, the hardware firmware level, is similar to a GPU. Works completely differently. It's not programmable with shaders, but you have that. So that's fairly low level. We have a kernel driver, Linux or DRM, that's also fairly low level and allows user space to build buffers that it passes with parameters. I don't think that's fundamentally different from an abstraction point of view between the two subsystems. And then in user space, on one side you have Mesa, Vulkan, OpenGL, so you know that abstraction level. To give an equivalent on the camera side, it would be a bit like saying, I'm going to accept your kernel driver if you make it possible with an open source user space stack to display a window with Qt or GTK. And whether that window and the 3D content in there is accelerated or not, you don't care. Whether you have support for the different shaders that the hardware supports, you don't care. So it's a really big gap between the libcamera API. It's a much higher level than OpenGL or Vulkan. And that's where things get difficult. Because if you say, we want to support those features in libcamera, if I want to say, I want to make sure that we have denoising, for instance. There are lots of types of denoising in the ISP. You can consider that you may have 2D denoising and temporal denoising. That's going to give you much better results because you accumulate multiple frames. At the libcamera level, you're going to have an API that says, I want to enable denoising. And the vendor will say, okay, I'm just going to do 2D denoising. And with my close-on stack, I'm going to have much better image quality. And there's lots of examples of that where it's very difficult. But if you compare that to Vulkan, you have an API that's much closer to the hardware. What you express with the Vulkan API when it comes to rendering and shaders, the other things are much closer to the device. So saying you have to implement that API gives you a very good chance that you have a really wide hardware coverage of the features that are there. And that's the challenge we have here with cameras, defining the API and saying that's the standard.
I think that's one of those problems you have to build it and let the market sort out. can't preempt it. You can't decide in advance that, like, oh, if one vendor just does the simple 2D denoiser and the other vendor then is tempted to one-up them by doing a temporal denoiser, and they get the better image quality, so they're going to win more things. That's how you're going to have to do it. You can't decide this in advance. I think you have to get to the point where you get the basic, because we've had this for a while. We've had like vendors with their own drivers who don't tell us all of the details of the hardware, and AMD it does that, and then but the open source one still won. It just takes a bit of time. It takes the market. You have to let the industry decide that they want these features.
So I want to make a comments on the API versus ABI. Actually, that for the lib camera, it's provide the API which is to enable the high-level applications, and we can consider this kind of the a middleware that allow vendor to enable their hardware abstraction layer. The ABI actually exactly the interface to the hardware. The one is that, as I mentioned, that there's a 3A flow. We call this as the IPA, the Argo part, which will generate those hardware payload and send this payload as a blob to the hardware that through the ABI. So that in case, this is why I think that the DIM is the better way that to handle those kind of the complex ISP.
If you have a vendor that gives you a proprietary implementation, at the end of the day, it's a blob that you can reverse engineer it. Inject it into IDA, see what they are doing, but you're starting with a driver that is giving you 70% of the functionality. And again, the market is going to self-regulate. If distros are going to distribute mainly the open source solution, so vendors want their features, they want their camera to look nice in most of the distros.
I've heard you and Dave talking about the market here, and I think that's an important point. We've been working for the past nearly 6 years, that's when we started Lib Camera, approaching ISP vendors and SoC vendors, and you can imagine how difficult that is, so that's a process that takes time. And we're seeing an increase of interest in what we're doing. We had very few vendors to start with, and then that's expanding. And with every new vendor that we manage to get on board, there are 2 others who think, well, maybe time for us to get there as well. That doesn't start at the top with Qualcomm or NVIDIA, obviously. Those are not the first ones you're going to get. But no later than today, and I can't name that vendor, but I've heard someone telling me, okay, we're talking about a large important one, who told me, we managed to initiate discussions internally to get the cameras to be more open and to go with Lib Camera and to have open kernel drivers and have the ability to have open source stacks, something that was completely unimaginable for them 3 years ago. And they told me, if you now allow vendor pass-through, I'm losing that battle and the discussion will never happen internally. We have leverage on the market today because you're pushing them to be open. If we tell them you can do anything you want, we lost. The 5 previous years of hard work we've done to get the market there, that's going to be destroyed.
I don't think you're telling them that by saying use the DRM architecture versus the V4L2 architecture. You control
DRM versus video for Linux, we don't.
Like the market,
but the level of openness they have to have, that's the open talk.
But the level of openness is driven by your Lib Camera expectations. If you even, you can also, another way to drive the market is provide quality reports out of Lib Camera saying, oh, well, we tested this person's denoiser and it's not as good as the other people. And say Lib Camera, and maybe you could set minimum quality requirements. You can set things that force things to happen as well. Like you have the power to decide on every person's submission whether you think they could push it a bit further. And that's how, we've done that again. It's like there's no rule you set here you have to dynamically engage with every single ISP that approaches you. And you're seeing the market already. By refusing to do anything else, they have to come to you. They're obviously saying what they're doing isn't working. They know that they're not getting the sales they want. They've got these devices and nobody wants them. And they're not, so they're coming to you because they want to build a market for it. They know they need to come through you now. That's success. But you push that every year a little bit further and higher. You're not going to be able to push it to the end now. You've got to, I've been doing this for 20x years now, and I've pushed everything a little bit every year, and that's where we got to. It's like, you can't get to the end without iterating up. You find the friendliest vendor, you persuade them to do the best quality thing, and the other guys will follow them. That's just the market.
And the same argument from you, it goes to the other side. We are constantly the same argument that you are saying, it goes in the different direction. We have been constantly working with vendors that they cannot they are not willing to make their drivers in video for Linux because our policies, and they will be open to release drivers that are good enough for users, that are good enough for our use case, with the openness level that we have today, if we give them another chance, another vendor pass-through. So the same goes in both directions. What we are losing in one side, we are winning in the other.
The problem was never related to pass-through. The problem is, and that's what we really want, and we really been fighting year by year. We want a vendor that can have a camera, get image, and present it the right way. And that's what they are refusing to do, because they want to do whatever fancy, weird algorithm they have, and they want this proprietary. They don't want to open. And the attempt to flip camera and other strategies is all about that. It was never about the actual video for Linux API. It's all about vendors wanting to get their proprietary thing there and not letting users get the image they want. That's basically the
So actually that one thing I want to mention, okay, people talk about the IQs, the image quality. The image quality is not determined by the software. Okay, the image quality is determined through the tuning process. This will include all the algos, pipelines, which will be enabled, disabled through the imaging tuning process. And the software will not to control it. Okay.
And
I don't agree with that. Tuning is extremely important, but if I replace today your binary image algorithms that you ship with a gray world AWB, so just a software change, will the image quality will be the same?
This is a very good question. Actually, what's the term, the image quality? Okay, usually do the tuning is for the different lighting environment or the whatever the implications, which is define those parameters will include dynamic and static to configure the ISPs. So that from the software perspective, the imaging algo is invisible to us, just from Intel perspective. Okay, we don't know this is the TNR, we don't know this is the XNR, we don't know this is the demosic. Okay, and this is the one is through the algo processing path, like the 3E path, to generate those parameters as a blob, then sent to the hardware directory, pass through to the kernel driver.
There's the few things that I believe would be good to clarify, but it's probably going to take a few days. Going back to Dave's argument about what we require from vendor, I think we'll have lots of people in the room who would agree that we should allow things to be merged if we set requirements on image quality and other things or features. And if the vendor reaches those requirements, then that's good enough. And I could also agree with that. Where it's going to be probably more difficult to agree is what level of features, what level of quality, what level of hardware features that will need to be supported. That's a discussion that I think we should have, because if we leave today saying, okay, we agree that this is the way to go, we may not have an actual agreement.
You do not need to agree on that. You need to negotiate that with every ISP vendor as they come to you, and you need to decide individual case, depending on your knowledge of the hardware and what they're willing to tell you, what you think as the expert in libcamera, what the base level requirements for those people to get that merged. You can't set, the problem with setting any static rule in systems like this is people game it. Yeah. You cannot do that. You need to negotiate with everyone individually one-on-one. There's no other way, because we've tried this thing, and people have come to me over the years going, "Oh, well, we'll do this." And we gave you a rule, and the first thing you did was try to game it. So people are always going to try and game the rules, and you need to sort of you can sort of go. You can give guidelines, rough sketches of guidelines, but don't make rules, because the first thing that will happen is vendors will try and game you, and they will.
How much can you discriminate between vendors?
It's up to you. It is. If you think it will help the market by giving one vendor more friendliness, you do that. Like for instance, I merged the Samsung Exynos driver, which I think you're somewhat familiar with, and Daniel certainly is. Not because it was a decently written driver, not because it was like a piece of hardware that was spectacular and I needed in the kernel. It was because it's the only ARM vendor who had submitted a driver at that stage, and it was shit. But it was good enough to put in the kernel because I knew it would create market force change in other vendors. I would never have accepted the Exynos driver as the second driver. It was only in there as the first one. I spent a lot of money getting it cleaned up. I spent a lot of other people's money, not my own money, getting it cleaned up. But that's the thing, you have to renegotiate every time. And you have to sometimes go back to the first guy and say, sorry, you're not keeping up anymore.
You've never had a vendor telling you that it's not fair, that they have
every time.
Higher standards?
Yes, all the time, and I just tell them to go away and come back when they figure it out.
So that means the community is fine with that?
The community likes that, because the community, what happens then is generally people from the first few vendors you're friendly with are your community, and they don't like you giving different, like they will. Like, I don't decide this. I'm saying I decided this. No, the DRM community has decided the standards we will accept from people. And people approach me, and I give them an opinion that I believe reflects the DRM community. I don't give them my personal opinion. I sort of gauge, I talk to other people, and then I go, look, yeah, no, we don't want your driver right now. It's not quite where we need it. And they'll come back in a year and they might go, yeah, we got to that point. And well, the scales have moved. You got to go a bit further. And it's like, so there's this constant, but it's a community decision. I'm only representing the community. It is not my personal thing. I talk to the people at Collabora. I talk to Red Hats. I talk to, and I try to sit down with all of the people with the stakes. And when a new vendor comes along, it's like, what's the kind of minimum we really would let this person into the kernel away with? And again, it depends on the company, and it depends on what they're trying to drive. It depends if there's market interest. It's a complex problem every single time, and you just sit down and have people in the community you trust to talk to as well, and make sure they're representative of each ISP. Because companies get resentful if you set a gate for one company and they get over it, and then you drop the gate for the next one. So you generally have to make the gates higher, but usually that's pretty much the best way to do it. And if
it's much better than the other way.
And if the first company gets over the gate, you don't have to force them to get to the next gate. They can drift along for a while, and maybe they'll come up to the next gate. But that's to say, you set the quality, and you have to make it happen.
And you raise the gate for the next generation.
Yeah, and you just have to be arrogant about it.
I can confirm Dave's extremely arrogant. No, like, individually in isolation, some of the decisions he's made over the years, and with SEMA as well, have been incredibly unfair in isolation. But it is that ratcheting up, right? And the ratcheting up does two things. One, it increases the standard and it increases the expectation year on year, which has absolutely happened. And the other is that it keeps the existing participants on their toes. Like, I'll be very unfair and single out one person here. If you look at AMD, they've been a really, really good participant in the community for quite some years. But when the whole Dell and DC thing came along, like, that massively blew up into a huge public fiasco. Because, they'd gotten in the gate at a certain level. They had participated really constructively and helped a lot of people out. But that level had risen, and they'd in some ways gone a bit backwards. And so, when they came to submit this whole huge thing, they found out that, yes, the barrier to entry is massively increased because that's where everyone else is now, and that's where the expectations are now. And that is something you can ratchet up every year. It's frog in boiling water.
And I'll just say, it is no fun to be the person that stops the work of 100 to 200 other engineers from going forward. And it's not. And imposter syndrome does get you with it. Like, it's like, why am I the person that's saying to AMD that 200 engineers years of work is not getting into the kernel? It's like, someone has to be, and you need to be, but you need to be negotiable. You can't draw hard lines.
Can I add a use case to that? Because we're considering big companies upstreaming their work for the ISPs, but there are a lot of small business companies which are maybe very expert on image tuning. They know much more than what we do as a community. They know much more as what we do as a community about imaging, and they want to use ISPs. And if we allow vendors to not document features that they might want to use, but they don't know they are there, we are preventing them to enter the market using free software or using Linux in general, because we allow them, they don't know there is a feature on that ISP because it's not been upstream or documented by the vendor. And they may be small and they cannot afford that, like upstreaming or supporting ISP by themselves alone, but they exist. There are a lot of those companies. We are seeing them every day, basically.
That's how the market self-regulates.
Yeah. And
if you have a vendor which has features A, B, and C, and another vendor offers A and B, you're going to choose the vendor that gives you most of the features. You are not going to choose that ISP because you cannot use it. And there's an incentive for companies. There's an incentive for companies to implement more features because they will get more clients.
Yeah.
I'm pretty sure Intel wants to sell their chips to more people instead of less.
Or maybe it's more convenient to have a big customer instead of having 100 small ones.
No, because I mean, usually.
But I think again, if those people are talking to like, well, we want to use libcamera to expose this sort of thing, then that's a point you ratchet up that API as something you should be implementing. And if they say to you, our hardware does not support that, you accept that. But if they say to you, we're not willing to support that in our hardware, well, that's a different discussion you have to have with them and be a bit more pushback on them, going, well, maybe we won't take your next set of changes, or we won't support your next chipset, and this is the thing, vendors per chipset, you can keep ratcheting. It's not like we let the vendor in, we have to accept everything from that vendor forever. Per release of a new chip, you could, every time you talk to them, there's a time to push that boundary.
And can you handle incremental development with that model? If you say, okay, this is the bar that you have to reach to get merged, that means that the driver will have to bridge a big gap before that happens. While today, what we've been doing in Video for Linux for the kernel side, but also in libcamera for the Userspace side, is okay, it's fine to go incrementally. How do you handle that?
It comes down to, do you trust the vendor? It's a personal relationship problem. It's like, yeah, does the vendor display that quality that I think I can let them get away with? I often find it's like, if the vendor has contracted it out to someone else to do it, and you trust them, that's probably okay as well. Like, so like if Collabora was writing the driver and you go, oh, those guys are pretty good at doing this. But if it's just a vendor, like, so if a vendor just turns up and I'm going, we've had this driver half written in-house and we want to upstream it, the default answer is always no, because they will just go away and you will never see them again. But if they're going, well, we contracted Collabora to finish this, and Daniel tells me that they're, and it's like, then yeah, we'll probably merge it at that point and let them do incremental in-tree development. But yeah, it's again, every case is unique and you have to negotiate every case on its merits.
I have a view of who I can trust today, so that's,
yeah, and like we've done ones where we started upstreaming some drivers and then the funding ran out, but we kept on doing it, paying for it ourselves because our name was attached to it and there's some level of embarrassment. So like, you know, that's the cost of having that reputation, right? But there's also, you know, we've been paid by people who have bought a bunch of boards and they don't quite do the thing that they want. So they'll pay us to implement some kind of feature. And, you know, great, that works, we get the feature upstream, but what tends to happen is when they want to do their next generation, they turn around to the vendor and they say, well, that all sounds really great, but last time I bought your hardware, I ended up having to spend 80 grand to make it work, and don't do that this time. Like, you know, you don't have to just deal with the vendor directly. Like by the time you're into OEM and to product land, you can use them to apply pressure back to the original manufacturers and do that kind of pincer movement.
Would you consider dropping a driver that has been merged on the basis of trust if the vendor then doesn't move forward?
Yeah, it causes regression issues with Linux, and that's always a discussion that's not fun. So I would
You could drop support in Mesa and not the kernel.
Yeah, we could put it into a Mesa, stop releasing it, or we would stop just touching it and leave it alone, and it would never get updated, and it would just break naturally because stuff just breaks naturally when you stop looking at it. But yeah, I don't think have we ever faced that? I've come close, that's true. But I don't think I've ever had to pull the actual, I'm kicking you out of the kernel level trigger. It's a pretty extreme.
As someone who's been kind of on multiple sides of this now, like working at Intel on the graphics stack and now at Google pushing Chrome OS and having to support these things, I can definitely say that it's kind of incremental, and you do want to be careful, like Dave said, to try and build the community and think about who the real customer is, right? So on the one hand, you can kind of saber rattle a little bit with the vendors and say, hey, can you level up your contribution? Can you improve this? Can you document that before you let it in? But if you make that like the initial bar, like Dave said, you may end up just getting no contributions. And to the point about dropping stuff, yeah, you could threaten to drop it, but really, who are you hurting there? You're hurting the end users. You're hurting the people who have this deployed. The vendor doesn't care, obviously, at that point if they've abandoned it. And so the question is, well, yeah, what do you do? Do you have someone step up and volunteer? But anyway, there's all these interests to balance, right? Customers, the developers on the upstream side, the vendors, and the needs of everybody. So it's just inherently challenging, but I think to Dave's point, the incremental approaches can really work. We don't need everything at the start, right? You can start with something that's better than now. In the camera case, now nothing is upstream, right? So for a lot of these cameras, so. Well, okay, so I'm just
nothing is upstream
like,
for the IPv6.
But no, don't
have the ISP.
Don't rattle on that. Don't rattle on that. I'm just saying, like the state of cameras we know for say Qualcomm or MediaTek is not great, right? And so if we say, hey, everything has to be 100% document open source, we're not going to get anything, right? If we say, hey, get a baseline of features up, that's going to be better than where we are today, and then to Dave's point, we keep ratcheting up. Yeah, don't worry about like whether everything is 100% or 99.9%.
And companies are here for the long term, right? For the long time. You don't want, if a company misbehaves, your level of trust is going to diminish to the next driver they're going to land. And at the end of the day, it's a driver by driver decision. And part of your decision plan is how do you trust this company? How do you trust this entity that is providing you the driver? Yeah, but I think we have very good examples of companies that have been behaving extremely well.
Absolutely, and they supported upstream in the kernel, in libcamera.
Yep. I can give you an example that is not.
But that company hasn't behaved well. That company
I think they have been.
Well.
I mean, I think have been behaving well, but that's something we can discuss.
There are lots of users on the internet who are unhappy there and who definitely disagree with you.
Yeah,
and we have high-profile kernel maintainers who said, well, if you don't agree with that, stop buying Intel chips.
I was just saying that 5 years ago it was probably, as you said, camera, there is nothing upstream. And that's really not true because we are seeing more and more contribution and upstream being supported there. Something that maybe 5 years ago was not imaginable. And it's right, the big names are not there, but we didn't have the small names neither 5 years ago.
Yeah, and we never asked 100% of documentation. This was never a requirement. What we really want is to have a camera that works decently. I mean, just like my camera, my notebook, it should, if I am in front of the camera, I should be seen at this display. Just like that. We need just the basics. Yes, and that's still a problem because most of the vendors don't allow that because you need to balance white balance. You need to do some tricks, otherwise the hardware doesn't really produce, or the image is too noisy for even to you to recognize the people.
Or are you leaving out a really big part of the market there? I mean, lots of the discussion here today is focusing on users having cameras in laptops or tablets and who can't use that for video conferencing today. That's an important use case. But we're leaving out all the industrial, all the IoT, all the edge use cases. And that's a very different case. In there, you have very different business constraints and the requirements. So when you say, I want a camera that has a decent image quality, On the IoT use cases, that's not what they want. Of course, they want a decent image quality, but they need the ability to tweak way more things than a user on a laptop. So we have to look at the big picture as well to be able to set the bar correctly.
But you decide, I mean,
Yeah, but even so, we are not requiring 100% of documentation. We do want not have a closed source there. That's the actual requirement.
I think the requirement today is that and I think that is written somewhere in some meetings we had ago, is that we don't want vendor pass-through. And this is written in stone. We wrote this 2 years ago from one of the media summits when we were talking about KCAM. So it's not fair saying that this is a model that we support. And saying that they only want minimum camera support, that's not true. I mean, Logan is pushing for full open documentation. So, yeah.
I mean, it's not really full documentation. The requirement that you are mentioning has been written, I think, was last media summit. It's either an open source implementation in libcamera or any other framework, documentation of parameters, but those two are not. We don't want both of them. Yeah. And if we had them, nobody would push them away. But I mean, that's not a requirement.
You cannot use any extra feature that is not documented.
That's device pass-through, and DRM would allow something different. Would allow accept blobs with the documented parameters in that case.
We would accept whatever Laurent is accepting in KCAM, and then if somebody else writes a separate thing that's nothing to do with libcamera and happens to use that API, well, we're not going to be able to stop that. But but we're not going to put a kernel driver in just for that. And we've been doing this with I don't think anyone really has gotten a kernel driver in without having a really, at least in the 3D level. The Excel is a bit more sketchy, but we're trying to build that. They generally end up using their open source thing more often than their closed source thing if they end up building one. The market just makes it happen. The effort of having to get your people to put this other piece of source that they can't get out of libcamera and build it all, it's too much for people. And then people have, we want to see the source. And I think eventually, yes, it will happen. Someone will build another thing on top of the DRM or V4L2 API or bypass, but that shouldn't be your concern. Your concern is how do I engage all of them, as many users as possible, libcamera, get the other ISPs, get as broad a support as possible in the market, try and bring up the level. And then, there's always going to be people that will try and game it and abuse it. And you have to spot those people as quickly as possible and, don't put their drivers in the kernel.
If I think of what has the discussion that has taken place for the past half an hour, 45 minutes. If I think of working that way, when it comes to cameras, there are a couple of issues. So if you're reviewing your driver, you can't say what kind of image quality is going to give you. You obviously need the entire stack, software stack to be able to judge that. And it is also very difficult to objectively measure that. I guess something exists today, but it's not something that we are using at all. So and what it would take to have that kind of a setup that we could objectively measure what these devices are doing.
You're getting into the area of what we call conformance testing. Is what we have in our area. And that's a hard problem.
If I may continue. So if you have an IO control based API that clearly defines the APIs that are supported, that's something that we can clearly say that what is there and what is not. It doesn't matter whether ISP features are all supported. What the requirement has been basically in the past that what is supported is also documented. But if you have a command buffer, that basically disappears.
I don't think. Do you count a C implementation of something is documented. It's like, is there enough explanation in the C code, the open source code, to say that's documenting these features, and then there's a few zeros that you just don't ever know what to program? Like, there's always registers you don't know what to do with. There's always must be zeros. There's always things, chicken bits and stuff that are hidden from everyone, and they're on every hardware. And occasionally someone will go off crazy and start putting values into those parameters and see what happens. And maybe they'll work it out, maybe they won't. And maybe there are things that, experimental features that the ISP doesn't want to support. You can't, yeah, I don't think you're going to get documentation, you know, that, I think having a C implementation in this case is probably more valuable than a documentation.
So actually that the software implementation is mainly for the data flow, okay? The data flow between the software firmware and the hardwares. And you can have a unified software implementation, but feed into or inputs to a different tuning file, you will get a different IQ quality. Right? So I don't think that the IQ versus the software, they are associated. They should be separate.
The image quality depends on, obviously, the hardware. It's a given, but that's set in stone. It depends on the tuning process, and then it depends on all your code in Userspace that takes the tuning parameter and will compute dynamically at runtime the ISP parameters. You have those three components. And if we set standards for the image quality, I mean, you compare that to conformance testing. Conformance testing is something that's well understood, that's cheap to do. Running benchmarks, that's fine as well. But if you want to run IQ test, real professional quality IQ test, you're talking about having an imaging lab that has a cost of more than 100,000 euros, right? So we're in a different
You need to find something smaller then. You need to find an acceptable level that's not that. But because the other option is you have a group of people who you trust and you send them the hardware and the complete device and you look at it and go, this is good enough.
No, you can't do that with a human.
No, so you're going to have to figure out some way of saying that this is good enough. It's the only, that's on you. I can't tell you what that is.
We'll have to find a way, but my point is that it's a different game than for GPUs.
Yes.
That problem has been solved already. I mean, OEMs do this every day. That's how they choose one solution or the other. You have quality reports. You define how the image should look with this specific amount of light, and those specifications exist. We just need to follow one, and they are objective and subjective. They are both. We in Chrome OS, we use third parties to validate that a camera quality is good enough. We can use the same, and we can.
How much do you pay those third parties? How much do you pay those third parties to validate that?
That's a question for
yeah, but I mean, the community can't do that.
No, but you don't have to do it. You trust a third party, and you say that the vendor needs to provide you a certificate that this vendor is conforming to this quality, and they will do it because they want to land the code. And they will tell you that this, according to this specification, is good enough for that specification.
Yeah, like if you define a process or an agreement, that something that's, like I said, something that they have to go through and say at the end of it that this is passed by those people and you trust those people, you don't need to do it yourself then. You just let the company do that and give you the result. And then you say, okay, this is valid. And
the report doesn't come
again, no, you'd probably, that may be even too far. You may not even need to go that far. But again, you have to figure out what's the most appropriate thing in your industry that will cover that.
You can have different rules based on the market.
A quick question, just from my understanding. Measuring image quality, that depends hugely on your lenses and sensors and whatever. So what do you, when it comes to upstreaming an ISP, the chosen sensor and lens is not included in that. So what sort of test would you do there? What would you use in order to determine that the ISP can reach good enough image quality?
You're absolutely correct. It's always the combination of ISP, sensor, and lenses.
And that's a very good question, and that's why I'm saying that this is a bit of a different game than GPUs when it comes to testing. And we'll have to decide on that, but it's more complicated. Not just about running a conformance suite or a benchmark. There's more
I don't think that this is actually a problem. I mean, if you go to any of those certified testing stuff, they have their own hardware, so they eventually may have one specific sensor with one specific lens and use this for all different vendors. That would be one option. Another option would be to have different profiles. So this is level A, level B, and we may have things like that. I don't think this is the problem. I mean, the idea of having a process like that works. I'm just not sure how to implement this in practice. I mean, we as an open source community, how can we require those kind of things?
Just on the topic of the image quality, can't you just cut out the sensor and like replace it with like some sensors have like static images that you can configure them through I2C, right? Or like just if it's MIPI sensor, generate the MIPI stream and like have some standard that you will like pass to the ISP. Then you control the input and you stream the output of the ISP, and that way like you can validate like how good it is.
But the real problem is not if you stack images. The real problem is when you change the lightnings and you change the backgrounds, you have a close or a more distance camera. So all of those affect the algorithm. So it's not an easy test like that. But of course, a library, proper lab could be doing those kind of tests, but then someone needs to write some specification about that. And someone needs to enforce this kind of things, and I don't think we developers should do that.
And yeah, but there's the calibration files, they are usually always agnostic. So if there's a product in Windows supporting that combination of sensor lens, you just take it. Yes.
So I'm slightly confused because we're talking about mem-to-mem ISPs, right?
Yes.
So you're feeding the images to it.
Yes.
So why would the sensor matter? You have your set of conformance test images, and that has to pass.
It's a real-time process, right? So for instance, if you think about the auto exposure, making sure that you get a properly exposed image, not overexposed or underexposed, that's going to configure the exposure time, configure the gain on the sensor.
Even if it's a real-time thing, you're still passing it, capturing first, then feeding it through memory to the ISP. You control all the inputs. You just have a sequence for it.
It's a feedback. It's a feedback loop.
Right? So you're saying that once the parameters are configured, then the input needs to change. Is that?
So the way it works is that you're going to calculate parameters for the ISP based on information you got from the previous frames. They're going to be applied to the next frame, and you're going to keep doing that process. If you think about, as I said, auto exposure or autofocus, if you want to make sure that the autofocus implementation works correctly, well, clearly you have to have a sensor with a lens that you can move, a focus lens that you can move.
So it has to feed back to an actual thing.
It has to feed back to actual hardware.
It. Okay.
And then it's very difficult to run 2 runs of the algorithms, like changing something, and see the impact, because the world changes. It's the mechanical world, the physical world will not react the same way twice.
Unless you unless you have videos that are changing light and changing the focus. So what you can do.
I have to say that it's very hard for the eyeball. You verify the IQ quality. Okay, so just to share something that for very professional testing that we have, that actually we compare the actual output versus the algo simulator output, which should be reached bit by bit, right? And this is the one only can be done by the ISP vendors. I don't think we need to propagate to open source. This will be a duplicate effort, because the one we upstream those code, we guarantee this is matched.
When you say it's us ISP vendors doing that, I agree that that works for a specific use case, but again, we are not looking at other people using your ISPs in their product and giving them the possibility to do their tuning for their specific use case, which might be very different than the one that you have been tuned for. And with all the discussion, it seems to me that we are trading one open source tuned implementation for a very specific use case, with maybe also configuration parameters for a very specific use case certified by the vendor, with the possibility of giving third parties full access to control of the ISP for doing tuning at the same level for their use case. And that it cuts out a lot of middle size or third parties from having this possibility. I'm not sure if that's desirable, that's it.
I'm saying that we should first solve the problem for most of the users, and then the market will automatically solve for the other ones.
Most of the Chromebook users or most of the users?
No, most of the users. Number of users, souls, number of souls. What is more important today?
Are there more camera sensors integrated in IoT and embedded devices or in Chromebooks? I mean,
in mobile phones or in IoT? I'm pretty sure it's mobile phones. And this is what we are talking about.
No, we're not talking about mobile phones.
I'm talking mobile phones.
No,
Yes.
nobody in this room is talking about mobile phones.
Everybody's talking about mobile phones. No. Everybody's talking about complex cameras, which is basically using the ISPs that are in place in mobile phones into other markets.
No, there are a lot of embedded and IoT use cases which are complex in the same. It's complex in different way, but it's complex as in the mobile phone or tablet or Chromebook, whatever call it, use case, personal device use cases. And those are, again, I don't want to stress that out too many times, but it's more encompassed with very specific use case that maybe we are cutting off from the market completely because they won't have access to the tuning parameters of a specific block of the ISP because that block has not been either documented or even exposed or described by the vendor.
They have the free choice to buy another ISP.
Yeah, and it's like if the vendor's not talking to them now, they're not going to get anything now anyway. They're already cut off. You're not helping them. All you're doing is giving them a longer delay because the vendors aren't willing to do this. So if you give them the open source driver that exposes a number of chunks, there may still be bits we can't see, but then you have to let them go to somewhere else or find a friendly ISP vendor. You can't save them all. There's just not. This doesn't scale like that. You need to find the point where there's an inflection point that will cause things to move sufficiently that pressure from those people will matter because it will be from the ISP's point of view, it won't be I have to release 100% of my stuff. It'll be an extra 5% or we work with NVIDIA. It's like, how does this work on your GPU? We're not telling you. And then you come back and go, well, could you tell us this little bit? And they'll give you that. And then a year later, they'll give you the thing you asked for in the first place. But it's like, you need to build a community of those people to say, this is something we need. They need to get that requirement into your camera and push it back
I think
down.
we're already building the community.
Yeah.
And that was my point.
Just a quick question. Raspberry Pi, the work your guys doing, can you tune those? Is that open? So there is a possibility for, if you are an industrial designer, you want to have special use cases, then the Raspberry Pi, hey, that might be a good choice. So if, say, another vendor who doesn't have that, so it would go into lib camera and it would be, say, it would be optimized for laptop use, okay? It wouldn't be able to do that. So then you have to advise someone, oh, I want to use it for a specific application, and then you can say, okay, yeah, you can't use that. But hey, the Raspberry Pi, hey, those guys are great. And that would push pressure on that other vendor, hopefully in the long term, that won't happen overnight, to perhaps also allow that. But it would be a different problem if nobody would have it. But there is at least already one that can do this.
You can't force a company that isn't willing to play with you to play with you. If they're not willing to talk to you, then no amount of pressure you put on them will work.
Yeah, I would also, in the same line as Hans, for me, we have already one good example, which is Raspberry Pi 5, but if for the other vendors, if they have something that works fine on my laptop and on my cell phone, I'm pretty happy with that. I mean, we can go further than after this is already a standard, but it could be done later, in my opinion.
So first of all, I don't think Raspberry Pi is a good example here, because if you're building would Cisco put a Raspberry Pi in their product? You complained before that... Yeah, I mean, you've complained before with that using some vendors who I won't name, and you're dealing with the closest camera stack and it's painful. So now we have competition in the market. Would you replace that vendor with Raspberry Pi?
It would be an interesting idea, by the way. I'll talk to my boss.
But what I'm saying here is that in a perfect market solution where you have lots of competition, some are open and some are closed, I would agree that that would be easier to do. But we're not at that point now.
That particular vendor has way more problems. So, you know, if you can, a big problem today is, that's just true. Lots of laptops have these Intel chips and you don't have a webcam. Fix that. And we want that to have tuned. So you already make a lot of users very happy. And then the next step will definitely be, okay, can we improve this further? So I like that idea of just ratcheting up. But you can't just almost there. You can't just postpone getting it in until, okay.
You mentioned Raspberry Pi as a good example of that. But Raspberry Pi, they did an amazing job, but they've not been the only ones. We have more vendors that are doing the same. And if we place ourselves 5 years ago, and if we 5 years ago would have said, okay, let's give all of them a free card for doing pass-through, we would not be here today be happy about Raspberry Pi or Mali or RKSP1 is well supported mainline, ISP, IMX8 and Plus from NXP supported mainline. We got there because 5 years ago we decided not to do pass-through.
But that's not a valid argument. Nobody can predict the future. The same argument could be that if 5 years ago we went for a different model, now maybe we had 5 times more vendors. So that's not a valid argument.
No, I disagree there. We have 5 of experience there engaging with the market. We are growing the numbers of vendors who are supported, so we have actual data points that show that what we're doing is working to some extent. And you propose replacing that with something that's based on no data point.
Based on DRM data points. You can use their experience, and based on their experience, they're doing an amazing job and engaging with vendors and providing drivers to users. Because at the end of the day, what we should care is about users. That's the only thing we should be caring about. We should provide, our Linux should be useful to users.
Well, first of all, we're talking about GPUs and cameras, and that's not the same thing.
It's the same model. It's the same people that are making GPUs are making ISPs. Yes.
So I think the key things is that for open source, we need to allow or support different business models. The Raspberry Pi business model will be different to the model to Intel or the other companies, I believe, right? And we cannot force other company to using the same business model. That's the key. Then from the open source, we need to support all different kinds of the business models. That's the spirit of the open source, right?
There might be business models, but I think it's more important the internal culture at each company, and as well a power plays between different groups within each company, and we cannot see that. But I think that's probably the single most important thing which tells us if a company is going to work with us or not. We just don't know. But it's very cool because when more and more companies start playing in such a way compatible with mainline, then we see that some arguments that people are debating internally at each company, they might not be valid, which is again patents and competitive advantage. And the people who are fighting those battles within each company, they may have more ammo if there are some companies which have been able to make business, gain customers by playing well with the community. So it's not just about market pressure. It's as well about changing minds within each company and community.
Yes, I fully agree with that. And that's something we're seeing happening in quite a few companies we've been engaging with. And going back to what Chenyu said, I agree with you that we can't force people to do what they don't want to do. But with the rules that we have set today, with ISP support in the kernel and what we're doing in libcamera, there are people we have approached a few years ago who said, no, we're never going to do that, and today they are changing their mind. So what we're doing today is working. And it's not working with 100% of the ISP vendors yet, because you can't address the whole market in one go. But I have good data to show that it's actually working and it's expanding.
Why don't we let the vendor choose? If you are offering them a value, they will choose that solution. There needs to be a win for. I mean, vendor. If they use your solution, they are going to have more market. They will use your solution.
We're letting vendor choose. I mean, on the IPU6 case, for instance, we haven't had a driver for the ISP for use. People are complaining about that. And Intel could have chosen to open a driver and document what they have. They have chosen not to, so they have chosen to impede the users.
We have chosen to ignore millions of users because they are...
No,
yes,
Intel has decided to let down the users.
No.
Intel has decided to let down the users.
I don't agree with that. I don't agree with that. No, I don't agree with that.
That's argument, it's really hurting. It has been used many times, saying that we are hurting users because companies that refuse to cooperate in a way and decide to release binaries, as the IPU6 fiasco has been, they're hurting users, not us. That's unfair to say, in my opinion.
Let me put something. The real thing here.
Sorry.
Just a second. The real point here is that what I'm seeing here is that we are, as Video for Linux community, not the API, nothing related to any technical issues. It is all about those non-technical ones. We, as a Video for Linux community, we really want something that works and that is open source. And vendors have been pushing for a long time, since maybe just after N900, all the other attempts of adding ISP were at the line of closed source. And we've been attempting up to now with success, we are blocking those things. So right now what I'm seeing is that people are trying to diverge using a DRM as a escape route. I mean, we as a community should not allow this. It doesn't matter for me if this is implemented via Video for Linux or via DRM or via whatever other subsystem. But we really want to have open source drivers that work in the central way. It may not be the perfect world, but it should at least provide something that has enough quality for the ones that will be using the cameras.
And that's what we are discussing now. Now we are discussing if we should drop the requirement of having everything open that goes from user space to the hardware. Nobody has ever discussed allowing drivers that are useless. Everybody wants a camera that is useful. That's what everybody wants.
Is the level of quality that you expect the open source implementation to provide, is that something that will be good enough for Chrome OS?
Yeah.
So can you commit today that Chrome OS will ship only open source code for camera support on IPU6?
I cannot commit to that. I mean, I'm not in that position to commit to anything.
Is it good enough or is it not good enough?
It has to be good enough. I mean, that's what I will be pushing for.
So,
what I promise
if it's good enough, why would you use the closed source?
I mean, we can call Sundar, and he will tell what he did with this. But what I can tell you is that in all my power and will, I will try to push for that. And I've been doing this for many years. So there's no reason to believe that I won't be doing that.
Yeah, but I don't believe it's going to happen.
Look, even if the quality was a little worse, I would still ship the open driver. Like, that's my choice.
Okay, so it's open driver, open user space, fully open stack. That's what you would ship?
I would rather ship an open stack. It's easier for us to maintain. So given the choice between like some, and we've done this before, right? We do this today. We actually ship open drivers in lieu of closed drivers, even if they're missing features or have lower performance or lower quality. We do that because it's actually possible for us to support and maintain. So yes, I would drastically prefer an open driver. Now, if open isn't open and it's just a blob in user space, well, that doesn't give me any advantages. I can't support that any more easily, right? So I don't want that. I want a fully open driver. But fully open also doesn't have to mean every register documented, every feedback loop documented, right? It's like and I think that's what we're arguing about here. Like some people bias very far down towards everything fully open. Other people are like, hey, you know, not everything's open today. We've got firmwares running we don't have any visibility into anyway. Like that's not great, but it's better than nothing. And I think that's kind of where the disagreement is here.
But what I hear from this discussion is that everyone sounds like to be happy with the current IPU, well, or not the current, but the IPU 6 functional scope that would give some kind of image. So whether or not this would be a VFRL 2 or alternatively a DRM driver, would that matter anymore? Much. I mean,
like
if the Userspace API would have the scope that would only be supported by the partial hardware support, so there would be no API to access all the features of the hardware.
I was ABI, not API.
ABI. Yeah. Fair enough.
I'm sorry, I didn't understand. You're saying if there was a
if we limit, let's say that we would have open source stack. Full open source stack support for IPv6 that limits the hardware features to those that would be only used by implemented by that stack, and the UAPI would not allow to use the rest. Would everyone be happy with that?
So you're asking if you shipped a driver that just implemented the features that we need, would we care if it didn't implement features we don't? I think that definitionally, no, we don't care about the ones that we don't, and so that would be fine.
Right.
It's not ideal, it's not great because it doesn't expose the full functionality of the hardware, but from a use case perspective, we're just about video conferencing basically. We don't care about world camera quality that much. So if it's a little bit limited, I think that's fine. We'd rather have an open driver that we can maintain better, right? And as for the API question, I know that's a different question. V4L, in my opinion, is really big. It's really highly featureful for like boards and tightly integrated stacks, but it's also, I don't think, ideal for a lot of the desktop SoCs that we see, where discrete IP blocks like video encode and decode or camera ISPs or whatever can be represented with much more small and targeted APIs. But that's just a broader discussion.
Just to make my position clear when it comes to video for Linux against DRM, if the openness requirements are the same, I'm going to judge that based on technical merit. So, as was written on a previous slide or further, I don't remember, I'm not going to block that on principle just because it's DRM and not video for Linux. I'm totally fine including in lib camera support for DRM-based drivers, as long as that matches all the rest of the requirements. So that part is fine. And regardless of whether this particular driver or other drivers will use DRM and video for Linux in the future, we did identify a few shortcomings and things that are already being worked on in video for Linux, improvements that would benefit ISPs but also benefit codecs, and those are things that will be done anyway, regardless of whether we do it for ISPs or not.
Yeah. The discussion is basically vendor pass-through, if this is something we want to accept or not. And I think we have seen some experience from DRM. We have been having our approach for years. Yeah, please go ahead.
Yeah, and the thing is, like, I don't think the V4L2 versus DRM thing really matters. I would not accept a DRM driver without Laurent or someone in the camera community telling me that they wanted this driver in DRM. I'm not going to go, Intel sent this to me, of course I'm going to merge it. That's not, your community is your community, and I don't have enough insight to know that. All I have is, you told me you wanted this, I'm happy to put it in there. And you will end up being the maintainer of the camera section of my DRM bits, because I don't have that level of insight. And I don't probably have space to fit that in my brain. But yeah, so again, if they define, if the API they end up giving in DRM fills all of the lib camera's requirements, but it's still quite identifiable as a vendor pass-through, you can try and push back and say, well, maybe we should limit the kernel driver to only accepting certain things, and that's fine as well. That's another negotiation of when you develop it, because vendor pass-through should not be the goal of any person writing a kernel driver. If that's a side effect that kind of works, it's impossible to avoid. Yeah, but it's, again, everyone is an individual negotiation. There's no rule. The minute you set a rule saying no vendor pass-through, they're going to call it something else. They'll just make it a multiplex or ioctal magic thing that stuff goes through. Whenever you have an API that exposes an entry point, someone can always write another API on top of it that puts all of our entry points through that single API. So it's like you're just moving the game up. And
that's not possible in Video for Linux today because we are passing we are passing concepts. We are not passing.
Yeah. But you're suffering from the fact that that doesn't scale in the performances and so to get to the point where you have a driver that is what solves the problems you're having and fits the hardware model. You are going to have to accept that vendor pass-through is going to be a negotiation. You just go, it's obviously what you're doing here. We can see it. We're going to stop that from happening. But it's going to be every trust problem.
I like how you phrase that. Vendor pass-through should be a side effect, not the goal. To revert the question, so Video for Linux versus DRM, I explained my position on that. So if we have a particular ISP driver, if that driver can be implemented with the same level of effort, in the same level of performance in Video for Linux and DRM, would you still say it should be done in DRM, or would you say no, that Video for Linux is a good fit?
I think it's like, if you find yourself in the kernel writing floating point calculations, you're probably in the wrong place. If you find yourself in the kernel needing doubles, unless you're AMD's graphics driver, you're probably in the wrong place. Generally, if there's a complex set of calculations that need to get you from what the API wants to what the hardware wants, and it's a bunch of floating point calculations or a bunch of table lookups or a bunch of, that should be in Userspace. And it's the same thing for video decode engines. And
there's no disagreement about that. I mean, that's not the question. Video for Linux or DRM, that's going to be in Userspace anyway.
But then, if that's all in Userspace, if the other problem is it's 10 ioctals to get to the thing, and there's no nice fencing. You need fencing, or those things are already there in DRM, so maybe it makes sense. And it's like if you can bring the V4L API up to the point where that it implements the same thing as DRM, then you don't need a DRM driver. I'm not. Again, if someone does one in DRM, we have to decide it was a bad idea in 2 years, and we stick it in the other one.
And that goes back, I think, to the, I don't know if you, to exactly that slide. If we can't fix the problems in Video for Linux that actually hinder the drivers in a reasonable time, then we're not going to block a DRM drivers in principle, on principle. If those problems are fixed, I'm not saying I would block a DRM driver in principle, but if a vendor tells me I could do that with Video for Linux and there would actually be no drawback, tell them, well, why do you do it in DRM in that case?
But I think it's definitely should be a reflection of the hardware programming model, and that's what draws that line. And I, as I said, I think in stateless stateful decoders, you already went the wrong way with that. I think a lot of the stuff that happens in stateless decoders should be in Userspace and should not be in the kernel. And I don't want you to say that mistake again.
I can't answer that.
Just in terms of like, you shouldn't be parsing H.264 headers in the kernel. You shouldn't be parsing that sort of stuff, calculating in the kernel, because
the stateless decoders don't. Right?
Some of them
that's done in Userspace, right?
I think some of it.
Short answer is I don't know the details. I have to double check. But there is some looking into headers.
But if you're parsing untrustable stuff or parsing things that are you don't want to be arbitrary calculations, but if you can get V4L2 to have a model that. I think the other thing that helps is like if I have to implement a whole lot of pointless boilerplate in my driver to satisfy a whole lot of requirements of the subsystem that aren't necessary. Now, like that sort of thing, if I have to do a whole lot of stuff with like, I don't know enough about this, but like say like I have a whole lot of format handling that's just required because that's part of the way V4L2 works, but doesn't fit my model because that's all done in Userspace. Why, that making that simpler, and ioctals, do I need ioctals for every single thing, or is there some way we can, like, IOU ring style? That's one thing, like, do you build command buffer type things, and that's a bit of work, and it may be just better to build that again in DRM on top of what we have, but it may be better to do it in V4. I don't know.
Video for Linux actually supports metadata on buffers that could be used for pass-through, even if we don't want, some vendor can still be using these kind of things. So everything that is needed, at least but the basic functions are already there. Maybe, I mean, we don't have fences, maybe we don't have some specific things, but I guess in terms of functionality, we have most, if not all, the things that are needed for ISP support. Of course, someone will need to write things, try to port a driver. If they are missing features, we will be adding, but there's not nothing really blocking, I think.
When it comes to formats in Virtual 2 and you're supporting ISPs, the information on what the format is used for those buffers, it's needed for processing and acting on them. So that is provided by Virtual 2 API. So, and I think that it's a good thing that it's standardized.
So when it comes to the formats, the reason we keep that as an explicit API, which makes it more difficult indeed, is that for all the hardware generations that do not have IMMUs, for instance, you need to validate the format against the buffer size. That has to be done in the kernel, so the kernel needs to know what the format is and needs to make sure it will either write the registers corresponding to the format manually or patch the command buffer with that information itself. But that's the only reason. Everything else of the ISP, we don't do that through explicit consent with Virtual 2 API. It comes from a buffer that's constructed from Userspace.
Again,
maybe just on the stateless decoder part that we talked about. Most of the parameters that we have, we actually just pass through, like basically the user space calculates it, we pass it through controls, and we basically just set the registers directly with small diversions. Like I don't have all the drivers currently now in my headspace, but I think for the most case, like we do stuff like maybe we convert a scaling list a bit before setting it to the registers, but otherwise most things are passed through.
Yeah, I guess that's one driver that actually formats on H.262, I guess. It's an old driver, so it has an MPEG thing there, header there, but just because that driver was a very old device, a very old camera device. And we do have a few things done in kernel, but for Vivid driver, if I'm not mistaken, in order to test. But just that, normal drivers is all on Userspace, as far as I know.
So I have a query in the DRM. Whatever the lookup tables prepared in the user space, right? So those will be sent as commands to the kernel that will send to the hardware. Right? Is there any validation happens, the generation of the lookup tables in the user space or kernel space? What content they are filling in the memory? No. My query is whatever the lookup tables registers prepared by the user space, the most complex logic in the user space, is that validated, and exactly is there a validation what exactly those lookup table content is? Or it's a pass-through?
It depends on the hardware, I suppose. It depends on if you're just passing a bunch of values into the firmware and the firmware is going to validate, there's no need for the kernel to get involved. It should just pass it through. If there's like, generally the only job the kernel has in these situations is to make sure you don't screw up the rest of the system, and that's like address validation. You don't go using pages that aren't yours. You don't go, and if it's just a set of parameters that makes no sense to the kernel and it has to go to the firmware.
So pass through to rest of it.
Those things go straight, but you would be generating them in user space, and so you should know what they are and what they mean enough that generate.
So that user space, whatever it generates, right, are those documented or based on the hardware, just it's a blob?
For most of, like for GPUs, it's just blobs. Like but we have virtual memory things and stuff. We used to have to validate each command and know exactly what was in all of them. We still do know what's in them, but we generally don't have to validate it anymore. But it sounds like for most of these parameters, it's not like containing a bunch of addresses or a bunch. Like we often have problems where we've got descriptor tables, as Daniel said earlier, and some of the descriptor tables have pointers to some of the other descriptor tables, and those pointers are addresses stuck in the middle of these blobs of data, and you have to know where those are so you can say that these are not going to cause like memory faults and stuff. But it sounds like that's not really a concern in this case, that the parameters are just numbers and they mean something meaningful to the firmware or to the hardware, and it would be good to have those documented, but the ability to generate them in the user space code is what should be open source, and that should be where you see that, not in the kernel driver.
Yeah, I guess the only parameters that may happen on some source of stream is the offset, because sometimes there is a header in whatever frame there is, but except for that, all of them are just random numbers that Userspace generates and you just pass through the driver.
Actually, the argo parameter that sending from the user space to the kernel space, that it's very hard for the kernel driver or the firmware to verify. There's a huge number of it's a mess. So usually that what we need to do or what we need to protect is that to make sure that those kind of data that, for example, the address, right, DMA, will not impact the rest of the system. However, that inside the ISP, the parameters, we will not do any verification on that. Right.
Just to make sure that we are on the same page, that's the same thing that happens for Linux drivers today. It's.
I think we have an agreement on this topic.
I think we're running in circles.
Yeah.
This is pretty much what we agreed on yesterday. That is, we want Video for Linux to be better. Video for Linux, we want to have less segregation, less fragmentation. But if we cannot achieve that, we are not blocking DRM. But that's fine. I think, and at the end of the day, this is a technical discussion. It should be based on technical merits. The problem is a not technical discussion, and I'm seeing here different positions. So I think in one side, I think I have heard Mauro saying that he's okay with if the camera is good enough for video conferencing, and there's a chance for having vendor IOCTLs. I see your position when you are completely against having anything which is not documented.
That's not true. There are things that could be undocumented.
Sorry, then please say your position.
I mean, that's the problem. We have to agree on the level of documentation what you have and for what parts of the ISP, and that's the difficult part. And certainly, I want more things to be documented than you do. I'm not saying that I want to reach 100%. As they mentioned, we may have the occasional bit of byte somewhere that has to be set to a value, and I don't care much about that. But if you give me and tell me, well, you're only going to have basic denoising and not good denoising, I'm not going to be happy.
But you're in an amazing position because you have the keys of the castle of libcamera. So you can decide if that driver is shit. You can say, based on case-by-case basis, you can say to the vendor, this is not what we want, this is enough.
I'm not disputing that.
So
I think we have a discussion scheduled actually for tomorrow morning to start discussing that and what would be good enough and what wouldn't. But that's a process that we're not going to have an answer on that in 10 minutes.
But I just want to make sure everybody's position. So that's your position is, can you say it yourself so I don't make a mistake?
What's the question?
What is your position about
on what?
About vendor pass-through?
Two different questions. So vendor pass-through, I like the way they phrase that. If it's a side effect, that could be accepted. If it's a goal, I don't like it. About the openness, that's not something that we can answer in detail in 10 minutes. Overall, I want to make sure that we cater for the needs of different markets and not just Chromebooks. And that means that we want to make sure that users can tune their cameras themselves.
I have a question for you about that.
Okay, just to finish on it and then get to your question. It doesn't mean that I want vendors to open source the tuning tools, but I want to make it possible. So the parameters that are calculated during tuning and that need to be applied to the hardware, those need to be documented somehow so that my tool that generates them. So to give you a clear example of tuning, assume that, I hope that most people here would be familiar with the lens shading, the fact that you have this vignetting effect in the darker corners. So you tune your camera, you take lots of images in some environments, and you're going to calculate coefficients so that the hardware can correct that. I want to make sure that the way those coefficients are programmed in the hardware will be documented so that I can make my tool that will generate them. If you tell me that there's a tuning file that has been produced by a vendor tool and contains binary data there, and even if you tell me it's a data offset in the file, and then you just take that and pass it through, if you don't give me the ability to calculate those myself, then I'm not going to be happy.
What is the value for that? For
Chromebooks, no.
Yeah, but for IPv6 devices, what is the value for that? Why do we need to dictate where vendors have to sell their products? If they don't want to sell it...
Just saying, I understand Laurent's point about different segments. So whether you're talking about security cameras or something else, the needs are going to be different there than on a clamshell device, right? And the driver requirements and openness can be different too, right? So in the case that you're talking about, maybe the OEM is providing these tuning files as part of the device, and that's what you want to use anyway, right? But in a case where you have a more dynamic environment, you really need to be able to control that. Different devices and different drivers can have different requirements about them, right?
That's also why I asked the question earlier, if it's okay to discriminate between vendors. I'm not sure if we're making today a public statement that says that Intel will never sell in the IoT market. Probably not. But that's also an interesting question. How do we decide what market the vendors are interested in? But I don't think we're going to answer that now. But Hans, you had a question?
I had the same question.
There we go.
Yes. So personally, if a vendor is, say, very specific to the laptop market, then, okay, personal opinion, you probably disagree, but I would be happy if the tuning would just be available for that specific market. So you can assure that the Chromebook market, the general laptop market, you get a good webcam. If, however, like a Raspberry Pi, that is likely to be used in loads of different situations because people love to hack and use it in all sorts of weird and wonderful ways, there I want to have the full support. And the same is probably true for a lot of the embedded systems. Because we know they are used in weird and wonderful ways. But for something that is very much geared towards the PC market and for laptops and in the webcam scenario, do I want... It would be nice to have, right? Yeah, sure. But should it be a requirement? Should it something be that we really require? And as a consequence, if you decide, no, we're not going to do it, I don't know if you will, but suppose that you would say no, then loads and loads of customers would be very unhappy, and they only care about their webcam. So that would be my personal opinion.
I mean, looking at the market segment, something that makes sense. I'm not disputing that. And clearly, Intel is much bigger on the laptop, the tablet market segment, those segments. If you look at vendors like MediaTek or Qualcomm, are they only in the laptop segments, or are they also in the IoT segment?
I mean, that's an interesting case, because that's one where, like, if you say they have to open pretty much anything, they're just going to be like, well, we'll stay downstream then, right? And so I think that's like Dave was talking about, the Exynos driver. I think those guys are in that category. Like, if we get something from them that, like, gives us, like, an image with an open stack, like, we should start running with it, right? But that's just my kind of view of it. Although I do know that, like, say, Qualcomm, you know, they're moving beyond the mobile space, and they recognize that especially, like, you know, in security space or IoT space, that people just need to be able to run with their devices without having to interact with them and their software teams. And so they're realizing, oh wow, we better have this stuff upstream, right? And so they're already facing market pressure, and so maybe we will see more openness from them in the future. And so if we see, you know, submissions from them in that context, I think it'd be right to kind of say, hey, you guys are missing out on these pieces, and we need to have some openness for that.
Well, I think that's a very good point. And they face market pressure because they indeed going for different markets. And my understanding, based on lots of discussions I've had, is that quite a few of those companies have struggles internally. They have people who are pushing for things to be more open and people who are pushing for things to be more closed. Do we want to help the people who are pushing for more open? That's what I want to do. And that's what I want to set the bar a bit higher in that case, because that will give those people the right arguments to push internally to win the fight. If we say, no, because we haven't had those vendors ever with anything open, we're going to accept something that's very low, then it's going to be very hard for those people to do the right thing. And I'm not saying we have to reach 100%, but setting a bit higher than lower, I think for these is the right option.
Johan, if we have calibration files that are system agnostic, meaning we force the vendors, if they want to have their drivers with us, they need to give us a way to consume the calibration file from any system they are using. So if the device is using in IoT, I will be able to use that calibration file. If the device is used in Windows, I will be able to take that file and consume it in Linux. Isn't that covering every single market the vendor wants to sell?
That doesn't help me. I need to know how the coefficients. That doesn't help me if I need to know what is the coefficient, the number of digits the number of digital digits that I need to program the coefficient with. I need to tune that myself.
We are basically saying that we want to use that ISP with a sensor that cannot be tested and might not work at all.
No, the thing is, the IoT OEM has to be able to take a particular SoC, connect that to a sensor they choose, with a lens they choose, and handle the tuning themselves with open tools. It doesn't mean that the vendor has to open their tools, but this has to be possible.
Okay, so I disagree on that one. I think Hans also disagree with that one. Correct me if I am putting words on your mouth. Can we try to find some middle ground?
I think you're falling into a very obvious trap here. It's called making a rule. Stop making rules. Start negotiating with the vendors individually, one-on-one, two people, community and vendor. You are trying to define a set of rules that will get gamed. Do not do this. You're falling into the rule trap. Look, I have a really, Laurent might understand this, but when graphics cards first came out, people would not tell us how to program the clock to set a mode. They would give us a random table of, do you want 1024 by 768? Program 4 of these values in. And do you want 128? And every time a new monitor size came out, you had to go and beg them for the magic numbers. And eventually someone went, why don't we just get the PLL algorithms and work them out? And people did. And the companies then just never do that anymore. And it just went away. It was like, these things you have to just negotiate. If you guys can say that, look, we're going in with this level of, I want these parameters, and they can go, well, I don't think our market segment requires us that's going to be useful for you. You get to decide then. You talk to them. You can't make these rules and say, this is the stance we're going to go in with. You need to go in and say, what are you willing to give us? We would like to get you up to this point. Where can you go? You can't you can't publish something that you give to all these vendors and then let them go away and come back to you. You have to have a conversation with every vendor, and it takes time and it's a pain in the ass. There's no industry rule you're going to get away with here. It's lovely to think that might be great, but it never works. And it's
just to try to find a middle ground here.
No.
It's just a statement.
You're falling into the trap.
No. I don't want to. I don't want to put a rule. I just want to. After this discussion, it's anybody here that disagree that if we have a camera with the correct openness to be defined, and an openness that satisfies sleep camera, we will allow a vendor pass-through for that specific situation. Is there anybody against that statement?
Not that way. As I said,
I wouldn't say that, because you used the word vendor pass-through as a goal. It's not
exactly what I was going to say.
You were never allowing vendor pass-through. That's the simple answer. If someone comes to you and you want vendor pass-through, your answer is no. There's no vendor pass-through ability in this. If it happens as a side effect of this process that you can happen to do a vendor can pass through things to their driver, that's an accidental thing, and they may take advantage of that. But the rule is no vendor pass-through. You want the lib camera is the rule, and the side effect, but you cannot say those words in your statement of what's acceptable. It's going to end bad.
I would say that now that there is no command buffer. It's just basically a request to capture a frame and with certain parameters. So I don't think that there would be a vendor pass-through as a side effect. It would be a goal, rather, in this case.
There's a bit of a question of vocabulary. I mean, we've been talking about command buffers and parameters buffers. It's command buffers for GPUs because they execute things. It's parameters buffers for ISPs because it configures the hardware, a fixed pipeline to do things. But that's... Yeah, I don't think the vocabulary matters too much in this case.
Yeah, so I think maybe it would make things clearer if we agree on why we want more openness or less, because I don't think anybody said what the goal is. And I think it ties with this thing about not having rules, trying to understand the other party, because if we really know why for us it's important to have more openness or less, then we can also explain our own position to the other side, and they have a chance to also understand us. So my understanding is that on DRM, if we really need for stuff to be open, it's because otherwise we cannot do our job as maintainers in the kernel. Because if we cannot really test and debug the code that reproduces a regression. We just cannot keep doing our own job. And what happens is that if we allow people to pass blobs and we don't know what is in there at all, and the vendor has some blob that people use, what will happen is that at some point we will have a new kernel and people will complain that their stuff is broken when they upgrade. But they are using a blob, we don't know what is inside it. So we cannot really figure out what broke in the kernel. And maybe we just find out that bisect, and this is one feature that somebody added. Do we have to revert that feature because people are using some blob from the vendor, and we don't really know why?
But I think everybody agrees that we should have an open enough implementation in libcamera. I don't think that that's part of the question here. The question is, what is open enough? And if there can be an alternative implementation by the vendor for that driver. Something alternative to libcamera the vendors can use.
Yeah, that's no question about that. It's totally fine. I mean, vendors can create their own implementation.
The problem of sending blobs to the kernel, and we did deny this in the past because all the vendors were to just pass this through, is that we don't want something completely undocumented. Now we have libcamera, and I'm perfectly fine to receive some blob from libcamera, provided that libcamera will do the right thing. So I expect to have an open source code on libcamera that will be doing whatever it takes to send me a parameter. It could be just a table lookup. I mean, doesn't matter much if it is just adjusting lightning because of the sensor or because something. I don't really care how those parameters are calculated from my side. I mean, not talking about Laurent, but from my side as a kernel maintainer, I don't care if this is calculated using some fancy algorithm that only Intel has or only MediaTek or whatever. But what I do care is that the entire solution needs to be open sourced, because this way, if something wrong happens, we can track, we can fix, and this way, the Linux users will have a decent solution for them. That's what I do care.
We are slightly behind schedule, about 2 hours. We were supposed to have a 30 minutes discussion about memory allocation, and I know that we have James Jones on the call remotely who's interested in that. Would we switch for that?
It's mine.
Yeah, I know, but I mean, James has been there for 2 hours and a half, and I don't want to tell him, well, okay, we're not going to discuss that, unless the room says that we don't want to, but I think it's an important topic as well.
My concern is that we have discussed a lot, we have said a lot, and we don't have any conclusion, and that's frustrating, right? So it will be nice. I like your approach. Like, let's say, what do we want from the drivers, right? I think I will go super fast. And if everybody promised to be super fast, we are done in 5 minutes. 1 second. So for me, what I want is that people using Chromebooks, they can use their drivers in an open way, as open as today, for the features needed by Chromebooks. And I also, as a Debian developer, what I want is exactly the same for Debian. I want to be able to use my camera with main. That's my main goal. If somebody can express if somebody has different goals, I think it's a really good exercise to do.
Just regarding conclusions, I recall a couple of points that I think that were mentioning. Please contest me if you disagree. I recall Jesse here mentioned that let's say that they would have libcamera support for IPv6, including the processing system. That quality-wise should be fine for Chromebooks. Is that right?
Yeah, I mean, has to have some basic level of quality, but I don't think that means like everything in your pipeline necessarily has to be enabled. I don't have enough detail to know what that would look like, but yeah.
Secondly, you had the blue slide that discussed the use of DRM. in case the Vida for Linux can't evolve in the direction that better supports ISPs. I think I guess there was rough agreement on that.
Yeah, I think that's what we agree on. Sorry?
The blue slide, I think we agree on.
Okay. Yeah, okay, that is fine. But the name of the meeting was the ultimate discussion about vendor pass-through. This is going to be like electing a pope. We close the doors until we find a solution.
And I think we have an agreement on that we say vendor pass-through is not acceptable. We don't want it, but if it happens by accident, it's fine.
But what it means by accident, so if in exchange of having an open and off camera,
Coming back to my point that we don't have common buffers, we basically have parameter buffers that define the parameters for which to capture a frame or process a frame using the ISP. There is no need for vendor pass-through there, so it wouldn't happen by accident.
Can we have parameters not can we have in our parameter buffers? Can we have parameters not documented? Mauro says,
can you explain me how it happens by accident?
Why not? I mean, if you look at the RAM system, there are lots of things that Intel, AMD, and other vendors have. They don't open it, but still the driver is open source, and still people can use their GPUs and do whatever they want. So if we have these kind of things, I'm completely okay of having some, we do have actually this on Video for Linux too. Not all the vendor gets any random sensor. Usually there are lots of random values that are stored there. We really don't know what they do. And that's okay. I mean,
and I think we accept that. We accept unknown values from the kernel to the hardware. But if we can, the question is, can we have buffers sent from Userspace where some of the registers are not defined? We don't have any documentation of them.
From my side, I don't have any troubles, provided that on libcamera we have open source for that.
Even if libcamera doesn't touch those files, if the libcamera implementation is taking the values from the calibration file and writing them to those without knowing how those calibration patterns work?
From my side, that's okay. From my side, that's up to Lohan to decide.
For IoT embedded markets, that's not good.
But for mobile phones?
For chips that can be, for ISPs that can be used in IoT, that's not good. The fact that an ISP is used in a mobile phone, that's not the relevant criteria. It's whether that ISP is also in the embedded market.
Okay. And it's fine to say that we want to decide market to market, and it will be a civil discussion for each one of these cases?
Was it civil today?
Something like this is fine.
I mean, I think we have an agreement also, and that clarifies a few things, that discrimination is fine. I entered the room with the impression that we shouldn't discriminate between vendors, but if the kernel committee overall think it's fine, then that's something we can do.
We had a kernel maintainer saying something about NVIDIA. So we can discriminate for sure. Do you have a different opinion? Is somebody having a much different opinion than this?
I'm just concerned, and I'm not in the position for making this decision, but how are we going to make a call on this?
I think it has to be a decision from the community based on trust, based on the market, and
case by case.
It should be case by case. Who is making that decision? That's a big question. Should be Video for Linux? Should be camera? Should be a combination of both? I mean, I'm expecting you to not be completely bananas with one specific vendor because you hate them.
I don't hate anyone.
It sounds like the requirements for libcamera would be more strict than for V4L2, because V4L2 is a kernel driver, and Mauro is saying like whatever libcamera passes through and libcamera properly implements, then he's fine. So I guess the bar is on you.
I think it's important to not say it's Laurent. Laurent should be representative of the community feeling at that time, and the community feeling will change, and his job is to maintain like what I've been doing for 20 years. It's like gauging the community feeling, reaching out to other people and saying, well, if this happened, would you be okay with it? And knowing whose opinion matters and, you know, who's important and, you know, who needs to be in the room for things. And that's, it's not, you know, it's just saying libcamera's job. It's not libcamera's job. It's the libcamera community that Laurent is going to represent. And that's, you know, building that community with people from each ISP as they come on board and making sure they're engaged in that. And when the next ISP comes on board with like, we don't want to give you this. And all the other guys, people go, well, we've already given them that. So don't accept it because we've already done, you know, reached that bar. Don't reduce the bar for them. Again, it's a feeling, it's vibes. It's not solid rules you can make up.
The challenging part is that the committee is fragmented today, so we'll have to keep discussing and try to find agreements.
I've been discussing this for 20 years. Every LPC, I have the same discussions with the same people about the same things. It's get used to it, and you know, and
I mean, yeah. I assume that in the DRM community, after all those years, you have a bit of a better consensus.
Not really. No,
I mean, it's not like you have 50.
So put it this way, right? Last year, I decided. I probably shouldn't say this out loud. I don't think I'd ever accept another C DRM driver, maybe not, in graphics space at least, that's not written in Rust. Someone would have to really push me to not to accept one because I don't see anything on the horizon, and I'm like, it's a waste of effort to start one now. I went ahead with that thinking, oh, gee, I'm going to get some pushback. I recently talked to a large company about a driver who I'm going to be writing in Rust, and expected the first time I talked to them about it being in Rust, they would say, what the hell, we're not getting involved, we want to do C. But they went, no, we're interested, we'll think about it. It's like, you sort of set these things in your own brain where it's like, oh, I don't think anyone will accept this. But sometimes you have to try, and sometimes you have to push it, and then you get the consensus of your community that that's something we should push for. And
okay, so the IPU 6 DRM driver should be in Rust.
Maybe. As I said, I didn't think of cameras when I said that. It was graphics focused, and accelerators are kind of on the edge of, yeah, I'm flexible. I negotiate on every case, every time. I don't try and set a rule, because it's too hard.
Can we use the last 15 minutes to talk about the memory?
And thank you very much, everyone.
Around a good plate and a good restaurant, we don't have this kind of discussions.
No.
All right. Okay, so I have a few slides which I will try to keep really, really quick to introduce the problem. I named this efficient memory allocation between different subsystems, but really it's also known as resurrecting the Unix device memory allocator work that was proposed and based on a XDC presentation in 2016. Can't believe it's that old, by James Jones. I rephrase, so there's a link on this slide to his slide, so if you can grab that afterwards to have the full details. I didn't want to make a full copy of that. But the problem statement is split in different parts. We're talking about how to handle buffer allocation. So how does an application allocate image buffers that can be shared between multiple components, multiple producers and consumers in the system in a way that will work and that will provide optimal performance. There's a question of, beside allocation of that memory, how do we negotiate formats? How do I need to configure my camera and my video encoder and my display? What pixel format should I use? What are the constraints on the strides to make sure that there will be interoperability between those components? And there's an added point here compared to the presentation from James, that is cache management. How do we ensure both correctness, obviously, but performance as well? So in this discussion, I'm mixing happily the words buffers, buffer objects, frame buffers, surfaces. They're used for different, in different ways, in different subsystems, different part of Userspace in the kernel. So it's a bit messy that we don't have a common vocabulary. But don't tell me off if I'm using one word instead of another, because we don't have a consensus on all of those across the whole kernel. One problem that James listed that I think is mostly solved is on synchronization. We do have fence support in the kernel. We have support for both implicit and explicit fences. My understanding is that explicit fences is the way to go for new APIs. And it's missing in Video for Linux. It's not everywhere. It is in DRM. And well, we discussed extensively before that this is something that we want to improve in Video for Linux as well. So I don't think there's really a need to discuss about this today. Basic use case, there's a camera obviously because I'm here. You have an application in the middle and you want to display that. So you want to make sure that you can allocate buffers that will be able to store images from a camera being displayed without having any memory copy in the middle. Of course, that basic use case is a bit more complicated because you do have your camera hardware and your driver, but you have lib camera between your application and the camera. You may even have GStream on top of that. And then on the other side for the display, you may have a graphical user interface toolkit, Q, GTK, whatever, that's going to talk to a compositor, one of the different Wayland compositors. And on the back end, your surface will be directed to a GPU composition or to direct composition by your display hardware through KMS directly, or it's even going to be composited by the CPU in some cases if you really have to do that. So from an application point of view, you don't really know and see how your buffer is going to be consumed, or possibly in some cases exactly how it's going to be produced. Your camera may DMA to the buffer directly. We have a workaround for some platforms where we're missing ISP support in libcamera with the software ISP, so we have the CPU writing the image. And for the application, it's completely transparent. And then if you add your video encoder, your NPU, and other components into the mix, that gets even more complicated, obviously. We shouldn't, it's supposed to be a next slide after that. Okay. We shouldn't forget about a use case where, well, we want to capture an image and just process that with the CPU and do nothing else. So it's not just about sharing buffers between producer and consumers that are hardware, but that can be very simple as well. So a bit of a recap, we do have multiple buffer allocations on the kernel side. So I'm not talking about generic allocation APIs, but things that are suitable to have buffers that devices can DMA to or DMA from. So we have APIs in DRM, and those are mostly driver specific. Each driver will have its own IOCTLs to allocate the buffers. We have APIs in Video for Linux. They are generic. The backend behind them is driver specific. Each driver will select which backend it wants. Does it want DMA contiguous memory? Can it support scatter gather? Will there be an IMMU? And then we have a bit more recent DMA heaps. So that's generic allocators that will give you a DMA buffer object. And the backend behind those is selectable by the user, so by the application user space. Mentioning here UDMA as well, that allows you to wrap memfd inside a DMA buffer object. I'm mentioning DMA buffer a lot because that's the de facto solution today on Linux to share buffers between different components. That, I think, is not going away, and it's not something that we want to reinvent. So everything has to use DMA buffer object. And those multiple APIs are, so they're based on standard IOCTLs, device-specific IOCTLs. In a later case, it's more complicated, obviously, to use from generic applications. And they also focus specifically on the needs of the device they cater for. So Video for Linux, what it will allocate a device for a camera, will not take into account GPU tiling. We have nothing in the API that would take that into account. Same thing on the DRM side. DRM will make sure that, or whatever DRM driver you will have APIs that make sure that the buffer will match the needs of your GPU for rendering or of your display engine, but without thinking too much about the camera side. We have some relevant prior art, and there's a bit more than that listed in the slides from James. In Userspace, so we have GBM, part of Mesa, and the mini GBM, part of Chrome OS, that are Userspace libraries that will allocate buffers for you, but those are mostly targeting the display use cases and the rendering use cases, not so much certainly for GBM, not on the camera side. We have Graloc on Android, which does pretty much what we're trying to do today, but in a way that can't really be replicated to a generic system, because Android expects system vendors to provide a Graloc implementation for their systems. And so that implementation knows what devices are present, know exactly what GPU, know exactly what camera, what video encoder, and the constraints of those devices. So the API exposed by Graloc is relatively high level, and when an application will say, I want to be able to capture an image from a camera, a buffer to capture an image from a camera, Graloc will know that the camera hardware has these requirements. While on a more generic system, if you want a more generic API, that will not be the case. You can't have, you can't ship a standard element in Userspace today that will run on random Linux systems without knowing what's in there that will make the right decision. EGL streams, they kind of solve part of the problem as well. It's a Kronos API, but not really something that I think can be leveraged. There's a big memory allocation API in Vulkan. That's a big part of Vulkan, which is the reason why people say that to draw a single triangle in your first Vulkan program, you need 1,000 lines of code in your application. So that's fairly complicated, fairly low level, matches the needs of display and rendering fairly well, but again, not a generic component that today can be leveraged as such. So the question is, what do we do? I've brought up this topic because this is something we face in libcamera. We have support, we have designed the API in libcamera to be centered around importing buffers. So we say the application should have a buffer and give it to libcamera so that we can capture an image in that buffer. And if your application today wants to render something and gets a buffer from the display side, assuming that it gets a buffer that can be DMA'd to on the display side, most likely the camera will be able to access it at least in the system we've been working on, but there's absolutely no guarantee. So it kind of worked by chance. I don't know what percentage of the time. But if your application just wants to capture images from a camera and save them to a file, we didn't want to force those applications to go and find a source of a DMA buff somewhere, so we kind of have an allocator API in libcamera today. And I think that's bad because every framework, every kernel API, every framework, because we don't want to force users to get something from another place that doesn't exist, there's no central allocator, we duplicate all that work everywhere. Every kernel API, Video for Linux, DRM, have their own allocators. libcamera has an allocator. We have, well, GBM in Mesa for the display use cases. So we do lots of duplication there. And we would like, from a libcamera point of view, to see that fixed, because we're running into issues with cache management, with allocation, and things like that. I described the problem space, memory allocation, that's the one I'm the most interested in. And then there's the negotiation of the formats and strides and different constraints when it comes to the layout of the image in those buffers. That's a secondary, from my personal point of view, at least a secondary goal. I think it's important, but less urgent for me. And the question is, who would like to see this addressed? Which small subset of that group would be willing to contribute, and how we could make that happen. So there will be a session about this at XDC next month in October, for those of you who plan to be there. But is there anyone in the room today who's interested in this topic, thinks it's worth working on, has ideas, would have an interest in working on that? So, question is for the room now. Microphone?
I think it would be very good to have this for interoperability to help Userspace to allocate memory, but I have no time to work on this.
Okay, so you're part of the first group. You want to see this fixed, but you want to do it yourself.
Yes.
I am part of the best group. I want to get it fixed, and I think I know who can help you on doing this. That means I don't have to do it.
Okay.
I think Thomas and Ricky are your two people to talk about this.
Okay.
So I have a query. As part of your presentation, you mentioned Android is supporting, there is no limitation, right? All the subsystems are supported by the Android.
So Graloc in Android supports all the Android use cases. So you ask it for a buffer and you say, I want a buffer that the camera will write and that the display will read and that the CPU will read sometimes. Rarely, but sometimes. And then it will give you what it thinks is the best buffer and the best format for that.
Correct. So already there is a base which is working well, right? Can't it be taken as a reference to adopt here? Because the other models, whatever you mentioned, is only rendering related use cases.
So from a functionality point of view, yes, that is something that can be done. I mean, we're looking at the feature set because we want, basically we have the same goal. But the big difference is that that component in Android being shipped by the system vendor knows about the devices you have in the system. And so it can make those decisions based on that knowledge. While if we want to have a generic implementation, a generic solution that works in Linux in general for all vendors, we will need somehow to have a component that will be able to learn about those constraints of the different devices. So we'll probably need something a bit more complex, where the application, knowing what it wants to do with the buffers, knowing which devices or which frameworks the buffers will be produced by and consumed by, will need to interrogate those to get a set of constraints in some form that he can pass to a centralized place that will resolve those constraints. The constraints will ultimately come from the kernel, I assume. We may need help from the kernel for constraint resolution as well, and then allocate the memory from the right place based on the resolution of those constraints.
Let me just understand one thing. You are talking basically about a user space library, eventually, of course, with kernel support, right? Or are you talking about some other subsystem in the kernel? What is your idea on that?
So I'm approaching this from a libcamera point of view because I would have loved to develop libcamera without having an allocator and only importing buffers. And we felt the pain of having to have an allocator. And so I don't want the next framework to have to do the same. And I would like the allocator and libcamera to be removed in the long run. So I'm looking at all the subsystems. We need something that will work for everybody. That's kind of the goal.
But this can still be like what we have libtrace. I mean, we could have a very low-level library on user space that Mesa, libcamera, and others would be used, or it could be something at the kernel, or it could be both. So what are you thinking about?
We could look at both options. That's interesting. I think it should be indeed a shared library in user space that different components can use. My view of that is that it would mostly be used either directly by applications or at least by frameworks, where GTK, for instance, would use that library to offer buffers that can be used. So you may, because this is going to be a fairly low-level API and maybe a bit more complex to use, maybe we'll have toolkits that will help using it. But I think my goal, at least, is to be able to remove allocation from libcamera. So libcamera would only import buffers, and so libcamera would not use that library, at least to resolve constraints and allocate the buffers, because I don't want it to allocate them. It may use that library, a part of the system, however, when the application will ask libcamera, okay, for this particular camera, if I want to capture images in memory, what are the constraints that need to be matched? And those constraints will likely be somehow opaque to the application. It's going to be something that it will get and then have to pass to the centralized allocator. That's the way I would see it. But of course, defining those constraints in a way that's standardized is something that's fairly complicated. James has more details on a proposal. He centered it a bit more, I think, on the format negotiation. But I think that the allocation is also a goal there, and so there's in the slides there's more information about a few C structures and ways to express some of the constraints. Some of the constraints are very easy. Do you need contiguous memory or not? What is the alignment of the stride that you need, things like that. And then you get into areas where you have vendor-specific constraints, and you have devices where you're going to capture YUV images in 2 planes, and the Luma plane has to be in one DDR bank, and the Chroma plane in another DDR physical bank, and things that can get fairly crazy. We've seen that more in the past, fortunately less these days. But I'm sure that if we design an API and release something that will only use simple constraint because it's all we're seeing, the next day we'll have complex ones from the vendors. But that's life. So something that's extensible with new set of constraints will probably be needed.
One more question. Between source and destination, if there are different alignment requirements, allocator library, whatever you are talking, that takes care and give the feedback to the source if there is a misalignment.
That would be the idea. This centralized component would say, okay, if you want to capture from the camera and then encode, this is the alignment on the stride that you need to have, for instance. Go ahead.
James?
Can you guys hear me in the room?
Yes.
I just wanted to say, for the constraint stuff, I think there was some, besides the presentation you linked, really with Simon Serra did a lot more work to formalize that into an action proposal, I think 2 or 3 XDCs ago, and there's a slide deck and some header sample code about that defines or attempts to define the vendor agnostic way to express the constraints. And one of the big open questions there was, where do you resolve those constraints? Is it in user space, or should they be pushed down to the kernel? I'd always initially assumed the kernel, but then Simon Serra kind of talked me into the user space option being valid too. But then the question is where you dispatch it to for actual allocation, and that it's complicated. That's a big open issue.
Hard one. Do I understand correctly, you'll be at XDC next month?
I will be, yeah.
Any other feedback on these? Yeah, Hans?
I guess if you really want to support all the random vendor-specific cases as well, then I can't think of any other way than that you, the allocator would have to have knowledge about the devices involved and ask those devices specifically. So make a proposal, is it working? I suspect it might be extreme. So I remember at the DMA, when DMA buff was first initiated, I was actually, was it also from Bloomberg? I don't know. I was at the same room as well. And DMA buff is kind of ignoring all this, right, today. So I think we had a very short discussion there as well. My idea was, oh, what requirements do you have? Contiguous, scatter-gather, weird. So the first two would be easy, and now we have some additional requirements as well. But vendor-specific is really hard. And would it be worth all the effort? Another question, by the way, because for video for Linux and DRM for that matter as well, you also have to synchronize, depending on the format. So when you allocate, you want to say, okay, you want a buffer, then they also, presumably somehow you either need to pass that format or you use the currently defined format. And the only way I think you can implement this is if you actually can go to the devices themselves and say, okay, this is, you can, for example, you ask DRM first and then say, this is the proposal from DRM, and then Video for Linux will say, oh, well, yeah, close, but no cigar, but let's try this, and perhaps go back. I have no idea. This is it's very complicated method, but trying to support everything, all the weird stuff, I'm a little bit skeptical about that, whether it's worth the effort or whether we should just go to a decent set of features, and if you can't support that, then you have to do it on your own. You have to figure it out yourself.
Good questions. When it comes to going to the device, I think we'll have to indeed to get the constraints from the devices, possibly also for the constraint resolution. It's not entirely clear, but certainly it's the device. Ultimately, it's the device driver that will know about the constraints. That's where the knowledge needs to come from. I hope that we would be able to split the two and handle the two problems of format negotiation and buffer allocation separately. So first negotiate a format, saying, okay, I end up having this pixel format, this stride, because I know that's going to work. And then after that, we get to the allocator saying, okay, now allocate a buffer that's suitable for those with the size that's needed for that. I'm not entirely sure if that will be the case. If we have to combine both and handle both at the same time, it becomes even more complicated. I think at the end of the day, we'll have to experiment with something and see how that goes.
At least part of this we have already on GStreamer. I mean, it already does all these negotiations with different devices and even on different parts of GStreamer itself, in terms of format negotiation, in terms of stride and things like that. So at least part of this you already have somewhere. So maybe it would be a matter of just picking those parts of the code and placing on a library.
That's a very good idea.
Yeah.
We do have indeed negotiation of capabilities between pads in GStreamer, so we could look at how it's done and either get inspiration from that. I'm not sure if we'd be able to reuse some of the code because I assume it's kind of tied with the rest of GStreamer, but at least looking at how it's done and see what concepts they have there, that could be useful.
If my memory serves, and I might be wrong, it might have been changed. I think GStreamer is always allocating the buffers from DRM. So if Video for Linux would have more strict requirements, then it would fail. But this may have changed. So this.
No, I guess it's changed.
On the allocation side, indeed, it would do that on the consumer, at least by default. I think maybe you have. I don't know exactly how it's working today, and things may have changed indeed. But when it comes to resolving constraints, what is the stride that is needed? That is something that I think GStreamer does, and using a pixel format that will work for all the components. That is something that GStreamer does.
I have to touch on this code once when we are trying to do some DMA buff implementation. That was back in Samsung days, so it was like 7 years ago maybe. But I do remember that it does a negotiation. It gets all the information it needs from both DRM and Video for Linux side. So from the query point of view, it will have everything there. Of course, it has its own instructors inside the GStreamer. You won't be wanting all that complexity on your library, but that part is solved. Maybe the only part that may require is about SCADA gather or continuous memory, so this is a little bit more.
Yes. I mentioned the DMA heaps that we have in the kernel today. I think that could be a way forward. Today we only have in mainline, I think, 2 different heaps, so that's fairly limited, but I think that will grow. And so using that as the backend allocator would probably be possible, but we'll need to resolve constraints to make sure we select the right heap with the right parameters. It's missing a few things, like there's no accountability on the memory that you allocate, but VFL2 has the same thing. If you have C groups and if you have limits on the memory that an application or process can allocate, that is not enforced by buffer allocation in Video for Linux or in DRM. Neither it is in DMA heaps, but I think that could be fixed. And it would probably be easier to fix that once in DMA heaps than having to fix it twice in DRM and VFile. So I think centralizing allocation around DMA heaps would be a good idea, but we still need to know what heap to use with what parameters.
Right now, between graphics and display, GBM defines set of formats. But defining one more allocator, right? It can bring its own set of the format definitions, right? How they can coexist?
That's a very good question. That's one of the reasons why I think GBM isn't a solution as such today, because it caters for the needs of graphics and rendering. Could it be extended with additional formats? Certainly. I mean, probably going to be a bit of work, because when we look, I think we looked at YUV allocation, buffer allocation in, was that in mini GBM or in GBM itself? Yes, and that's, I mean, the code was clearly meant for the graphics side, so we would need, but that's a technical problem. Even if we have to refactor and rewrite lots of things internally, that's a technical problem. But I'm not sure what else than adding new formats would be needed there, but it's something we can definitely look at.
I think it's designed around the DRM format, so that when we look into that for YUV formats, we would have need to go through DRM people, convince them that YUV, I think, was a suitable format, wasn't needed, and they don't need that for graphics. So we have to define, in this case, I think a superset of the format that GBM currently support will be needed.
NB12 is one example, right? Yeah.
I don't recall, but there are some formats that are missing, certainly. There's some limited YUV support, I think, for some formats that are relevant to graphics. But James raised his hand.
Yeah, I just wanted to say, I think Weird. DRM, I think, and the graphics side of this has defined a pretty good method with the format list, which is just incomplete for other subsystems. And the format modifier mechanisms for like negotiating the format and the layout of the buffer for that format in memory. But it all falls apart if you don't want to use very simple layouts. And if you want to do anything like device locality, because all the allocators that GBM is defined in terms of allocating for one graphics device, and specifically graphics devices. If you want to allocate for even like a thing that's not a graphics device, like a display or a video code or anything like that, it's just not the right API yet. It does do a great job of allocating graphics buffers for a device.
Yeah, I agree. Any other input from the room, or do we call it a day?
We can call it a day, but just to mention that one specific pain point was also mapping formats between the camera side and the DRM side. We got issues there because, well, the format definition is different, but the concept here is the same, but there might be things in the middle that requires you to do the mapping in a device-specific way.
Yes, and VFOL2 and DRM both use 4CCs to define pixel formats, and then you have identical formats that use two different 4CCs on the two sides, or different formats that use the same 4CC, and it's always great. Like you call RGB 24 in VFOL2 is actually BGR888 in DRM, and it's just that causes lots of headaches.
That's hard to fix right now, because I mean, they grow and separate, so.
Yes, we have a big table that converts between the two in libcamera, and that has been tested. So if you ever wonder which DRM format corresponds to what VFOL2 format, look in the libcamera source code. That is a source of truth at the moment.
Maybe we need a unique definition of 4CCs in Linux that.
What's the number of the XKCD? When we need a new standard to.
Yeah.
There are other relevant standards, actually. There's a Kronos standard that's called the Kronos Data Format Specification, I think. So it's not about pixel formats as 4CCs, but it's about describing the exact layout of a pixel format, and that takes hundreds of bytes to do the description, but that is standardized. So it's not something that could be used as a format identifier towards components, but it's fairly useful if you want to clearly describe a format in a way that's possible by a machine. But it's oriented, it's meant for graphics because it's Kronos API. Kronos is mostly so far about graphics. It's going to change a bit with the work we're doing there for cameras. So that spec could possibly be extended at some point. It could be part of the solution, but not as a format identifier, probably. All right, 3, 2, 1. Thank you very much. Thank you, James, for attending.
Where should I place this thing? Maybe here.
Yeah, I suppose. Yeah.